Alright, so before we move on, we first of all need to install two things. The first one is Node.js. Now to download Node.js, just go to this website nodejs.org and then it's download section /en/download. Now depending upon your operating system, you need to install Node.js. Like for example, if you're using Windows 32-bit operating system, just simply click on this thing. And now if you're using Windows 64-bit operating system, just simply click on this thing. And now similarly, if you're using Mac, just simply click on this thing. Similarly, if you're using Linux, just simply click on this thing right here, and it will start downloading Node.js on your computer. And now I will be using Windows 64-bit operating system in this course, so I need to click on this thing right here. But I'm not going to click on this link because I already have downloaded Node.js on my computer. But in your case, just simply click on any one of these links to download Node.js on your computer. And once it is downloaded, just go to the download section to install Node.js on your computer. Okay, so it is actually a very simple process. Just simply click next a couple of times and it will be successfully installed on your computer. And once it is installed, you can just simply open your command line and start writing down your JavaScript code. But it's going to be really difficult for you in that way. So what we're going to be doing is that we're going to be using an IDE to write down our JavaScript code. Now, you can use any IDE or integrated development environment of your choice. Like, for example, you can use Sublime. You can even use Notepad++ if you want. But the one I'm going to be using is the most popular one, and it is known as Visual Studio Code. Now, again, depending upon your operating system, you need to download VS Code as well. Like, for example, in my case, Windows, I need to click on this thing right here. And now if you're using Linux, just simply click on these things depending upon your operating system. And now similarly, if you're using Mac, just simply click on this thing right here and it will start downloading VS Code on your computer as well. And once it is downloaded, again go to the download section and then just simply install VS Code on your computer as well. So again, it is actually a very simple process. Just click next a couple of times and it will be successfully installed on your computer as well. And once it is successfully installed, you can actually open it like this by searching it in the start menu and then just opening this thing right here, which is Visual Studio Code, which is basically its app. So once you actually open it, it will actually open this screen right here. Now in here, you can actually create JavaScript file, you can create HTML file, CSS file, whatever you want. You can open a file, you can actually open folders, you can actually create folders, whatever you want to do in this IDE. And this is what we're going to be doing in the coming videos. We're going to be creating files. We're going to be actually creating folders where we're going to be putting our files and images and all things we need in our JavaScript. Okay, so this is what we're going to be doing in the coming videos. So for now, if you have any problem downloading Node.js or Visual Studio Code, then just let me know and I will get back to you as soon as possible. Now, the next video, thank you for watching and I will see you guys next time.
Alright guys, in this video I'm going to be teaching you guys the difference between thread and a process. It is very important to understand thread with process because both are very much the same thing, but at the same time there are some key differences between both of them and we're going to be covering these things in this video. So let's get started. Alright, so first of all, let's understand a very common term, that is a process. Well, a process is simply any program under execution or in the running mode. But you might don't know that the process can run independently and do not share memory with each other. And therefore, the operating system treats all different processes separately. For example, even you open 10 same processes, then it is same for you, but for the operating system, they are all different processes because operating system is treating each process a different process. So for example, if you open a program MS Word, then that program is known as the process. Now let's say if you open MS Word 10 times, then for operating system, it is 10 different processes. Now similarly, if you open a Google Chrome browser, then it is also a process and if you open a game, then that game is also a process. Okay, now let's see what is a thread. Well, thread is also a process, but it is a lightweight process and it is executing within a process. So we can say a process can contain single thread or it may contain multiple threads as well. So a process may contain 1 or 100 or even thousands lightweight processes inside that one process, and we call all of these lightweighted processes as threads. So consider the same example in MS Word, which itself is a process, but inside Word we have many lightweighted processes. Like for example, one thread is auto saving the document while you are typing the document, while on the other hand, at the same time, there is one more thread which is checking for spelling mistakes. And there are many other lightweighted processes or threads inside MS Word. And when there are many threads running at the same time in a process, we called it as multi-threading. So multi-threading is when you have multiple threads executing at the same time inside a process. Okay, so now you know what threads and a process is. Now let's cover some differences between both of these things. So process is a heavyweight process while a thread is a lightweight process, and therefore processes require more time for context switching as they are more heavy, while thread requires less time for context switching as they are lighter than processes. And also communication between processes require more time than between threads. And then processes require more resources as they are heavy, while threads require less resources than processes because they are lightweighted process than a process. And then as I told you in the start that processes do not share memory with each other, while on the other hand threads share memory with its peer threads. Now there is one more thing that you often come across while learning threads, and that is the main thread. Well, main thread is nothing but a process. So we have the main thread and then there are many lightweighted threads inside that main thread. Alright, so there are three ways we can create a thread in Python. We can create a thread in Python using a function, and then we can create it by extending the thread class, and then we can also create it without extending the thread class. So we will be implementing all of these three ways in Python in the coming videos. So yeah, that's it for this video. In this video we covered the difference between thread and a process. So if you have any questions, feel free to contact me through email and I will definitely get back to you as soon as I can. So up till next video, thank you for watching and I will see you guys next time.
Now, in this video, I'm going to be talking about the difference between asynchronous versus synchronous. And by learning the difference between both of them, you will actually understand what actually asynchronous and what actually synchronous mean in computer programming. So let's just first cover what actually is synchronous in programming. So synchronicity in programming happens when the execution of operations is done sequentially. So an operation will only be executed after the previous one is done. This means that a potential complex task may take a while before all its steps are executed and completed. So synchronous tasks are done in a single thread. So just imagine, let's just understand synchronous programming with an example, and just imagine that when a person is alone preparing a meal, they will have to do all the tasks by themselves, and some steps require food processed in previous steps. Well, you can rearrange the order slightly, but some steps have a fixed order. Like, for example, you can only mince a carrot after you have unpeeled it. That is quite obvious one. Now, let's just understand what actually is asynchronous. So asynchronous processing is done in parallel, means that in asynchronous, multiple tasks are actually happening in parallel, or you can just say at the same time. So since tasks are not dependent on others, so they can be actually executed at the same time as one main process or operation. So each asynchronous task is done in a different thread that reports back to the main thread with the result when it is actually completed. So all the tasks in asynchronous report back the result when they are done. And again, let's just understand asynchronous by having the same example. So let's just say that you add another cook to the kitchen that will allow you more time efficiency. So for example, when one person is taking care of chopping vegetable, another person can start making the sauce. And let's just say that you add another cook as well who can prepare the meat while the other two one are working as well, and so on. Now there are some steps that needs to happen in sequence. The summary of the dish after every ingredient is prepared is an obvious one, but others can be carried out independently to speed up the process. So I hope that you now have understood the difference between synchronous and asynchronous programming. Well, actually, you will understand the difference between both of them more accurately once we move on to the coding part of asynchronous programming. But now, since you have understood the basic difference between synchronous and asynchronous programming, my question to you is that is JavaScript synchronous or asynchronous? So just pause this video for a while and just think about it. Okay, so let me just answer this question. So by default, JavaScript is actually synchronous. That is, each task in JavaScript is executed sequentially, means that the second task cannot be executed after the previous one is done. Means that, in other words, I can just say that the third or fourth line of code cannot be executed before the first and second line of code. So that is why JavaScript by default is synchronous, but actually we make JavaScript asynchronous with callbacks, promises, async await, and other built-in functionalities in JavaScript. So I hope now well, actually this question will actually make more sense once we actually move on to the coding part of asynchronous programming. And I'm going to basically show you the synchronous and asynchronous examples once we move on to the coding part. Okay, so yeah, that's it for this video. If you have any problem understanding the basic difference between synchronous and asynchronous programming, then you can just let me know. You can just directly message me and I will get back to you as soon as possible. For now, thank you for watching and I will see you guys next time. Okay, now in this video, I will be coding an example of synchronous programming. So let's just say that I will have some console.log like 5 or 6 times, and in here, let me just add a space right here, and then just copy it. So copy, and then let's just say I'll just paste it 3, 4, and then 5 times. And in here, let's just say that I'll just say that 5, and then in here I'll just say um I am making an ice cream. Okay. So I am making an ice cream. Okay. So now just save it. And since we are just running it on our console or console screen. So to open your console screen, if you're using this code, just simply click right here and then just click here on terminal. And now since you want to run script.js, just simply type node and then script dot js, hit enter, and you can see that we're actually seeing this output. I am making an ice cream. So you're seeing that it first of all executed this line of code and then this line of code and this one and then this one and then this one, because JavaScript is actually running the code from the top to the bottom. So let's just say that if there is some problem, let's just say with this line of code, then the entire execution will stop. So this is an example of synchronous programming. That is, the code is actually running from the top to the bottom. That is, this line of code cannot be executed before this line of code, because JavaScript is actually executing it sequentially from the top to the bottom. So let's just say that I've just I just changed the order. So let's just say that I just add this thing right here. And now this sentence is actually not making sense. I am ice cream making an, but if I just save it and run it again, the same script file, you can just see that JavaScript doesn't care. It's just saying I am ice cream making an, because JavaScript doesn't care what actually I'm executing JavaScript doesn't care that if I have to make sense as well. It doesn't care about this thing. It just simply execute the code from the top to the bottom sequentially. That is, this line of code cannot be executed before these lines of code. And then similarly, this line of code cannot be executed after these lines of code. The code will be executed synchronously, one after the other. So now you can just say that by default, actually JavaScript is synchronous. So in here, let me just add a comment right here and just say that this is actually an example of synchronous programming. Okay, so this one is an example of synchronous programming in which the code is executed one after the other sequentially. Okay, so now in the next video, we'll just do an example of asynchronous programming. Okay, let's have an example of asynchronous programming. So in here we have console.log 5 times, which is saying that I eat ice cream with a spoon. Okay, so now let's just say that we will add a set timeout function, which is an asynchronous JavaScript function. So now right in here, I'll just say that set timeout function. And now in here, the first thing that will pass out is a function will be basically an arrow function, and this arrow function will be executed after, let's just say, after a certain amount of time. And let's just say that it will be executed after 4 seconds. So it actually takes a time in millisecond. So this 4000 actually means 4 seconds. Now for the first argument, we'll pass a function, and this function will be an arrow function. So now right in here, we'll just pass an arrow function. And now for this arrow function, let's just say that it will actually execute this line of code. So I'm going to basically cut it right from here and I'll just paste it right here. Okay, so now what I'm going to do is that let's just say that I will just add it right here. So now just save your code. Okay, so now what I'm actually doing is that I'm just saying that I eat and I'm just adding a set timeout function which will actually execute this line of code, which is ice cream. So I eat and then with set timeout function, I'm just adding console.log ice cream and then console.log with a spawn. Okay, so now let's just first of all see how it will be executed. So now just save your script and now let's just execute it by just saying that node and then the name of this file, which is script.js. Okay, now hit enter. Okay, so it's saying that I eat with a spawn because we have instructed JavaScript that this line of code will be executed. This function, that this whole function will be executed after 4 seconds. And after 4 seconds, it actually says that it is an ice cream. Okay, so now how actually this whole thing is working behind the scene. So for this, I have this thing in my notepad. Okay, so basically this whole thing is actually this whole program, this whole JavaScript program is actually a main process, or you can just call it as a main lane. So first of all, in the main lane, it executed this line of code, I, and then it says say eat. And then since it is an asynchronous call, so what JavaScript will do is that it will actually create a new thread, which will actually be the part of this main thread, but it will be executed separately. So what JavaScript will do is that it will actually take this whole thing, basically this whole set timeout function, and then we'll put it in a separate lane. So in the separate lane, this thing will be executing while the main thread will be executing parallelly, parallel to basically this a small thread. So since it will take 4 seconds while the main thread is executing as well, so it will continue to say with a spawn, and then after, let's just say after 4 seconds, when this process has actually been executed, then what it will do is that it will actually report back the result to the main lane or to the main process. So in here, first of all, it executed I, and then we just printed out it, and then we just added an asynchronous function, which will actually move to the separate lane or a small thread, which will actually be the part of this main thread or this main program. So it will be executing at the same time, while in parallel, our main lane will also be running. So since it will take 4 seconds, it will then report back once it is completed. So, and then it will say with a spawn, and then after 4 seconds, this line of code will be executed. So it will actually report back, and then you will just see this result right here. Okay, so let me just execute this code once again. So this thing and then this thing, this whole thing is executed while the small thread is not yet been executed. And now it has been completed after 4 seconds and it has actually reported back with this result, basically this whole function. Okay, so I hope that you now have understood this set timeout function and how actually how it is actually working in an asynchronous mode. So this was an example of asynchronous programming. So I hope it is making sense. And now in the next video, we will actually move on to make an ice cream. Basically, we'll follow all these steps that I've shown you previously, all these steps, and we're going to be covering it with callbacks, promises, and async await. Okay, so let's have a simplest example of callback, and then I promise we will start making an ice cream. First of all, with callbacks, and then with promises, and then with async await. But first of all, let's have a simple example of callback so that you actually understand what actually a callback is. So, in simple words, when you call a function inside another function, that is a callback. In other words, we can just say that when you nest a function inside another function as an argument, that is called a callback. Now, what is the purpose of callback? So what callback do is that it forms connections between functions. Okay, so let's just first of all, it actually forms connection between two or more function. So let's just create two function. So the first function we'll just name as one, and we will just say that console.log. We will just say that step one. And let's just create another function. And we just need to change its name right here. And then we just simply name to change it to step two. Okay. So now, first of all, let me just call the first function and let me just call the second function. Okay, so now let's just execute this code with typing node and then script.js, hit enter. Okay, so as I told you that JavaScript runs from the top to the bottom. So since I call this function one for the first time, first of all, that is why it executed the first function first time by just printing out this thing on the console screen. And then actually we call this function. So that is why it is printing out this thing on the console screen. But if I just reverse the order, then what you will do is that you first of all execute the second function, which is step two, and then the first function, which is step one. Okay, so now as I told you that callback is actually used to form connection between function. So in here we have these two function, and now what we'll do is that we'll actually form a connection between them using callback. So right in here, this function will actually receive actually another function. And in here, I will just name it as call underscore two. Okay, so now in here, after this thing, we will just call basically this function that we have passed, this function as an argument. Because let me just repeat the definition of callback. When you nest a function inside another function as an argument, that is actually a callback. So in here, we're actually passing a function to this function as an argument, which will be received right here in this. And now we just need to call this function, which is receiving this, which is actually receiving in here in this variable called to. And since it is a function and we need to call it, so that is why we actually need these two brackets. Okay, so now what we will do is that, let me just get rid of this thing. I will just simply call this function one, and then what I will do is that to this function, since it is expecting some kind of argument, and what we will do is that we will actually pass this function, this whole function, as an argument to this function. And in this way, we'll form a connection between these two functions. So in here, this function which we are passing to this function right here will be received in this variable right in here. And then in here, this one is actually doing basically printing out this thing on the console screen. And then what we will do is that we can just add some addition by saying we can just put some addition by saying that step one is completed. Please call step number 2. Okay, so now in here, we do not need to call this function because this function, we are actually calling this function right in here inside of this function. And now we can just say that we're actually calling a function inside another function, and that is actually a callback. Okay, so now let me just save it, and now let me just execute on this thing. And now you can see that it is saying that step 1 is completed. Please call step number 2. So first of all, as I told you that JavaScript execute from the top to the bottom. So I just call this function 1. So first of all, it just encounter this line of code. So it actually prints out this thing right here, and then it actually called this function. So since this function is actually printing out this thing, so that is why it just print out this thing right here on my console. But if I just reverse swap these two lines of code, and then here I just paste it on this thing right here. Now what it will do is that it will first of all call this function, and this function is actually printing out this thing on the console screen, and then it's gonna execute this line of code. Okay, so now just save your script and execute it once again. And now you can just see that it first of all prints out this thing, and then it is actually printing out this thing on my console screen. So that is actually a callback that is calling a function inside another function. That is the simplest example of callback. And now what we will do is that we will actually implement implement callback with our ice cream example. Okay, so now from this video, we will start making an ice cream using callback. So now you can just see that in here, there are like several steps involved in making an ice cream. Now what we're going to do is that we're going to form the connection between all these steps because these steps are actually interconnected with each other and cannot be executed without each other. So what we're going to do is that we're going to form connection between all these functions, all these steps using callback. So for the ice cream business, we first of all need to form the connection between us and the customer. Like for example, we first of all need to get the order from the customer, and only then we're gonna fetch the ingredients and start the production. Because the production cannot be started before the order, and once the production is done, we can then serve the ice cream. So for this, we're gonna make two functions: the order function and then the production function. And we obviously need to form the connection between the order and production function because, as I told you, that the production cannot start before the order. So let's just form the connection using the callback. So let me just minimize it. And now in here, what I'm going to do is that obviously, I first of all need to make the order function, and this order function will be my arrow function. So this one is going to be my arrow function. And then what I'm going to do is that I will just create another function, and this one is going to be my production function. And this one is going to be an arrow function as well. So this one is going to be my arrow function, and yeah. Okay, so now in the order function, once this function is called, means that the order is actually has been placed. So right in here, what I'm going to do is that I will just say that console.log. I will just say that order placed, please call the production. Okay, so the order has been placed. Now you're going to call the production. So what we can do is that when the order is placed, we can call the production function inside of this function, which is my callback. So for this, I need to pass this function as an argument to this function. So right in here, I will just call the order, but I will just pass the production function as an argument to this function order. And now in here, it will be received, let's just say in this variable called production. And once the order has been placed, I'm going to call the production. So in here, I'm going to call this function call production. And since we need to call it, so we actually need these two round brackets. Okay, so what's going to happen once this function is actually called? So this function will actually start the production. So right in here, what I will just do is that I will just say that console.log. I will just say that, okay, the order received starting the production, because once the order has been received, this function is just going to start the production. Okay, so let me just first of all explain this code before I actually execute it. So I'm actually calling this function, but with this function, I'm actually passing this function as an argument to this function, which will be received in this variable called production. So once the order is placed in here, this function is going to be called. So it will just say that order placed, please call the production. And after executing this line of code, we're going to call the production because the order has now been placed, and this function will actually receive that order, and it will say, okay, I now have received the order. I'm now actually starting the production. Okay, so yeah, this was pretty simple, keeping in view that we have done a pretty simple example in the previous video. Okay, so now let's just execute this code by actually executing this script. But first of all, actually saving it and then running it. Okay, so it is just saying that order has been placed. Please call the production, and then it is saying, okay, order received, starting the production. Okay, so now in the next video, we will actually we will move on to complete this ice cream example using callback. Okay, so let's just continue making this ice cream. So while making an ice cream, we have a kitchen in which we're going to make this ice cream. And then we have a storeroom where different types of things like fruits, liquid stuff, machinery, chocolate, and other raw materials are placed on our stock. So what I'm going to do is that I'm going to create a variable in which I'm going to store all my stocks. And let's just create this variable right here at the top. And I'm going to name this variable as stocks. You just name it anything you want. And this will be an object which will contain different things. And then the first thing it will contain is actually the type of fruits. So on our stock, we will have different types of fruits. So it will be an array of fruits. And let's just say that we have strawberry, and then we have grapes, and then we have, let's just say, banana, and then let's just say we have apple. Okay, now the next thing that we will have is the type of liquid that the user wants. So let's just say that there are two types of liquids. The first one is water, and then the second one is ice. Okay, and then the third one we will have is, let's say, the type of holder. We will have different types of holders available. So let's just say that we will have three types of folders. The first one will be con, the second one will be up, not like this. It is actually inside the single quotation mark, so up, and then the third one will be the holder. Okay, and then the other thing that we will have is actually toppings. And let's just say that we have different types of toppings. The user have the option to have chocolate on his ice cream topping, and then the user have an option of having peanuts on his ice cream. Okay, so these are all the stocks that are available in our storeroom, and now in here. Let's just say that while ordering, the user selects any kind of fruit right here. So it will actually go inside the order function. So while calling this function in here, we will just pass the fruit name that the user actually has selected. So it will be receiving this variable fruit name. So fruit name, so I'm actually passing to this order function, the first argument I'm going to pass basically the type of the fruit name that the user has selected from our stock, and then from our fruit list. And then I'm actually basically passing this production function. So in here, when I'm calling it, I need to pass it right here. Okay, okay. So notice here that the customer might take some time while selecting all these things. He might have a hard time choosing either he wants a strawberry ice cream or a grapes ice cream, banana or apple ice cream. And then let's just say that, so actually it will actually take time in selecting from all these things. And in here, let me just show you this time function. So in here, we have assumed that, let's just say that placing the order will take 2 seconds. Now, in reality, it actually takes more time, but for learning purposes, we can assume that placing the order takes 2 times, means that it will take 2 seconds for the user to select from all these things. And let's just say that for simplicity purposes, we can only assume that the user will take 2 seconds to select from this fruit list. So in here, let's just say that the user has selected the strawberry, which is at, so this one is at index number, strawberry is at index number 0 inside this fruit array. So in here, we're going to pass 0. So now, as I told you that the order will take 2 seconds. So now let me just first of all get rid of this thing from here, and let me just get rid of this thing from here. So now in order to manage time, we're gonna basically use the set timeout function that we have used before. And now in here, I'm gonna basically call this asynchronous JavaScript built-in JavaScript function called the set timeout function. And now in here, first of all, I'm gonna pass an arrow function. And now since the ordering of food will take 2 seconds, in here I need to pass this time in millisecond, which actually means 2 seconds. Okay, now inside this set timeout function, and then inside this arrow function that we have inside this set timeout function, I'm going to basically say that since I have this thing inside, I'll just say that, first of all, I'll just say that console.log, and then console.log, I'm going to basically print out the fruit that the user has selected. In our case, we have assumed that the user has selected this fruit, strawberry. So in here, because in here we have passed 0, so this strawberry is at index number 0. So I'm going to first of all say that it is actually inside my, since it is inside my the stock object, so stocks, and then in the stocks, we are actually talking about fruits. And then for fruits, we are actually talking about the 0 index number, this first index, which is at index number, this first fruit, which is at index number 0. And we have passed 0 right from here, and it is actually receiving this variable fruit name. So in here, we just need to type the fruit name. Okay. So now we're going to basically see this thing in action, but just notice here that it just takes 2 seconds for the user uh, to basically select from these a list of roads. Okay, so now just save it, and now let me just execute it. So right in here, I'm going to execute it. So node, and then the name of this file, which is script.js, and make sure that you save it. Okay, so it will take 2 seconds, and now it is actually printing out the strawberry on the console screen. Well, let's just make it more sensible. So in here, I'm going to use this backtick case. Oops, not like this. So I'm going to use this backtick case here. And then I'm going to have this dollar symbol. And then I will have these curly brackets right in here. And now I'm going to say that a strawberry was selected by the customer. Or you can just leave it as it is. Okay, so now let's just execute it once again. And now after 2 seconds, it is saying that the user has selected this strawberry food. Okay, so now we are actually calling after 2 seconds. We are actually, so after 2 seconds, inside this order function, we are also calling this call production function as well. So inside this call production function, let's just put it inside the set timeout function as well. And in here, the first thing I need to pass is the arrow function. And let's just say that it will just take 0 second to start the production. So in here, inside the arrow function, I'm going to say that console.log here. And now let's say that received, order received, starting the production. Okay, so now just save it. And now if we just execute it here, you're going to basically see a trick. So I just execute, and in here you're just seeing that order has been received, and it's starting the production, and then it is saying strawberry was selected. Means that the production has started before the strawberry has been selected. This is because this line of code was executed first, and then it is saying strawberry was selected. So for the user who's actually seeing this output will say that this code is absolutely wrong, because he will just say that how can the production be started before the strawberry type of ice cream was selected. Okay, and this is because we're actually seeing this output because now here I actually need to explain this whole code because it is very important for you to understand. Okay, so in here, once I actually call this order function, and then when JavaScript actually see this set timeout function, it looks that it will actually take 2 seconds for this, basically for this function to execute. So what JavaScript will do, since it is an asynchronous function, so what JavaScript will do is that it will actually take basically this whole thing, this whole set timeout function, and then we'll put it in a separate thread, but it will still be the part of this whole, basically this whole process, but it will be executed separately as a separate thread. So uh, now this thing will take 2 seconds to be executed while the main thread is still running. So this one is actually executing in a separate lane, while this one will be called, because this is actually still in the main lane. This because this one is actually outside my set timeout function. So this will continue to run in the main lane. And since it is taking 2 seconds, so before 2 seconds, JavaScript execute, call this function, call production, and since it is taking 0 seconds, so it actually executed immediately before 2 seconds. And that is why in here we have this thing printed out first. And once after 2 seconds, the small thread actually reports back to the main thread, and then the main thread actually prints out this thing that you are seeing right here on your console screen. So I hope it is actually making sense. Now, how we actually will get rid of this problem? Well, just think about it for a minute. Just pause this video and just think about it for a minute. It is actually pretty simple. You just have to be a little bit smart to get rid of this problem. So just think about it, pause this video and think about it. Okay, so what we can do is that we can actually simply actually cut this thing right from here, and then paste it inside the set timeout function where we have this arrow function. So in here, we're going to basically paste it. And now this call production actually becomes the part of the set timeout function. So when JavaScript will see the set timeout function, it's going to actually take it to a separate thread, and to the separate and then this call production will also be the part of this small thread. So first of all, after 2 seconds, it will first of all execute this thing, and then the small main thread will actually execute this line of code by calling this function call production, and then it will actually print out this thing, and then will print out the result. Okay, now let's just see the result now. So let me just execute node, and then first of all, you need to make sure that you save it. And now after 2 seconds, it's first of all saying that strawberry was selected. And once strawberry was selected, it's saying that order received. And now it is actually starting the production. Okay, so I hope that it is actually making sense. Just know that this call production is now the part of this asynchronous JavaScript function set timeout, and that is why it is actually taking 2 seconds to execute basically these two lines of code. And yeah, that's it. That's it for this video. I hope it is making sense. If not, then watch this video again. And still if it's not making sense, then just directly message me and I will just get back to you as soon as possible. Thank you for watching. I'll see you guys next time. Now, in this video, we will continue making our ice cream, and the next step after receiving the order is to start the production. And then the first step in the production is to actually, let me just show you, is to first of all chop the fruit, and say that it will actually take 2 seconds to chop the fruit. So we're going to add another set timeout function, and we're going to tell that basically I'm just giving you 2 seconds to chop the fruits. So now let me just minimize, and now you need to make sure that you just add that set timeout function inside the arrow function of the set timeout function, because if we just add that set timeout function outside the set timeout function, then what can I do is that it's going to basically start the production before strawberry was selected, as you have seen previously. So right in here, you need to make sure that you just add the set timeout function right here. So I'm going to add set timeout, and in here, the first thing is obviously my arrow function. So my arrow function right in here, and then in here it is actually taking 2 seconds to chop the fruits. So right in here, I will just say that it will just take 2 seconds, and then in here, I'll just say that console.log, um, and after 2 seconds, the fruit will be chopped. So I'm going to just add the statement right here and just say that the fruits has been chopped. Okay, so now let me just execute this code, but notice here that once it comes to this production function, we are actually calling this production function inside the order function. So once you actually call this production function, first of all, it will actually take this set timeout function. And since this set timeout function will take 0 seconds to start the production, so we're going to see this thing immediately on our screen because it is actually taking 0 seconds. While this set timeout function, so after this line of code, it will again see this set timeout function, which is a built-in asynchronous JavaScript function. So it will just see that, okay, I need to take 2 seconds to print this thing on my console screen. So again, after this line of code, it will take 2 seconds to print this thing on my console screen, in which I'm just saying the fruit has been chopped. Okay, so just save your script, and now let's just execute it right here. So script dot yes, hit enter, and it would first of all take 2 seconds for the user to decide strawberry has been selected, and then it just print this thing immediately because this side timeout function is taking 0 seconds to print this thing on my console screen, and then this set timeout function, which is actually inside of this set timeout function, is actually taking 2 seconds for the fruits to be chopped. So we're actually seeing this thing after 2 seconds. Okay, now, the next thing in preparing this ice cream is to add water and ice. So right in here, after the fruit has been chopped, we're going to add another set timeout function because it is taking some time to add water and ice. So set timeout function, and the first thing we need to pass is basically our arrow function. So arrow function, and then the next step. So say that it will take 1 second to add water and ice to our ice cream. So in here, I will just type here 1000. It actually mean 1 second. Okay, now right in here, I will just say that console.log. And in here, I'll just use this backtick keys because in here, I just need to render something. And then dollar sign and then these brackets. And since inside my stock, you're going to see that we have two types of liquids available, water and ice. And I actually need to add both of these things to my ice cream, which is actually in my stock object. And then this array liquid, and then water is at index number 0, and then this ice is at index number 1. So first of all, I'll just say stocks dot liquid, and here I'll just do it. So stocks dot liquids, and then the first thing I will add is basically this thing, and then I will just say that and the other thing I need to add is basically again inside my stocks dot liquids, and then this one is at index number 1. Let's say that has been added, and just remember that it will take 1 second to add water and ice to the ice cream. Okay, so now we can execute this code once again, but first of all, you need to make sure that you save it and let this execute. Okay, so first of all, it will take 2 seconds, and then production will start immediately. And after 2 seconds, the food will be chopped, and then after 1 second, water and ice will be added to the ice cream. Okay, now let's just see what is the next step. So the next step is to start the machine. So starting the machine will take 1 second. So let's do it. So right in here, after water and ice has been added, we're gonna add another set timeout function. So let's say that set, it's not set interval function, set um, timeout, and here we'll just add this arrow function. So arrow function, and then say that it will take 1 second to start the machine. And then I will just say that console.log, and I will just say that the machine has been started. And yeah, that's all I need to do for this thing. So just remember that it will take 1 second to start the machine. And now we can actually save our script once again and execute it. So let's just run it, and it will just take 2 seconds. And then production will start immediately. Water has been added, and the machine has been started as well. Okay, so let's see what is the next step. The next step is to actually select the container. So we actually have uh, basically for the container. Okay, so right in here, let's just add this container as well. Let me just scroll it down. Okay, so after the machine has been started, we're gonna add another set timeout function, and basically selecting the container will take 2 seconds as well. So in here, I'm gonna add another set timeout function. I'll just say that set timeout, and then the first thing I need to pass is basically an arrow function. So this arrow function, and it is actually taking how many seconds? Let's just see. It is taking 2 seconds to select the container. So in here, I will just add 2 seconds. Okay, and now in here, I'll just say that console dot log, and in here, what I'm going to do is that for in here, I will just say that the holder, basically container actually means holder. Let's just say that I will just select this one, cone, but you can select cup or stick or whatever you want. But I will just select cone, which is inside my stock object, and then this array holder, and then this cone is at index number 0. So right in here, I will just say that right in here, I'll just again use this backtick keys, and I will just say that ice cream placed on holder, and then I need to basically use this dollar and then this thing, and then stocks dot holder, and then since I'm just selecting the cones in here, I just need to type 0. So ice cream placed on holder, uh, holder cone. Okay, so it will just take 2 seconds to place ice cream on this cone holder. Okay, so now just save your script and run it once again to see if it's actually working or not. And first of all, taking 2 seconds, food has been chopped, water has been added, machine has been started, and it is saying that ice cream has been placed on holder cone. Okay, so now let's just see what is the next step. And then the next step, let me just show you this time function. The next step is to select the topping. So say that for the toppings, you can see that we have multiple types of toppings. We have either chocolate topping or we can have peanuts. But let's just say I will just select this chocolate. So again, this is actually inside my stock object, and then there's array topping, and then this one is at index number 0. So in here, immediately after I just placed this thing on cone holder, I'll just add another set timeout function. So set timeout, and the first thing I need to pass is basically my arrow function, and then say that how many seconds it is taking. Let's just see, it would be taking 3 seconds to select this topping. So 3 seconds, and then I'm going to basically show it on my console screen. So console.log, and again, I need to use this backtick keys, and then this dollar, and then these brackets, and then stocks dot toppings, and say that it's at index number 0 as topping. Okay, so yeah, that's it. And let's just do it. Let's just do the final step as well, which is serving the ice cream, which will take 2 seconds as well. So after the topping is actually being selected, then the final step is to actually serve the ice cream to the customer. So again, it will take some time. So that is why actually we need to use the set timeout function. So set timeout, and then first thing we need to pass is basically this arrow function, and it will take 2 seconds to serve the ice cream. So in here, I will just say that console dot log and serve the ice cream. Yeah, that's all we need to be doing. And now let's just save it and let's just execute it for the last time because our ice cream has been prepared completely, and let's just see if it's working fine or not. First of all, it will take 2 seconds for the customer to select strawberry, and then the production will start immediately. Then 2 seconds to chop the food, 1 second to chop to add water and ice cream, 1 second to start the machine, 3 seconds, 2 seconds to place ice cream on holder cone, and then chocolate is topping, and then 1 second to serve the ice cream. Okay, so our ice cream has been prepared. It has been prepared 100% using callbacks. And now in the next video, I'm going to basically show you something which is actually a kind of problem with callback, and what is actually called callback hell. So I'm going to teach you what actually callback hell in the next video. Okay, so the code that you can see inside this production function is actually looking quite messy because we are actually adding set time on function inside another set time on function, and we're just doing it again and again as long as our ice cream is prepared. So this condition where we are actually adding set time on function again and again inside another set time on function, and it's actually forming a kind of pyramid, as you're going to see that. And here you're going to see that it's actually kind of forming a pyramid. This condition is actually called callback hell. And in callback hell, our code actually looks something like this that we have inside our production function. Now, we don't want callback hell because it actually makes our code look quite messy. As you can just see that there should be another better way to solve such type of problem, and that is actually through promises and async await. So people don't usually use callback because it actually because the code that we actually make using it actually look quite messy, and because of callback hell, people don't use callbacks. People use nowadays people use promises and async await to solve such type of problems, and this is what we're gonna do as well. We need to escape from this callback hell because it is making our code quite messy, and it is very hard for the ordinary user to read such type of code. And for this, we're going to be using promises and async await in the coming videos. Okay, so as we have seen that with callback, our code looks very messy, and it looks something like this, like a pyramid, and this condition is called callback hell. So we can escape from callback hell using promise, and with promise, our code looks very neat and clean, and you're gonna see it once we code the ice cream example with promises, and then you're gonna see how promises will make our code looks pretty much neat and clean and pretty much readable. Okay, but first of all, you need to understand the life cycle of promises. Okay, so this is the life cycle of promises. And the first step in here you're going to see is that a promise is made. And this is like what promise we're gonna make. Like in case of ice cream example, our promise is that okay, we're gonna serve you ice cream. So that is our promise. And then the next step is the pending stage. So say that a customer comes in and sits on a table and he has that menu, but he has not ordered anything, means that it is actually pending. The production has not started because the order has not yet been made. So that is actually the pending state. But now say that the customer orders something and say that he says that, okay, I needs a mango ice cream. So say that a mango is actually available on the stock. So it will then move to the resolve part. But say that the mango is not available on the stock. So then from the pending state, it will actually move to the reject part because mango is not available. So the waiter will say that we are very, very sorry. We can't serve you the mango ice cream because it is not available on our stock. But if it is available, then it's going to come to this resolve part, and then we're going to start the production, and then we're going to basically chop the fruit, and so on. Whatever steps that we have right here, like for example, adding water and ice, and then starting the machine. So it will actually move, like for example, in here, we have in total 7 steps. So with promises, we will have 7 then. And then say that if the ice cream is not available, then we're going to basically come to this reject part, and then we're going to basically catch that reject by saying that sorry, our ice cream is not sorry, we can't serve you ice cream because mango is not available on our stock. And then the final thing in here in this life cycle is this finally. Okay, now finally will be executed whether uh, whether it is resolved or it is rejected. So say that the final is actually kind of a final message that you want to basically want to tell to the customer. Like for example, in this case, it will be like, thank you for visiting our shop. Thank you for visiting our ice cream shop or something like this. So this is actually the life cycle of promise, but with promise, it actually promises you that the code will be pretty much neat and clean as compared to callbacks. And we're gonna start doing this ice cream example using promises in the coming video. Okay, so now from this video, we're gonna start working on making an ice cream with promises. So let's get into it. Okay, so the first thing that I will do is that first of all, if the shop is open, only then the customer will be able to get the ice cream, and then we will be able to serve the ice cream. So first of all, we'll just make a promise that we can serve ice cream if the shop is open. So right in here, I'm going to make a variable, and I'll just name it as is shop underscore open, and by default I will just say that the shop is open, so that's why I'm just setting its value equal to true. Okay, now the next thing that we will do is that I'll just create a function, and that function is going to be order that we have made with callbacks as well. Now this order function, which is going to be an arrow function, will take two things as an argument. First of all, the time that is actually required perform a specific task in making this ice cream, and then that specific task that needs to be done while making that ice cream, like for example chopping the fruit or starting the machine, adding toppings and such type of work. Okay, next we will just enter inside this arrow function, and this arrow function will actually return a promise. So it will be basically a promise object. So right in here, I'll just say that it is going to be a new promise. And basically, this is a built-in object in JavaScript to perform such type of task with promises. So this promise object to the constructor method of the promise object will pass a function. And again, this is going to be an arrow function. Okay, so this promise object, the constructor method, this arrow function that we're actually passing to this promise object will take two things. First of all, the promise will either be resolved or it will be rejected. So right in here, I will just name it as resolve, or it might be rejected. Okay, so now I'll just come inside this arrow function that we have inside of this object. Okay, so now in here, first of all, I will check if the shop is open or not. If the shop is open, we will just actually resolve it. Else, we're going to reject it by saying to the customer that we can't serve you ice cream because the shop is closed. So first of all, and here I will just check that if is shop open means that if shop open equal to true, and in this case it is actually equal to true, so it will come inside the if block, and I will just say that resolve basically what we want to resolve. We want to basically resolve the work. Okay, so we haven't passed so this work is actually going to be a function that I will pass when I will just call this function. So right in here we'll just do it in a minute, but first of all let's just do the else part. So if the shop is open, we are going to resolve our promise. Okay, but if the shop is not open, then we're going to come inside this else block, and we will just say that we're going to reject it. And how we're going to reject it? We're going to reject it by printing something out on the console screen, and we'll just say that sorry, um, the shop is can you type it? The shop is closed. Okay, so let me just repeat. If the shop is open, then we're going to resolve the work that will pass to this order function. Else, if the shop is not open, then we cannot order anything. Means that we're going to reject it by saying that sorry, the shop is closed, so we can't serve you the ice cream. Okay, so basically this work will be done in some specific amount of time. So right in here, what I will just do is that I will just add a set timeout function. So set timeout, and for the set timeout function, the first thing that I will pass will be an arrow function. So the first thing that I will pass will be an arrow function, and then the next thing that I will pass is basically the time that I will basically pass to this order function, and that time is actually the time required to perform a specific task while making an ice cream. Okay, so in here we're actually passing it, so we'll just use this variable time. Okay, so that work will be resolved in some specific amount of time. So what we're gonna do is that we're gonna actually cut it right from here. So cut it, and we're gonna paste it right here inside this arrow function that we have inside the set timeout function. Okay, so yeah, that's all we need to be doing for the order function for this video. All now we need to do is to actually call this order function. So let's just call it right here, and you can just see that the first thing it is expecting is the time. So say that it actually takes 2 seconds to order the ice cream, and then the next thing that we need to pass is actually a function that will actually be copied right here. So let's just pass an arrow function. Well, now what you can do is that you can just make that function separately, or you can just pass it right here. So since this is going to be an arrow function, so I'm going to basically print out something on the console screen. So I'll just say that console.log, and what we want to do basically, the customer will order something by first of all choosing the type of ice cream he wants, and say that he wants the strawberry ice cream, which is inside my stocks object, and then this array of fruits, and then the strawberry is at index number 0. So right in here, I will just use this backtick keys, and then I will just use this dollar, and then these curly braces, and then I will just say that stocks dot fruits, and then this one is at index number 0, the strawberry, and then I will just say that was or is selected. Okay, so actually, you do not need these arrow brackets right here, because we only have one line of code for this arrow function. Even if you omit it, this won't make any difference. But just let's just say for simplicity purpose, I will just keep it as it is. Okay, so now just save your script, and now let's just execute it. So node, and then the name of this file. Okay, so after 2 seconds, 1, 2, it is saying that strawberry is actually been selected. Okay, so that was actually the first task, that is the ordering part, where the customer needs to order the ice cream by selecting the type of ice cream he wants. If you remember, we had done it with callbacks, but now we're gonna deal it. Now we're gonna make it with promises. We're gonna basically make this ice cream by solving all of the remaining tasks that is actually required for making this ice cream with promises, and you will actually see how simple our code will look like. So with callbacks, it was looking very messy, but now you're going to see how simple it is looking. But I'm going to do it in the next video. But um, before I end this video, I need to explain what actually I have done one last time. But if you have understood each and everything, then you can actually finish this video. Okay, so in the order function, what I'm actually doing is that I'm actually returning a promise. Okay, so I'm actually returning a promise, and with this promise object, I'm actually passing a function, an arrow function. So in here, I'm actually with this arrow function. In this arrow function, this is actually taking two arguments. Either it is going to be resolved or it's going to be rejected. So it's going to be resolved if the shop is open. So by default, its value is true, but you can actually take this value dynamically from the user. But for teaching purposes, let's just say that we will just set its value to true. So in here, this condition will true because shop open is equal to true. So if that is true, then it's going to resolve the work. And what is actually the work? The work is actually this whole thing right here that we have passed to the, this is actually a function, and this function is going to be executed if it just come inside right here. If this condition gets true, if the shop is open, so it's going to resolve it by actually executing this function in that specific amount of time, because as I told you that it will take 2 seconds to order the type of ice cream the customer wants. So if the shop is not open, then we're going to actually reject it. We're going to reject our promise. In here, we're actually resolving our promise. And in here, we're actually rejecting it by saying that, sorry, the shop is closed. So right in here, say that I just set its value equal to false. So let me just save it and let me just execute now. Now, what it's gonna do is that, okay, so not hand, okay, so it is saying that it actually needs dot catch as well, because it needs to be catched somewhere else. So we're gonna basically catch it in the coming videos. In the next video, by default, now for now we're gonna set this value equal to true, but later on we're gonna catch this exception. Like what's gonna happen if our promise is rejected? We need to actually catch it, and we're gonna catch it in the coming videos of promises. So for now, thank you for watching, and I'll see you guys next time. Okay, so the first step in promises, as you can see from this life cycle, is either resolve or reject. So we actually resolve and reject it based on this condition. If the shop is open, we're gonna going to resolve it. Else, we're gonna reject it. And then the with this reject, we need to add the catch as well, but we're gonna do it in the next video. But for now, in this life cycle, you can see that after resolve or reject, if it is resolved, then it just move to the next part, which is actually the promise chaining, then, and then so on. So this then actually is actually all the tasks that needs to be performed. Like for example, we already have placed the order, and then the next step is cutting the fruit. So it will be our first then, and then the next step is adding water and ice. Then this one is going to be our second then, and then the third step is starting the machine. Then that is going to be our third then, and so on, as many then as you want, depending upon the task that needs to be performed. Okay, so now let's just open your VS Code, and now right in here, the first thing you need to make sure is that you don't have this semicolon right here, because if you do have semicolon, then JavaScript will think that the task that you need to be that needs to be performed with promises is actually done. So right in here, what you need to be doing is that you actually this time dot then. So this then is actually the method which is actually inside my promise object, and we have made this promise object right here that we're actually returning from the place we're actually calling this function right here. So this whole thing is actually an object. Now with this object, we're actually calling this built-in method that is actually inside the promise object. And now with this promise object, with this method, this dot then method, the first thing that we need to pass um, is basically an arrow function. And now this arrow function, let me just scroll it down, is going to return. What it's going to return is going to return whatever that is being returned by the order. So right in here, to the order, we actually need to pass first of all the time and then the task or the work that needs to be performed. So right in here, the next step after ordering the food, placing the order, is actually cutting the fruit or chopping the fruit. So right in here, first of all, here you can see that chopping the fruit actually takes 2 seconds. So the first thing I will just pass right here is 2 seconds, and then the next thing I will just pass is an arrow function, just like we have passed right here while we were ordering the fruit. And now we're going to just say that console.log. Okay, so first of all, we actually need to start the production after the strawberry or whatever fruit is being selected. So just say that the production has been started, and the production will be started immediately after the order has been placed. It will just be done in 0 seconds. Okay, so now just save your script and execute your code. So first of all, it will just take 2 seconds for ordering the fruit, and then the next step is actually starting the production. So it will take 0 second to start the production. Okay, so hit enter. So it will take 1, 2 seconds, and then after the strawberry is being selected, the production will start immediately. Okay, so now the next step is chopping the fruit. So right in here, you will just simply add another dot then. So dot then, and then in here, you're just gonna again pass the arrow function, and this arrow function will again return, and then this function order, and chopping the fruit will take 2 seconds, and then the next thing that we need to pass will be an arrow function, and then I'll just say that console.log. So after 2 seconds, fruits will be chopped. So I'll just say that fruits has been chopped. Okay, so now just save it once again, and just notice here that it will take 2 seconds for the fruits to be chopped after the production has been started. Okay, so let's just execute this code once again. So after 2 seconds, strawberry will be selected, production will start immediately. In about 2 seconds, fruits will be chopped. Okay, so now let's just see what are the next steps. The next step is adding water and ice. So right in here, we'll just add another dot then. So dot then, and we'll just pass an arrow function, and this arrow function will again return this thing, so this thing, and it is actually taking 1 second to add water and ice, and the next thing that will pass will be my arrow function, and I will just say that console.log. And again, I've just used this backtick keys because I need to select something from my stocks, and that is actually water and ice. So it is actually inside my stocks object, and then liquid, and this one is at index number 0, and this one is at index number 1. So right in here, I will just simply say, first of all, this dollar symbol, and then this one, and then stocks dot liquid, and then this one is at the first one is at index number 0, and I'll just say that and now what I will do is I will actually copy it. So copy and just paste it right in here, and we'll just say that um is added. Okay, so that was the third step, and now the fourth one will be again dot then. And again, we'll just pass an arrow function to it, and this will again return order. Return, just calling this order function order, and the next step after adding water and ice is to start the machine. So starting the machine it actually takes 1 second. So right in here just type 1000, and then this one, this arrow function, and I will just say that console.log the machine has been started. Okay, so the next one is again dot then, and then the arrow function, and then this one is going to return order, and then the next one after starting the machine is to basically select the container. Okay, so first of all, let me just see how much time it takes to select the container. Selecting the container takes 2 seconds. Okay, so in here I just need to pass 2, and then the next one is the type of work that needs to be done. So I'll just say that console.log, and let me just see what we have inside my stock. So for the holder, it is either corn, cup, or steak. So let's just say that it is going to be corn, which is inside my stocks, and then holder array, and then this one is at index number 0. So right in here, I'll just say that which is back to case, and then dollar, and then this one, and then stocks dots. Basically, it is holder, and then this one is index number 0 as holder. Okay, and that was another task, and it's taking 2 seconds. And then the next one is actually the topping one. Um, so right in here, I'll just again say that return. Uh, Calling the order function, it is actually taking 3 seconds, and then we need to call, basically we need to pass this arrow function, and I'll just say that console.log, and then in here what we are doing is that for topping we can either have chocolate or peanut. So let's say that I will just have chocolate on my ice cream top. So topping is in my stock object, and then this array toppings, and then this one is at index number 0. So right in here, just use this backtick keys, and then this dollar, and then stocks dot toppings, and then 0, and then let's say that as not like this. It should be actually inside in here as topping. Okay, so after adding the topping, I think the final step is to serve the ice cream. Yeah, so selecting the topping, the final step is to serve the ice cream, which is taking 2 seconds. So right in here, I'll just say that then. Uh, and then in here, I just need to pass this arrow function, and I'll just type return, and then this function order, and it's taking 2 seconds to serve the ice cream, and then we need to pass the work in the form of arrow function. So console dot log, and I'll just say that serve the ice cream. And yeah, that's all. We are done. We are done with promises. But see that how neat and clean this code is as compared to the code that we had using callback. So we simply have dot then, and then dot then, dot then, dot then, as many then as we want, depending upon the number of tasks that we have right here for making this ice cream. Okay, so first of all, let me just execute. So first of all, just save your script, and hopefully everything will be fine. So first of all, it will take 2 seconds. Production has been started. Fruit has been chopped. Water has been added. Machine has been started. On as a holder. And then chocolate as topping. And then finally serve the ice cream. Wow, our ice cream is ready with promises. It was pretty simple as compared to callbacks. While making our ice cream, you can just see that our code actually is looking neat and clean. And if I can just show you, that was actually the format of promises. We first of all need to resolve. We need to first of all either resolve or reject it. And if it is resolved, then we have simply dot then, dot then, dot then, and then dot then. Okay, so just you might be confused. If you are not confused, then you can just simply end this video. But if you are confused, make sure that you do not have this semicolon right here, because this order function is actually returning a promise object. So this whole thing, this promise object is going to be returned, whatever this function is actually is, this is going to be returned as an object, because in here we're saying that return a promise object, return this promise object, and it will be received right here. So this whole thing will be an object, and now with this object, we are actually calling this function dot then. But if you have that semicolon right here, then you actually can't call this function then with this object, with this promise object. So make sure that you don't have any semicolon right here or anywhere else. But at the end, if you want, you can have this semicolon. That is absolutely fine, because we are now done. But actually, we need to catch our in here. You can see that if there is something, if it is not resolved, it is rejected, then we actually need to catch our exception right here, and that is going to be catched in the next video. But I hope that everything is pretty much clear. You can just see that how neat. Just compare the code between promises and callbacks. This is the most asked question, like why do we use promises? Why do we use promises, and why don't we use callbacks? So the reason is there is only one reason, is that with callbacks our code is looking very messy. It is not readable. With promises our code is you can see that how neat and clean it is, and it is pretty much readable. That is the answer. And then the next most asked question in the interview is that is if JavaScript synchronous or asynchronous. So by default JavaScript is synchronous, that is execute the code line by line. The first line, second line cannot be executed before the first one, but we actually make JavaScript asynchronous using callbacks, using promises, and then in this video we will also cover async await. So we actually make JavaScript asynchronous using async await as well. that we're going to be covering in this course as well. So for now, thank you for watching, and I'll see you guys next time. Okay, so in the promise lifecycle, you're going to see that we have either resolve or we have reject. If it is resolved, then we're going to go through all these steps, dot then, and so on. But if it is rejected, then it's going to look for this catch. And in our case, it's going to come to this catch if our shop is closed. So if this thing is not true, means if it is false, then this if condition will be true, and instead of just resolving it, it's just going to come to this else part, and then it's going to reject it. So when JavaScript sees this thing reject, then it's going to look for dot catch, the catch method that we have inside the promise object. So right in here, we're going to catch it right here. And again, make sure that you don't have this semicolon right here, because we're just going to continue it. And now right in here, we're going to catch it. And now with this, just look, see that this catch is actually the promise object, and right in here, and it will actually be called if the promise is actually rejected. So you can see that attaches a callback for only the rejection of the promise. So right in here, what it's going to do if it's going to be catched, we're going to do something right here by printing something out on the console screen. I'll just say that console.log. And if the shop is closed, then the customer is going to leave. So I'll just say that customer left. Okay. So yeah, that's all we need to be doing. And you have seen that if this condition is true, then it is actually printing out all these things. But if it is false, then it's going to reject part and going to come inside the catch block. Okay, so now let me just execute this code once again. And you can see that it is saying that sorry, the shop is closed, customer left. And that is because right in here, we have set this value equal to false. So this condition gets false. It comes to this else block and just saying that reject by printing this thing out on the console screen. Sorry, the shop is closed. And then when it sees this, JavaScript is looking for the catch block. So right in here, it will just come to this catch method. And then with this catch method, we're actually passing this method. And this method is actually printing out this thing, which is customer has left. Okay, so yeah, that's all we need to be doing for the reject part. And in here, the final step you can see is whether the promise is resolved or it is rejected. It will still we did actually the optional part. You can just leave it or you can just complete it. So finally, is actually giving some kind of final message. So say that right in here, we just can add this final message. So just remember that even if the promise is rejected or resolved, it will still come to this finally part if we have something in the finally block. So right in here, I'll just say the finally, and again, we just say that console.log and say that the final message will be thank you for visiting our ice cream shop. And yeah, that's all we need to be doing. And just remember that even if the promise is resolved or rejected, it will still come to this finally block. And I'm going to show you. So first of all, we have the value of is shop open equal to false, means that it's going to be rejected. And we're going to see actually this thing with addition to this thing that we have inside the finally block. Okay, so let me just execute it once again. And you can see that first of all, it is saying, sorry, the shop is closed, customer left. And then finally, it is printing out this message. Thank you for visiting our ice cream shop. And let me just add another thing. We will see you again. Okay. And now what I'm going to do is that I will just set this value equal to true, just to show you that it will actually work even if the promise is resolved. So right in here, just set its value equal to true. And now let me just execute it once again by saving your script first of all. And first of all, it will just go through all these steps of making this ice cream. And then finally, it will show you this message which is inside my finally block saying that thank you for visiting our ice cream shop. We'll see you again. And yeah, that's it for this video. I will see you again. Okay, so now from this video, we will start covering async await, and we will be making our ice cream using async await as well, just like we had made with promises and callbacks. So before we make our ice cream using async await, we first of all need to understand what actually async await is. So async await is actually a better way of writing promises. So when we were writing promises, we were just doing it like this. So say that we have an arrow function. So this arrow function will take no argument. And in here, what we were doing is that we were actually returning promise object. So first of all, we're just creating it using a new promise. And this promise object will take an arrow function. And this arrow function will take two arguments. Either promise is going to be resolved or it's going to be rejected. So in here, okay. And then we'll just come inside our arrow function. And then we were just saying that if the condition gets true, what we're going to do is that we're going to resolve our promise. So we're just going to resolving our promise, else what we were doing is that we were actually rejecting our promise by saying something on the console screen. So this is how we were actually creating a promise and then resolving it and rejecting it using promises. But now, how we gonna actually create a promise using async await? So in here, uh, um, we just do it something like this. We just type this keyword async and then um, function and then the name of the function and yeah, this is how we actually create a promise using async, using this keyword async. So this will actually create a promise. So previously we were just doing it like this, but with async, we're just doing it like this. So this will actually create a promise. This keyword async will actually create promise, but it is not as that much simple. So after basically we have this promise, then if it is resolved, then what it do is that first of all we actually need to call this function order, then it actually move to the then block, and then again then and then as many then as you want, and then if the promise is rejected, then it actually come to the catch block, um and doesn't matter if the promise is rejected or resolved, it still come to this finally block. So this one gets executed when the promise is resolved. This one gets executed when the promise is rejected, and this one is executed anyways. Doesn't matter if the promise is resolved or rejected. But in async await, we actually write this condition of dot then and catch and finally using try, catch, and finally. So we have three things in async function. We either have try, catch, and finally. So let's just do it like this. So let me just comment this whole thing out because we don't need this. So yeah, we don't need this. So just comment this thing out. And now let's just come to this async function that we have created right here using this keyword async. So first of all, what we do is that we write try. And then what we do is that we write catch. And with this catch, the error is actually caught right here. Not like this. It is this caught. Um, okay, so with catch, for error is caught like this, and then it just come to the catch block, and then finally we have finally uh, it will be executed. Doesn't matter if the code is executed or if there is some kind of error that is going to be caught right here. Okay, so first of all, well, let's just understand it. So in here, say that we have this keyword await. So just forget about this keyword await for now. Let's just first of all try to understand this try block. So say that we're actually calling a function right here. I will just say await ABC. And if there is some kind of error, where well actually there is some kind of error because there is no function named abc in my whole code. So this is some kind of error. So it's going to come to this catch block. And with this catch block, I will just say that console dot console.log. Oops, what I'm just typing, console.log. Um, function ABC doesn't exist. And then we'll just print down this error right here. And then this finally block is going to be executed. Doesn't matter if there is some kind of error or not. So in the finally block, we'll just say that console.log. Um, I'll just say that the finally block, oops, block will be executed anyways. Okay, so in here, first of all, what I'm actually doing is that I'm actually trying to execute this line of code. Basically, the code that we have inside the try block. It can be as much long as long as you want. But, in here, we just write only one line of code, and in here, what I'm doing is that I'm actually trying to execute a function that doesn't exist. So in here, it just fails to execute the try block because there is some kind of error because this function doesn't exist. So this error will be caught in the catch block right here in this argument error, and then we're actually saying this thing with this error right here. So it doesn't matter if there's any error or not, it's gonna still print out this thing on the console screen as well. Okay, so now let's just call this function order right here. Make sure that everything else is commented. Okay, so now we can just call this function right in here. Let's just say order. Now save it, and now let's just execute our code. Yeah, this is the code. Okay, so finally block will be executed anyways. So let's see what is it saying. Okay, so again it's saying that function ABC doesn't exist and it is actually a reference error. ABC is not defined, and this is actually the whole error that we are actually getting. So this whole error is actually caught right here, and then we are actually printing that error right here with this thing. And then, as I told you, that finally block will be executed at the end. Doesn't matter if there is any error or not. In this case, we have error, but still, this block will be executed. So, first of all, again, let me just repeat. First of all, you just try to execute this line of code. If it just fails to execute this line of code, then it's going to come to this catch block and it will catch that error that it actually caught in this argument error, and then we'll actually printing out that error right here with this thing. And then finally, we're actually printing this thing on the console screen. So this is how we have try, catch, and finally in async function, while with promises we have dot then, and then catch, and then finally. Okay, so as I told you that this thing will actually create a function right here. This thing will actually create a promise right here. So now what I can do is that since this actually has created a promise, this async keyword has actually created a promise object that we have created previously like this. So now what we can do is that since it has created a promise object, now we can actually use dot then, and then we can just pass an arrow function saying that console.log. I'll just say that this will be executed in step step 2, and then we can have another then, and again we can just pass an arrow function by saying that console dot log. This will be executed in step 3, and then finally we can either have catch and finally as well if you want. But the point that I'm actually trying to make is that since this keyword has actually created a promise object, and now with the promise object, in the promise object we have this built-in method dot then, and then dot catch, and then dot finally as well. So we can use it once we have this keyword async with any function. So and now we have it. So now we can actually use dot catch, get dot finally as well. But in the next video, I'm going to be talking about this keyword await, because this keyword await is very, very important while learning async await. This will actually replace actually all these lines of code that we have written um, pretty much, and you're going to see it in the coming videos. All right, now in this video, I'm going to be talking about this await keyword using an example. So say that I'm working on making an ice cream in the kitchen, and say that while making an ice cream, I forgot what topping the customer would like. So I just leave the kitchen and go back to the customer and ask him, sir, what topping would you like on your ice cream? And then I will just come back after taking an order from the customer regarding the topping. So in the meantime, while I'm actually out of the kitchen, the process of making an ice cream is actually stopped. Nothing is actually happening in the kitchen. So, because it is actually taking time for me to go out of the kitchen, go to the customer, and then come back. So, during that process, the process of making an ice cream is being stopped because the chef, which in this case is me, is no more in the kitchen. But the entire restaurant is working. Like for example, um, other workers are basically working on cleaning the dishes. They are working on cleaning tables, taking orders from the customer. But the process of making an ice cream is stopped because I am no more in the kitchen. I actually went out of the kitchen to take order from the customer regarding the topping thing, and then when I just come back, then I will just start the process once again. So let's just have a function for this. And in here, but let me just first of all clear each and everything that I have, and let me just clear this thing as well because we do not need it. Okay, so right in here, if let's clear it. Okay, so I'm gonna clear it till that point, and now what I'm gonna do is that I will just create a function, and I will just name this function as toppings underscore choice. And this one, this function is going to return a new promise, basically a promise object. Um, and in here, we need to pass an arrow function, and this arrow function will take two things. If you remember, it is um, resolve or it is reject. And now I'll just come inside my arrow function, and I will just add a set timeout function because it will take some time for me to ask the customer which topping would he like. So right in here, I will just put it inside my set timeout function. So set timeout, and the first thing I will just pass will be an arrow function, and say that it will just take 3 seconds for me to ask the customer what topping would he like. And now inside the arrow function that I have inside my um, set timeout function, I will just say that console.log. And in here, I will just say that I will ask the user which topping he would like. Okay, so that is the function that I have made for asking the customer which topping he would like. Okay, now in here I'm gonna create an async function. So right in here, let's say that async, and I will just name this function as kitchen because I'm actually working in the kitchen. Okay, now in the kitchen, basically, I will be working on all the steps that are required to make an ice cream. So say that I will just write console. So say that there are like 5 or 6 steps. So say that there are 6 steps. So in here, I will just type A, and then I will just type it like 5 times. So 1, 2, 3, 4, 5 times. And now in here, B, and then C, D, and in. Okay, now somewhere in between, like for example, I actually chopped the fruit, I actually started the machine, and then I added water and ice. But somewhere in between, I forgot which topping the customer has actually ordered. So somewhere in between, I forgot to ask. So what I'm going to do is that I will actually go back to the customer, and in here in that function, I've actually asked the user which topping he would like. So in here, I will just use the keyword await. I'm going to explain it, but first of all, let's just call this function topping choice. Okay, so in here, first of all, I will just execute my first step in making an ice cream, and then second step, and then third step, and say that in the fourth step, in here, I forgot which topping the customer has ordered. So I will actually go back to this function, this topping choice function. Basically, I will actually go back to the customer and say that it will actually take 3 seconds. So during these 3 seconds, these two steps will not be executed because the chef is not present in the kitchen. So these two steps, the kitchen is since the kitchen is empty, so these two steps will not be executed in 3 seconds. So in here, it is actually waiting for this function to be executed, and once it is executed, it can then execute this step and then this step. But outside of this function, say that there are other workers that are working on cleaning the tables, serving the customers, doing dishes and all these things. It will continue to happen. So in here, I'm actually calling this kitchen function and say that in here we will have console dot log, and say that the in the restaurant, the people are working on doing the dishes, and then there will be console.log, and then they will be actually cleaning the tables, cleaning the tables, and then they will be working on something else as well, like for example, serving the customers or taking orders from different customers. Okay, so let me just execute this code, and then it will actually make more sense. So I'm gonna basically save it, and then I'm gonna actually execute it. Okay, so you can see that it's first of all ABC, and then all the remaining steps are being executed, like we're doing the dishes, cleaning the table, and taking orders from different customers. And once after 3 seconds, I actually came back with the topping choice of the customer, then it will actually execute basically this thing, which is which topping would you like, and then it will actually in here, my ABC. Let me just scroll it up. ABC cleaning dishes, taking order from different customers. Which topping would he like? Okay, so yeah, it is actually not executing these two lines of code. And the reason for this is that I forgot to put this thing in resolve. So this thing must be resolved. So this is my bad. I This thing must go in the resolve part, and yeah, this one will now work absolutely fine. Taking order from the customer, taking orders from customer, and yeah, which topping would he like? And after the chef knows that which topping the customer would like, it will then execute step number D and step number E. Okay, now let me just explain this code one last time before I end this tutorial. But if you have understood this code, then you can actually end this tutorial. Okay, so again, what I'm actually doing is that somewhere, let's say that I'm actually working on the kitchen and I execute step number one, step number two, step number three, and then I forgot which topping the customer had ordered. So I will actually go back to the customer right here and will ask him which topping would he like, and say that it will actually take 3 seconds for me to ask the customer. So during these 3 seconds, the other restaurant is in the working state. Like for example, other waiters are actually doing dishes, cleaning tables, taking orders from different customers. But this whole process, this kitchen thing is actually stopped because the chef is no more in the kitchen making an ice cream. It is He has actually gone to the customer asking him which topping would he like, and once he actually come back after 3 seconds, it will then execute step number D and step number E. And this is what actually we are seeing right here. So in here, first of all, it is actually executed step number A and then B and then C, and then it actually go back right here. And since it is taking 3 seconds, so in the meantime, the other restaurant, the other waiters are still in the working state. They are actually doing the dishes, cleaning the tables, taking orders from different customers. And once, after 3 seconds, once the chef is done taking the topping order from the customer, he can then come back after 3 seconds and then execute step number D and step number E. So this await keyword will actually put the remaining code inside of that async function as long as that function has not been executed. And once that function has been executed, it can then execute the remaining part of that function. So this is what this await keyword will actually do. So hope this is making sense. And if it does, now we can actually move on to make that complete ice cream using async await. And you're going to see that making an ice cream using async await, actually coding ice cream using async await is a lot easier as compared to promises, and then almost a million times more easier than callbacks. Thank you for watching. I'll see you guys next time. Okay, now in this video, we're gonna make our ice cream using async await, and async await is actually the last part of asynchronous programming. So the first one is callbacks, the second one is promises, and then the third one is async await. So now, previously we had made ice cream using callbacks and then promises, and now we're gonna make our ice cream using async await, and then async await is going to make more sense to you. So let's just get into it. Okay, so first of all, what I'm going to do is that I have actually created each and everything from the previous video except the stocks. And now in here, what I'm going to do is that I'll just create a variable, and this variable will be is shop open, and by default, I'm going to set this value equal to true. Okay, now what I'm going to do is that I will just create a function, and that is going to be a time function. So I'll just name it as time, and then this time function will accept an argument, and that is going to be the time that is actually required to perform a specific task while making an ice cream. Okay, now what this function will do is that it will actually return a promise object. So I'll just type here return new promise. And then if you remember, it is either it can the promise can either be resolved or rejected. So in here I'm actually passing an arrow function right here, and then for this arrow function it is actually expecting two arguments. It can either be resolved or it can be rejected. So now in here I will just add an if statement, and the promise is going to be resolved if the shop is open. So you can see that by default its value is true. So the promise is going to be resolved if the shop is open. So I'll just type it if is shop open. Then what we're going to do is that we're going to actually resolve for promise. So in here I'll just add it inside the set timeout function. And the first thing that I'm going to pass is basically obviously resolve. And the second time I'll just pass is basically the time, which is going to be in millisecond. Okay, but if the shop is closed, means that if this variable is false, then it's gonna come inside my else block, and I will actually reject it by printing something out on the console screen. So I'll just say that console.log, and I will just say that um our shop is closed at this moment. Okay, so yeah, this is all we need to be doing for this time function. It is simply returning a promise, and this promise is going to be resolved if the shop is open, else it's going to be rejected. Simple, simple. And now the next thing in here, what I'm going to do is that I will actually create an async function. So I'll just type here async function, and then in here I will just name it as kitchen, because in the kitchen everything that is involved in making an ice cream will be done. So right in here, okay, so if you remember async, actually for async we have try, or we have catch if we got some error, and then basically this is optional, but you can add the finally one as well. And this catch, in this catch, the error will be received. So in here for the finally, we can just simply type like console dot console.log. And I'll just say that um, thank you for visiting our shop. See you again soon. Okay, and then for the catch, we can just simply type uh, console.log customer has left. Okay, so in here, let me just type customer has left. And basically, if our promise is actually rejected, means that if the shop is actually closed, then this thing will actually be received right here in the catch. And if you want, you can actually print out the error, but I will not print it. I will just simply say customer has left. Okay, so if you remember it with promises, if it gets rejected, then we need to actually catch it. And it's going to be catch right here. And it will come to this reject part if the shop is closed. So it will first of all print this thing out, and then it will just look for the catch block. So the catch block is right over here. And since our shop is closed, so the customer is going to leave. So that's where actually we are printing this message customer has left. Okay, now at the entire part, the remaining part we have to do inside this try block. Okay, so for the try block, now what I'm going to do is that first of all, I will just say that the first part is actually console.log, and the first part is first of all, the user will actually select a fruit by ordering ice cream by selecting some kind of fruit from or stocks, and then this array fruits. So right in here, I will just add this backtick key, and then I will have this dollar symbol, and then this thing, and I will just say that stocks dot fruits, and then let's just say that the customer select the first fruit, which is strawberry, and I will just say that strawberry was selected. And now, if you remember, it actually takes some time to select the type of ice cream the customer wants. So say that it will just take 2 seconds. So now in here, what I'm going to do is that I will just use this keyword await. And for this await, I will just for the await next to await, I'm going to basically call this time function. And since selecting the fruit actually take 2 seconds, so right in here I will just pass this 2 seconds. And if you remember, this time function is actually expecting this thing in milliseconds. So in here we actually need to pass it in millisecond. And actually this time function accept the time in millisecond. So now what it actually means that as long as we actually wait for 2 seconds, and after waiting for 2 seconds actually try to execute this line of code. So previously with promises it was different, but now for async await, we're actually using this keyword await to wait for some specific amount of time. And in this case, it is only 2 seconds. Okay, so now in here, the next step is actually chopping the fruit. So right in here, I will just say that again, await time, and say that chopping the fruit would also take 2 seconds. And now in here, basically, I will just say that console.log fruits has been chopped. Okay, so actually before chopping the fruit, we actually need to start the production here. So right in here, I will just say that await, and we say that this time we'll just pass 0 second because the production will start immediately after ordering the fruit. So right in here, I will just say that console dot not like this, console dot log. And I will just say that production has been started. Okay, so let first of all let's test this thing out to see if it is working or not. So right in here, just type. First of all, you need to save your script and then just type node script.js and hit enter. Okay, so it is just printing nothing out on the console screen because we forgot to call this function kitchen. Okay, so we're gonna call it right here. So just kitchen. And yeah, that's all we need to do. And now let's just run it. So it will take 2 seconds. 2 seconds. Production will start immediately. And after 2 seconds, it will say fruits has been chopped. And then at the end, it will just come to this finally block saying, thank you for visiting our shop. See you again. Okay, so now let's just do the remaining steps after fruits has been chopped, and the next step is adding water and ice. So right in here, adding water and ice is actually taking 1 second. So right in here, what I'm gonna do is I'll just say that await time, and it's gonna take 1 second to add water and ice. So let's say that console, oops, not like this. So console dot log. And then in here I need to add this backtick keys because in here I'm just going to select something from my stocks. So it is water and ice, it is basically inside my liquid. So stock, and then this liquid array, and then the zeroth index, and then the first index inside this liquid array. So right in here I will just say that not like this. First of all, this dollar, and then these curly braces, and then I can just write some JavaScript. So stocks dot liquid, and then the first item in the array. So water, and then again the same thing. So why not just copy it? So copy, and I'm gonna paste it right in here, and then just type here one. Water and ice has been added. Okay, so the next step is, if you remember, just open this notepad. It is starting the machine and it will actually take 1 second. So I will just type await, and then this function time, and then it will take 1 second. And then I'll just type console.log. Um, the is machine is started. Okay, and now the next step is selecting the container. So it will take 2 seconds. So right in here, I'll just say that await time 2 seconds, and then I'll just type console.log. And then since in here, container for the container, it is actually the type of folder which is either con, cup, or stake. So say that I will just use cup this time instead of con. So which is actually inside my stocks, and then this array holder, and then this first item in the holder array. So right in here again, I just need to use this backtick keys. And then basically my dollar and this curly braces, and then stocks dot holder, and this time it's talking about the second item which is at index number one as holder. Okay, now the next step is selecting topping. So selecting topping, let me just see how much time it takes. It takes 3 seconds. Okay, so I'll just type await time, and then 3 seconds, and then console.log, console.log, and this time again I'm just going to use this backtick keys because I'm just going to write some JavaScript by selecting something from here, from this topping, and say that this time I want peanut as topping on my ice cream. So this one is as stocks, and then toppings array, and then index number one. Okay, so let's just write it in here. Okay, so dollar, and then stocks dot toppings, and then actually first index as topping on ice cream. And then the final step is to actually serve the ice cream, and serving the ice cream will take 2 seconds as well. So now finally I will just type console.log, and now I'll just type serve the ice cream to the customer. And yeah, that's all we need to be doing for making ice cream using async await. And you can just see that how simple dimple it is using async await. I would say that it is actually more simpler than promises, and then almost a million times more simpler than callbacks. But I would say that it is actually even more simpler than promises as well. So yeah, this is actually the more neater and cleaner picture of making an ice cream using or performing any task using asynchronous programming and then by using async await. Okay, so now let's just execute it and then finally I'll explain this code and then I'll just end this video. So let's execute it. So 2 seconds and then immediately starting the production. Fruits has been chopped, button has been added, machine started, cup as holder. And then let's just see what we have on the topping. Peanuts as topping on ice cream. And then finally, it's going to serve the ice cream and print out this message saying that thank you for visiting our shop. We're going to see you soon again. Okay, now let's just say that in here, this promise gets rejected. So it will just get rejected if we have false right here. So it will first of all check this condition. This condition will be false because this thing is actually false. Because by default, if you just don't type here anything, it actually means true. So this one will get false. You can come to this else part and would reject it. And as soon as it just sees basic print out this message, and since it is actually inside this reject function, then it is actually looking for the catch block because the error or the reject part is going to be catched right here in the catch block. So it's coming in the catch block, and the error will be caught right here in this variable error. And then I'm actually not printing out the error, but I'm just actually printing out this thing. The customer is left because the shop is closed. And then finally, it's going to basically print out this message because this finally block will be executed whether the doesn't matter if the promise gets resolved or rejected. Okay, so now let's just execute this code. But first of all, make sure that you just save your script before, and now we can actually run it. And then it is just saying that our shop is closed at this moment. Customer has left because it is coming to this catch block, and then again finally it's printing out this message. Thank you for visiting our shop. We're gonna see you again when the shop is open. Okay, so let me just basically turn this variable back to true. So I'm going to just turn it back to true. Okay, so now how actually it is working, basically this function. So this thing will actually stop the execution. This await will actually stop the execution. So say that our program is somewhere right here and it actually sees this await keyword. Now, whenever you just want to use the await keyword, now it can only be used if you have this keyword async before the function name. Make sure that this keyword is actually present or you cannot use this keyword await. Okay, so when it sees this await function inside this async, what it does is that it actually stops the execution of that particular function in which we have that await keyword. In this case, it is the kitchen function. Then it's gonna basically stop the execution till that point for 2 seconds. And as long as this line of code will not be executed, it will not come here to this line of code only for this function kitchen because we have this await keyword for inside this function kitchen. But say that if we have like other functions, then it gonna continue to execute while this function is in the await state. And this is how actually threading work. I already have explained how threading work. And now similarly, it is actually taking 0 seconds and then again, it has actually stopped the execution of this function, this async function, for 2 seconds, and it will not go further for 2 seconds again. And after 2 seconds, it will actually print out this message, and again, it will actually stop here. This async function will stop here for 1 second. Let me just scroll it down, and after 1 second, it will be stopped again for 1 second, and then for 2 seconds, and then for 3 seconds. But remember that this await keyword is only applicable for this function kitchen. If we have other function which does not has async, this keyword async, and then this keyword await, then you're going to continue executing in a separate thread or as a part of main thread while this one is actually in await. So I hope it is making sense. But say that if we have like multiple async functions and then let's say that we have another function which has this keyword async and then this keyword await as well, then they're gonna run separately as well in separate threads. But they're gonna actually report to the main thread after awaiting for a specific amount of time. Just like we have seen in promises, and just like we have seen how threading work in the thread slides. So I hope because it is actually you need to make sure that you actually understand the entire asynchronous programming, because this is the most, when you just go to the JavaScript, when you just go for the JavaScript interview, they're just gonna ask you so many questions related to asynchronous programming. So you must know how asynchronous programming actually work, how basically they go in separate threads, and then you should know if JavaScript is synchronous or asynchronous, and then you should know how this await keyword is doing and what this promises actually what this keyword what how promises work, how callbacks work, and then the most asked question is what is callback hell, and you need to tell that in callback hell our code is actually very messy, and that is why we use promises and async await. Honestly, I mean, if you just have to decide between promises and async await, then you will see if you just go to the professional field in different companies, you're going to basically see async await to be mostly used, but a lot of companies still use promises as well because they just love it. And trust me, I just sometimes use promises as well. But this async await is used more than promises. And obviously, no one uses callbacks these days. It was used when JavaScript was new, and then these things, promises and async await, were not the part of JavaScript. So, if you have any problem related to asynchronous programming, then you can just directly email me. You can just directly throw me a message, and I will be very happy to answer any questions that you have related to asynchronous programming, because I love this asynchronous programming. I have a lot of experience in web development, and web development these days without asynchronous programming is literally nothing. So make sure that you actually understood each and every part of asynchronous programming. And if you have any problem at any time in asynchronous programming, then just let me know and I'll just get back to you as soon as possible. Thank you for watching, and I'll see you guys next time.
Hey guys, what's up? I welcome you to another tutorial on this course. And in this tutorial, we are going to start on to learn more in depth about functions. So let's start on with recursion. Now, if you are not new to programming, then it is probably familiar a topic and you could just skip this tutorial. But if you are not, then stay right here because we are going to learn everything we have to learn about recursion in JavaScript. Now, basically, what is recursion? Recursion is a programming pattern that is useful in situations when a task can be naturally split into several tasks of the same kind but simpler, or when a task can be simplified into an easy action plus a simple variant of the same task, or as we are going to see soon, how we are going to deal with certain data structures using recursion. Now, when a function solves a task in the process, it can call many other functions. Now, a partial case of this is when a function calls itself. That is exactly what recursion is. That is a function called to itself. Now, there are two ways of thinking basically. The first one is how to implement something using the iterative thinking, that is the for loop, which we have studied. The second way of thinking is the recursive thinking, that is to simplify the task and to have the function call itself. So, if you consider the function for how to calculate the power of a number, then you know how to do that using the for loop. So let's just see how we are going to calculate the power using recursion. So let's just say that we have this function x raised to the power n, and inside that function, we need to specify a stopper for the recursion function. So if n equal to 1, that is going to indicate that the recursive call for the function is going to stop. And it is going to return x, that is going to be the answer in this case. Else what it is going to do is that it is going to perform a recursive call that is going to be return x multiplied by the power, which is the function itself, where x is going to be n minus 1. So that is exactly what recursion is. And if you now write in alert and you want to call in the function POW where the x is 2, this is 3. Now, apparently, you know that the answer is going to be 8.
So if you refresh this, you are going to get that 8. Now you can implement that with the help of a for loop as well, and it is going to be a bit actually bigger. So that's why recursion is used. So if you note here how the recursive variant is fundamentally different. Now, when the power xn is called, the execution actually split itself into two branches. The first one, as you can see, is where we have written if n equal to 1. Now, if n equal to 1, then everything is going to be trivial. It is called the base of recursion because it immediately produces the obvious result, that is, if power x has the power of 1, that equals x itself. So right here, if you just write in 2 raised to the power 1, then actually at the first iteration, this thing is going to actually stop and it is going to go no more. No recursion is going to be performed here. Now in the second step, otherwise we can represent power x comma n as the x steric power x n minus 1. Now in maths, one would write xn equal to x steric x raised to the power n minus 1. Now that is called a recursive step. We transform the task into simpler action, that is multiplication by x, and a simpler call of the same task, power with lower n values. Next step is to simplify it further and further until n reaches 1. Now, for example, if you want to calculate 2 raised to the power 4, then the recursive variant is going to perform 4 steps. In the first step, it is going to have 2 raised to the power 3. In the second step, it is going to have 2 raised to the power 2. In the third iteration, it is going to have it for 2 raised to the power 1. And in the final step, when the value of n becomes 1, it is going to exit. So the recursion reduces a function call to a simpler one and then to even more simpler and so on until the result becomes obvious. Now, recursion is always shorter. A recursive solution is usually shorter than an iterative one. Now, the maximal number of nested calls, including the first one, is actually called the recursion depth. In our case, it will be exactly what we specify the value of n to be. Now, the maximal recursion depth is limited by JavaScript engine. We can rely on it being 10,000. Some engines allow more than 1 lakh. That is probably out of limit for the majority of them. Now, there are automatic optimizations that help alleviate this tails calls optimization, but they are not yet supported everywhere and work only in simple cases. Now that limits the application of recursion, but it still remains very wide. There are many tasks where recursive way of thinking gives simpler code and is easier to maintain. Then comes the execution context and stack. So let's just examine how recursive calls work. Now for that, we will look under the hood of functions. Now, information about the process of execution of a running function is stored in its execution context. Now, the execution context is an internal data structure that contains details about the execution of a function, where the control flow is now, the current variables, the value of this, and few other internal details. Now, one function call has exactly one execution context associated with it. Now, when a function makes a nested call, basically four steps happens. The first one is the current function is passed. In the second step, the execution context associated with it is remembered in a special data structure that is called the execution context stack. In the third step, the nested call execute, and in the very end, the old execution context is retrieved from the stack and outer function is resumed from where it stopped. So what happens during the execution of the power 2 raised to the 3 call? Now, in the beginning of the call, so let's just say that you have something like 2 raised to the power 3 here. Now, in the very first call, the execution context will store the variables where the value of x is going to be 2, 3. Now, the execution flow is at line 1 of the function. We can sketch it as x2 and 3 at line number 1. So, that's when the function is going to start executing itself. the condition n equal to 1 is going to be falsy for the first iteration, so the flow continues in the second branch of if. Now the variables are same, but the line is going to change. So in the first iteration, as I am telling you, it is going to be the x value is going to be 2, and the value of n is going to be actually 3 at line number 1. Now, in the second iteration at sorry, in the second context where we have this condition over here, we have actually x equal to 2 and n equal to 3. But when it executes, the value of n is going to be reduced by 1, which means that now in the second iteration, the value of n is going to be 2, which means that now we are dealing with power 2 comma 2 here, which means that here we have 2 comma 2 now. Now to do a nested call, JavaScript remembers the context execution context in its execution context stack. Now here we call the same function POW, but it absolutely doesn't matter. The process is the same for all functions. The current context is remembered on top of the stack. The new context is created for the subcall, and finally when the subcall is finished, the previous context is popped from the stack and its execution continues. So here basically the context stack, when we entered the subcall power 2 comma 2, it has x2 and 2, as well as it also has the x2 and 3 at the execution where it happens at line number 5 here. So the new current execution context is on the top, and both and previous remembered contexts are below. So when we finish the subcall, it is easy to resume the previous context because it keeps both variable and the exact place of the code where it stopped. Then in the third iteration, the process is going to repeat itself and a new subcall is made at line number 5. Now the arguments are going to be x2 and n1. A new execution context is created in the stack where the previous one is pushed on top of the stack. So now at the top of the stack, we have x2 and 1. After that, we have x2 and 2. And then at the third, we have x2 and 3. But the first one, that is x2 and 1, is actually at line number 1, whereas the remaining two, that is x2 and 2 and x2 and 3, are actually at line number 5 because they got executed there. Now there are two old contexts now and one currently running for power 2 comma 1 at line number 1. Then comes the stage where we have to exit because now the value of n is 1. So during the execution of power 2 comma 1, unlike before, the condition is now true. So the first branch of if is going to get executed, and after that there are no more nested calls. So the function finishes returning 2. As the function continues, its execution context is not needed anymore, so it's removed from the memory, and the previous one is restored off the top of the stack. Now the execution of power 2 comma 2 is resumed. It has the result of the subcall 2 comma 1, so it also can finish the execution returning 4. Then the previous context is restored. That was the first one, x2 and 3. When it finishes, we have a result of 2 comma 3 equal to 8. Now the recursion depth in this case is going to be 3. As we can clearly see here, the recursion depth equals the maximum number of contexts in the stack. So if you note the memory requirements, context takes memory. In our case, raising to the power of n actually requires the memory for n contexts for all lower values for n. So basically, if you considered here, then the first iteration at the top is going to be x2 and 3 if you move when the value of n is not 1 and it is 3. So it is going to have x2 and 3. After that, it is going to have x. The value of x is going to remain constant, but this time we are going to have the value of n as 2. This is also going to be a comma. And after that, in the final iteration, the value of x is going to be 2, whereas the value of n is this time going to be 1. Now, this is actually going to stop the execution, and now it is going to move in the opposite direction, because since it is a stack, so it is now going to pop out values from here. So now it is actually going to have 2. So this value over here is going to return 2. After that, this is going to return 4, and this one here is going to return actually 8. So if you have alert 2 raised to the power 3, if I just save this, refresh this, you can see that the answer also here is actually 8. So I hope that you have understood how recursion work. Now, if you have a same loop-based algorithm in memory saving, where you have the same using a for loop, then the iterative power function uses a single context changing I, that is the value that is looping over, and the result variable which actually stored the result in the process. Now its memory requirements are small, fixed, and do not actually depend on n, the value of n. Now, any recursion can be rewritten as a loop. The loop variant usually can be made more effective, but sometimes the rewrite is non-trivial, especially when a function uses different recursive subcalls depending on conditions and merges the result, or when the branching is more intricate. And the optimization may be unneeded and totally not worth the effort. Recursive can give a shorter code, easier to understand and support. Optimizations are not required in every place, and mostly we need a good code. That's why we used recursion in JavaScript. So I hope that you have understood what we have covered so far. In the next tutorial, we are going to talk about recursive traversals, as well as we are going to see how data structures like linked list use recursion. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk about recursive traversals in JavaScript. So that is basically another great application of the recursion, that is recursive traversal. So imagine that we have a company and the staff structure looks something like this, that can be presented as an object. Now, in other words, you can clearly see that the company has department. Now, a department may have an array of staff. For instance, you can see that the sales department here, which is right here, has actually 2 employees, John and Alice, which are the employees of the sales department. Now, a department may split into sub-departments like development, that has 2 branches that are sites and internal. You can see that we have this development which can have this sites and internals, which are sub-department. Now each of them has their own stuff as well. Now it is possible that when a sub-department grows, it divides into sub departments, or you can say teams. Now for instance, the sites department in the future may be split into teams for site A and site B, and they potentially can split even more. Now that is not the picture, just something to have in mind. So now let's just say that we want a function to get the sum of all the salaries. Now how can we do that? Now, the answer is an iterative approach is not easy because the structure is not simple. The first idea may be to make a for loop over company with nested subloops over first level departments, but then we are going to need more nested loops, subloops to iterate over the staff in second level departments like sites, and then another subloop inside those for third level departments that might appear in the future. Now, if we put 3 to 4 nested subloops in the code to traverse a single object, it becomes rather ugly. So why not try recursion? As we can see, when our function gets a department to sum, there are 2 possible cases. The first one is either it's a simple department with an array of people, then we can sum the salaries in a simple loop. And secondly, it is going to be either an object with n subdepartments that we can make n recursive call to get the sum for each of the subdepartments and combine the result. Now, the first case is the base of recursion, that is the trivial case when we get an array, and the second case when we get an object is the recursive step. Complex task is to split into subtasks for smaller departments. They may in turn split again, but sooner or later the split will finish at 1, and that is how the code is going to become short and easy to understand, and that is exactly what is the power of recursion. It also works for any level of sub-department nesting. So we can easily see the principle for an object subcalls, why subcalls are made, while arrays are the leaves of the recursion tree that gives immediate result. So that's why recursion is also helpful in actually recursive traversals. It actually make it easy for you to iterate. Then we can have recursive structures. A recursive data structure is a structure that replicates itself in parts. We have just seen the example of the company structure. A company department is either an array of people or an object with departments. Now, for web developers, there are much better known examples that are HTML and XML documents. In the HTML document, an HTML tag may contain a list of text pieces, HTML comments, other HTML tags that can have div, paragraph elements, h1 tags, and a lot of other things. Now that's once again a recursive definition. Now for better understanding, we will cover one more recursive structure that is named as linked list that might be a better alternative for arrays in some cases. So imagine that we have stored an ordered list of object. So let's just say that we'll remove this from here, and let's just say that we have an array where we have object 1, we have object 2, and we have object 3. Now there is a problem with arrays. Now the delete element and insert element operations are expensive. For instance, array.unshipped object operation has to renumber all elements to make room for a new object, and if the array is big, it is going to take a lot of time. Same goes for array.shift function. Now the only structural modification that do not require a mass renumbering are those that operates with the end of the array. That includes the array.push or pop. So an array can be quite slow for big queues when we have to work with the beginning. Alternatively, if we really need fast insertion or deletion, we can choose another data structure that is called as linked list. Now the linked list element is recursively defined as an object with value, and the next property references the next linked list element or null if that's the end. So a linked list basically looks something like this. Let's just say that we have this one. After that, what we will have is an arrow that references 2. After that, we can have an arrow that references 3. And finally, we can have something like 4 here. Now, basically, these are actually the data part of the arrays, sorry, the linked list. Now, linked list also has one more part, which I told you is the next property that references the next element of the linked list. Now this one, basically the next of this is actually going to be 2. Now the next of 2 is going to be 3. The next of 3 is going to be 4. And the next of 4, which is actually the last element. So the next of it is actually going to be null. Now here we can even more clearly see that there are multiple objects. Each one has the value, and the next is going to point to the neighbor. The list variable is the first object in the chain, so following next pointer from it, we can reach any element. So if you want to reach this 3, so if you start from 1, you can see that you want the 1 next, which means that you want this 3 right over here. So that's how actually linked lists work. So for example, let's just say that you want to remove this one from this linked list right here. Now, what you can simply do is that there is going to be something pointing at this one as well. That is actually the head pointer. So basically, head is actually pointed over here. That indicates that this is the first element. Now, if you want to remove the first element, what you are simply going to do is that you are going to make the head point towards here, and now nothing is going to point here, and you are going to make the one next, which is 2 actually, equal to null, which means that this connection here, which is right here, is going to be removed, and head, which we have already pointed towards here, which means that now this 2 is actually the starting of this linked list, and this over here right here is actually being removed. Now to have backward traversal, you can have also the previous, which is an added property in addition to next, to reference the previous element to move back easily, which is right here. What we can do is point the tail here towards this 4, and now the tail previous is going to be 3, its previous is going to be 2, and its previous is going to be 1. So that's how basically in recursive steps you can actually move from one element to another, then to other, then to other, and finally towards the end. So I hope that you have understood how this data structure of linked list work. I hope that you have understood what we have covered so far. That is an important topic. So that is it with this tutorial. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk about the second part of what we started in the previous tutorial, and in this tutorial we are going to talk about the spread syntax. Now we have just covered in the previous tutorial how to get an array from the list of parameters, but sometimes we need to do exactly the reverse. For instance, there is a built-in function math.max that returns the greatest number from a list. So right here, let's just say that you have alert math.max. Now this is the example which I gave you in the start of the previous tutorial, where math.max, as I told you, is going to give you the greatest number, and that is actually the practical demonstration that I was telling you the truth. You can see that it says 5, which is the greatest number here. Now let's just say that we have an array 351. Now how are we going to call the math.max with it? Now passing it as is not going to work, because math.max expects a list of numeric arguments and not a single array. So right here at the top, let's just say that you have an array that has the 3 parameters which we have right down here, that are 351. And right now if you want to pass in the array here, save this page and refresh that, you can see that it says nan, which means not a number. And surely we can't manually list items in the code like math.max array 0, array 1, array 2, because we may be unsure how many items there are in our array. Now, as our script executes, there could be a lot or there could be none, and that is going to get ugly. Now, spread syntax basically comes to your rescue. It looks familiar to the rest parameter, also using the triple dot format, but does quite the opposite. Now, when you use the dot 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 arr, it is used in the function call. It expands an iterable object array into a list of arguments. Now, if you talk about the math.max, so if you just write in dot 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 here, and then have your array and refresh this page, you can see that you have got the 5 which you required. Now what it do is that the spread actually turns the array into a list of arguments, and after it convert it into a list of arguments, now your math.max function knows that there are 3 elements 351, of which I have to choose the largest, so that's why it chose 5 and gave you the output. Now we can also pass multiple iterables in the very same way, and it is going to act in the same way. So for example, let's just say that you have one more array here that is going to be named as array 1, and let's just say that it has the elements 8, and let's just say 2, and let's just say 9, and let's just say 4, you can just say. Now you can clearly see that the biggest one here is 9 of these two arrays. So you're going to write in ARR, a comma, dot 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 ARR1, which means that you are actually now looking in two arrays. So if you refresh this now, you can see that the output is 9. So that's how you can actually pass multiple iterables. Now we can also combine the spread syntax with normal values as well. For example, right here, you can see that you have these two arrays. So what if I want to also have some parameters like this? And let's just say that I want to also add parameters here. Let's just say I want to add 10, 11 here. So now you can see that of this complete list, 11 is the largest. So if you want to refresh this now, you can see that it says 11 now. So that's how you can even combine the spread syntax with normal values. Also, the spread syntax can be used to actually merge two arrays. Now, how you are going to do that? What you are going to simply do is that right down here, you're going to have a variable merged. And what you're going to write here is dot 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 arr and dot 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 arr1. So we will just alert the array which we have got here. So we will just remove this from here, and right here we are going to write in merged. Save this, refresh this, and you can see that you have got the two arrays here. So in examples here, we used an array to demonstrate the spread syntax, but any iterable will do that. For instance, here what we are going to do is that we are going to use the spread syntax to turn the string into array of characters. Now to do that, what we will do is that we are going to have here, let's just say a string that is going to say hello. Now it is no longer an array, it is a string. So we are going to change this to str. And now what you are going to do is that you are going to simply remove this from here as well. And right here, you are going to write in dot dot dot, and you're going to write in str. Save this and refresh this page. And you are going to see that you have got h. All right, it has got only h because what we missed here was to specify this as this. So now if you run this code, it is going to work perfectly. You can see that now it says h, a comma, then a e, comma, l, comma, l, comma, o, which means that the spread syntax has actually converted the entire string for you. Now the spread syntax internally uses iterators to gather elements the same way as the for of loop goes. Now, so for a string, the for of returns the characters, and the dot 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 str pattern becomes h e l l o. Now the list of character is passed to array initializer. Now for this particular task, we could use also the array from method, array dot from, because it converts an iterable like a string into an array. Now if you want to do the very same here, what you can do is that you can just write in here array dot from, and you can just specify the str here, refresh your browser, and it is going to give you the same output as the dot 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 str did. Now there is a subtle difference between the array dot from and the dot 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 string. The first difference is that the array dot from operates on both array likes and iterable. And the second is that the spread syntax works only with iterable. So for the task of turning something into an array, the array dot from tends to be more universal. Now, the second thing which we are going to learn in this tutorial is to how to copy an array or object. Now, remember when we talked about the object.assign in the previous tutorial, now it is possible to do the same thing with the spread syntax as well. So for that, let's just say that you have an array that is actually equal to 1, 2, not 1.2, but 1, 2, 3. And let's just say that you want to have a copy of that array. So you are going to make it equal to dot 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 array. Now you know that it is going to actually copy your array completely, string, sorry, not string, but element by element, because the spread is going to have the array into a list of parameters and then puts the result into a new array. So right here, if you want to alert JSON dot stringify your array, and you want to check it equal to JSON dot stringify the array copy, then actually this line completely here is actually going to return true because you have this complete copy here. Now, if you want to see if I'm telling you the truth, so you can just write in a triple equal operator and you can just write in a double r copy, but this time it is actually going to actually give you false. Now the reason behind that is that the triple equal operators deal with references. Now both these, the ARR and ARR copy, do not have the same reference, so that's why it is actually going to give you false. But if you want to alert this thing over here is actually going to give you true because the arrays have the same contents, but this over here talks about reference, so that's why it is going to give you false. So if you save this and if you want to refresh your browser, you can see that first you are going to get true because of this statement, and then you're going to get false for this statement. So all right, my bad. You can see that, all right, just refresh this page and you can see that you have got 1 2 3. After that, you have got false. I guess we did something wrong here. Yes, we have to, I think, actually close this and to specify this here. And I think now it is going to work. Yes, we need to just remove this from here and this from here as well. We did something wrong with the brackets. And now it is going to be all right. So now refresh this and you can see that now you got true for the first statement and false for your second statement. Now, what if you want to modify your initial array? Then the question is that does it modify the copy as well or not? Now the answer is simply a no. So if you want to write in array dot push, and let's just say that you want to put 4 into your array, and after that you want to alert the array and you want to alert the array copy. So we will not have this now. Save this, refresh this. Now this is your array and this is the array copy, which means that the element have not been added. Now that is possible to that it is possible to do the same thing to make a copy of an object as well. Now how you are going to make a copy of an object, if you just write in here a let object equal to a1, b2 and C3. So you can see that we have got 3 elements in the first one. You can create an object copy here. Now the object copy is going to be equal to dot and obj. Using the format of the spread syntax, we have actually created the copy, and the spread, what it is going to do is that it's going to take the object into a list of parameters and it is going to then return the result in a new object. Now the question is that do the object have the same reference? For that, what we will do is that we will just remove this from here, and we will just go a bit back, and right here instead of this copy we are going to have your objects here. So what we will do simply is, and we are going to check this and we are going to check the object copy, and I hope that this time we are good with the brackets. Yes, we are. So for now we will just remove this from here. Now if you want to refresh this, you can see that you have got true for your first statement, and you do not need array here. You need to have object, and right here you need to have the object copy. So now let's just refresh this. True for the first and false for the second ref, because the same reasons goes here, because object have a different reference. Object copy as a difference reference. This over here is being referenced by this object, and this, that is the copy here, is being referenced by this object. So that's why it is not it do not have the same reference. So that's why this here is going to return false. And since the elements are same, so that's why this statement over here at line number 4 is going to return true. Now the question again lies whether if you want to modify your initial object, does it modifies the copy or not? Then the answer is the same. It does not modify the copy, and you can check it on your own. So I hope that you have understood what we have covered in this tutorial and the previous tutorial. So to summarize that, when you see the triple dot in the code, it is either the rest parameter or it is either the spread syntax. Now there is an easy way to distinguish between them. There are two things. First, when the triple dot is at the end of the function parameter, consider that it's the rest parameters and gather the rest of the list of arguments into an array. Now, when a triple dot occurs in a function call or a like, it is called a spread syntax and expands an array into a list. Now, use patterns. Rest parameters are used to create functions that accept any number of arguments, whereas the spread syntax is used to pass an array to functions that normally require a list of many arguments. Together, they help to travel between a list and an array of parameters with ease. All arguments of a functions are also available in old-style arguments array-like iterable object. So I hope that you have understood what we have covered in these tutorials. That's it. Thank you so much, guys, for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk about the second part of what we started in the previous tutorial, and in this tutorial we are going to talk about the spread syntax. Now we have just covered in the previous tutorial how to get an array from the list of parameters, but sometimes we need to do exactly the reverse. For instance, there is a built-in function math.max that returns the greatest number from a list. So right here, let's just say that you have alert math.max. Now this is the example which I gave you in the start of the previous tutorial, where math.max, as I told you, is going to give you the greatest number. And that is actually the practical demonstration that I was telling you the truth. You can see that it says 5, which is the greatest number here. Now let's just say that we have an array 351. Now how are we going to call the math.max with it? Now passing it as is not going to work because math.max expects a list of numeric arguments and not a single array. So right here at the top, let's just say that you have an array that has the three parameters which we have right down here, that are 351. And right now, if you want to pass in the array here, save this page and refresh that, you can see that it says nan, which means not a number. And surely we can't manually list items in the code like math.max array 0, array 1, array 2, because we may be unsure how many items there are in our array. Now, as our script executes, there could be a lot or there could be none, and that is going to get ugly. Now, spread syntax basically comes to your rescue. It looks familiar to the rest parameter, also using the triple dot format, but does quite the opposite. Now, when you use the ARR, it is used in the function call. It expands an iterable object array into a list of arguments. Now, if you talk about the math.max, so if you just write in here and then have your array and refresh this page, you can see that you have got the 5 which you required. Now what it do is that the spread actually turns the array into a list of arguments, and after it convert it into a list of arguments, now your math.max function knows that there are 3 elements 351, of which I have to choose the largest. So that's why it chose 5 and gave you the output. Now we can also pass multiple iterables in the very same way, and it is going to act in the same way. So for example, let's just say that you have one more array here that is going to be named as array 1, and let's just say that it has the elements 8, and let's just say 2, and let's just say 9, and let's just say 4, you can just say. Now you can clearly see that the biggest one here is 9 of these two arrays. So you're going to write in a double r, a comma, dot 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 a double r 1, which means that you are actually now looking in two arrays. So if you refresh this now, you can see that the output is 9. So that's how you can actually pass multiple IEEEs. Now we can also combine the spread syntax with normal values as well. For example, right here, you can see that you have these two arrays. So what if I want to also have some parameters like this? And let's just say that I want to also add parameters here. Let's just say I want to add 10, 11 here. So now you can see that of this complete list, 11 is the largest. So if you want to refresh this now, you can see that it says 11 now. So that's how you can even combine the spread syntax with normal values. Also, the spread syntax can be used to actually merge two arrays. Now, how you are going to do that? What you are going to simply do is that right down here, you're going to have a variable merged. And what you're going to write here is dot 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 a double r and dot 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 a double r 1. So we will just alert the array which we have got here. So we will just remove this from here, and right here we are going to write in merged. Save this, refresh this, and you can see that you have got the two arrays here. So in examples here, we used an array to demonstrate the spread syntax, but any IEEE will do that. For instance, here what we are going to do is that we are going to use the spread syntax to turn the string into array of characters. Now to do that, what we will do is that we are going to have here, let's just say a string that is going to say hello. Now it is no longer an array, it is a string. So we are going to change this to str. And now what you are going to do is that you are going to simply remove this from here as well. And right here, you are going to write in dot dot dot, and you're going to write in str. Save this and refresh this page. And you're going to see that you have got h. All right, it has got only h because what we missed here was to specify this as this. So now if you run this code, it is going to work perfectly. You can see that now it says h, a comma, then a e, comma, l, comma, l, comma, o, which means that the spread syntax has actually converted the entire string for you. Now the spread syntax internally uses iterators to gather elements the same way as the for of loop goes. Now, so for a string, the for of returns the characters, and the dot 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 str pattern becomes h e l l o. Now the list of character is passed to array initializer. Now for this particular task, we could use also the array from method, array dot from, because it converts an iterable like a string into an array. Now if you want to do the very same here, what you can do is that you can just write in here array dot from, and you can just specify the str here, refresh your browser, and it is going to give you the same output as the dot 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 str did. Now there is a subtle difference between the array dot from and the dot 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 string. The first difference is that the array dot from operates on both array likes and iterable. And the second is that the spread syntax works only with iterable. So for the task of turning something into an array, the array dot from tends to be more universal. Now, the second thing which we are going to learn in this tutorial is to how to copy an array or object. Now, remember when we talked about the object.assign in the previous tutorial, now it is possible to do the same thing with the spread syntax as well. So for that, let's just say that you have an array that is actually equal to 1, 2, not 1.2, but 1, 2, 3. And let's just say that you want to have a copy of that array. So you are going to make it equal to dot 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 array. Now you know that it is going to actually copy your array completely string, oh sorry, not string, but element by element, because the spread is going to have the array into a list of parameters and then puts the result into a new array. So right here, if you want to alert JSON dot stringify your array, and you want to check it equal to JSON.stringify the array copy, then actually this line completely here is actually going to return true because you have this complete copy here. Now, if you want to see if I'm telling you the truth, so you can just write in a triple equal operator and you can just write in a copy, but this time it is actually going to actually give you false. Now the reason behind that is that the triple equal operators deal with references. Now both these, the ARR and ARR copy, do not have the same reference, so that's why it is actually going to give you false. But if you want to alert this thing over here is actually going to give you true because the arrays have the same contents, but this over here talks about reference, so that's why it is going to give you false. So if you save this and if you want to refresh your browser, you can see that first you are going to get true because of this statement, and then you're going to get false for this statement. So all right, my bad. You can see that, all right, just refresh this page and you can see that you have got 1, 2, 3. After that, you have got false. I guess we did something wrong here. Yes, we have to, I think, actually close this and to specify this here. And I think now it is going to work. Yes, we need to just remove this from here and this from here as well. We did something wrong with the brackets. And now it is going to be all right. So now refresh this and you can see that now you got true for the first statement and false for your second statement. Now, what if you want to modify your initial array? Then the question is that does it modify the copy as well or not? Now the answer is simply a no. So if you want to write in array dot push, and let's just say that you want to put 4 into your array, and after that you want to alert the array and you want to alert the array copy. So we will not have this now. Save this, refresh this. Now this is your array and this is the array copy, which means that the element have not been added. Now that is possible to that it is possible to do the same thing to make a copy of an object as well. Now how you are going to make a copy of an object, if you just write in here let object equal to a1, b2, and C3. So you can see that we have got 3 elements in the first one. You can create an object copy here. Now the object copy is going to be equal to dot and obj. Using the format of the spread syntax, we have actually created the copy, and the spread, what it is going to do is that it's going to take the object into a list of parameters and it is going to then return the result in a new object. Now the question is that do the object have the same reference? For that, what we will do is that we will just remove this from here, and we will just go a bit back, and right here instead of this copy we are going to have your objects here. So what we will do simply is that we are going to check this and we are going to check the object copy, And I hope that this time we are good with the brackets. Yes, we are. So for now, we will just remove this from here. Now, if you want to refresh this, you can see that you have got true for your first statement, and you do not need array here. You need to have object, and right here you need to have the object copy. So now let's just refresh this. True for the first and false for the second ref, because the same reasons goes here, because object have a different reference, object copy has a different reference. This over here is being referenced by this object, and this, that is the copy here, is being referenced by this object. So that's why it is not it do not have the same reference. So that's why this here is going to return false, and since the elements are same, so that's why this statement over here at line number 4 is going to return true. Now the question again lies whether if you want to modify your initial object, does it modifies the copy or not? Then the answer is the same. It does not modify the copy, and you can check it on your own. So I hope that you have understood what we have covered in this tutorial and the previous tutorial. So to summarize that, when you see the triple dot in the code, it is either the rest parameter or it is either the spread syntax. Now there is an easy way to distinguish between them. There are two things. First, when the triple dot is at the end of the function parameter, consider that it's the rest parameters and gather the rest of the list of arguments into an array. Now, when a triple dot occurs in a function call or a like, it is called a spread syntax and expands an array into a list. Now, use patterns. Rest parameters are used to create functions that accept any number of arguments, whereas the spread syntax is used to pass an array to functions that normally require a list of many arguments. Together, they help to travel between a list and an array of parameters with ease. All arguments of a functions are also available in old-style arguments array like iterable object. So I hope that you have understood what we have covered in these tutorials. That's it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this part of the course we are going to talk about variable scope and closure. Now JavaScript is a very function oriented language. It gives us a lot of freedom. A function can be created at any moment. It can be passed as an argument to another function and then called from a totally different place of code later. Now we already know that a function can access variables outside of it that are known as outer variables. Now what happens if outer variables change since a function is created? The question is that will the function gets newer values or the old ones? And what if a function is passed along as an argument and called from another place of code? Will it get access to outer variables at the new place? So let's expand our knowledge to understand these scenarios and more complex ones. We will talk about let or const variables here. In JavaScript, there are three ways to declare a variable. Let and const are the modern ones, and the var, that is the remnant of the past. In this article, we will use let variables in example. Variables declared with const behave the same, so this tutorial is about const 2, and the old var has some notable differences that we are going to cover in the next tutorial. So the first thing we are going to talk about is the code blocks. Now if a variable is declared inside a code block, then it is only visible inside that block. Now for example, if you just write in here let message equal to hello, and now right inside here you want to alert message, we will just move it something like this. All right, now the thing is that actually we will have this here and remove this from here. Now it is good. Now the thing is that it is actually accessible here. So if you refresh your page, you can see that it says hello. But what if you want to remove this from here? and you are going to move it outside this block where actually it is declared. So if you now try to refresh your page, you can see that it says nothing, because as I told you that if a variable is declared inside a code block, which is this in this case, it is only visible inside that block, and if you want to access it outside that, it is actually going to give you an error message. Now we can use this to isolate a piece of code that does its own task with variables that only belongs to it. Now the thing is that, let's just say that we just remove it from here again and paste it here again, and let's just say that we copy this entire block from here and paste it again here, and this time it says hello number 2. So if you want to refresh now, you can see that it says hello, and after that it says hello number 2. Now the reason is that as soon as the code gets out of this block, this variable that is visible only inside this block actually lost its place, and now it can be used again. So that's why we can use this variable again, because this block over here does not know that the variable named as message has been declared inside some block, because this message variable over here is only accessible and visible inside this block. So this block does not see that we already have this variable, so I'm not allowed to use it. But since it does not know that, so that's why it can use it. And also the compiler does not give you an error message. Now there is not going to be an error without blocks. Please note that without separate blocks there would be an error if you use let with the existing variable name. So if you do not have these blocks here, and let's just say that it is a single block of code, or let's just say that we do not have a block of code here at all, then you can clearly see that you already have got a red line, which means that you cannot use a variable twice inside a single piece of code. Now, you already have covered the if, you have covered the for loop, you have covered the while loop, and so on. Now, you know that they all deal with blocks. For example, if you talk about for loop, it is something like this, and after that, you have to assign this. Now, you can see that it actually has a block. Now, whatever variables you declare inside here, so whatever you have here is actually not going to be visible out here. So the same logic which we have discussed goes for all the loops, for the if statements, for everything that is declared inside a single block. Now, what about nested functions? Now, a function is called nested basically when it is created inside another function. Now, it is possible to do that with JavaScript as well. We can use it to organize our code. So, for example, you can have something like for this, and after that, inside the not the for loop but a function, so we are talking about nested functions, and right inside that function, let's just say that you have another function, and as you can see that you have got a function inside another function. Now there is a thing about that, let's just say that this function is named as a1 and this function is named as b1. Now here the nested function, that is the b1, is made for convenience. It can access the outer variable, so can return the whatever we have inside this. So nested functions are quite common in JavaScript. What's much more interested is that a nested function can be returned either as a property of a new object or as a result by itself. It can then be used somewhere else, no matter where. It still has the access to the same outer variables. So let's just see this with the help of an example. So let's just say that you have a function that is named as name make counter. Now inside this function, let's just say that you have a variable that is count that is equal to 0 for initials, and then you just write in return function, and you just write in return count plus plus. So right down here, if you want to have let counter equals to make counter, and you want to have alert the counter. Save this and refresh this. You can see that it says the function itself. My bad, this is not what we want. We want two brackets here as well. Save this now, and it is going to say 0 now. So if you want to call this function again here, save this now, refresh this, you can see that it says 0, and after that it says 1, which means that it is actually going to start its counter. Now, despite these simple, slightly modified variants of that code have practical use, for instance, as a random number generator to generate random values for automated test. Now, how does this work? If we create multiple counters, will they be independent or not? What's going on with the variables here? Now, understanding such thing is great for the overall knowledge of JavaScript and beneficial for more complex scenarios. So let's go a bit in depth, and for clarity, the explanation is going to be split into multiple steps, but we are going to do that in the next tutorial, where I'm going to explain all this behavior using the slideshow. So for this tutorial, that was the practical part. That's it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, where we will be again talking about variable scope and closure. So if you remember this code from the previous tutorial, we have the variable closure, where we have the make counter function where count equal to 0, and it actually incremented the count every time you are going to call this function. As we have seen here, it is going to say 0 and then 1, and as many times as you call this function, this counter is going to get incremented. Now, as I told you in the end, that despite being simple, slightly modified variants of that code have practical uses, for instance, as a random number generator to generate random values for automated test. Now, there are certain questions that arises here. The first one is that how does it work? The second is that if we create multiple counters, the question is that will they be independent or not? And thirdly, what's going on with the variables here? Now, understanding such things is great for the overall knowledge of JavaScript and beneficial for more complex scenarios. So let's go a bit deep in depth and talk about what is a lexical environment. So we will go on to the slideshow as I promised you. So what we are going to do is that for clarity, we are going to split the explanation into multiple steps. So the first step is going to be variables. So in JavaScript, every running function code block and the script as a whole have an internal or hidden associated object known as the lexical environment. Now, the lexical environment object consists of two parts. The first one is the environment record. That is an object that stores all local variable as its properties. And the second part of lexical environment object is the reference to the outer lexical environment, the one associated with the outer code. Now, as the step one was variable, so a variable is just a property of the special internal object, that is the environment record. To get or change a variable means to get or change a property of that object. Now, in this simple code without function, there is only one lexical environment, as you can see. We have let phrase equal to hello, and we have simply alerted the phrase, where you can see that we have only one lexical environment where the phrase is hello and the outer points to null. Now, this is the so-called global lexical environment associated with the whole script. On this picture, the rectangle here means environment record, that is the variable store, and the arrow means the outer reference. The global lexical environment has no outer reference. That's why the arrow at the right hand side points to null. Now, as the code start executing and goes on, the lexical environment actually changes. So here's a bit longer code for you. Now, in here, basically the rectangles on the right hand side demonstrates how the global lexical environment changes during the execution. In the first step, you can see that when the script starts, the lexical environment is pre-populated with all declared variables. Initially, they are in the uninitialized state, as you can see at the very top. Now, that is a special internal state. It means that the engine knows about the variable, but it cannot be referenced until it has been declared with the let keyword. It's almost the same as if the variable did not exist. In the second part, we have let phrase. So it is the definition that has actually appeared now. Now there is no assignment yet, so its value is actually undefined, which you can see in the second block, which means that we can use the variable from this point onward. Now in the third part, where you have let phrase equal to hello, which means that the phrase has been assigned a value now, that is hello. And in the last one, where we have phrase equal to by, which means that the phrase has actually changed the value. Now everything looks simple for now, right? Now, two things here. First, a variable is a property of a special internal object associated with the currently executing block, function, or script. The second is that working with variables is actually working with the properties of that object. Now, lexical environment is a specification object. It only exists theoretically in the language specification to describe how things work. We can't get this object in our code and manipulate it directly. JavaScript engine also may optimize it, discard variables that are unused to save memory, and perform other internal tricks as long as the visible behavior remains as described. So this was step one, that where we deal with variables. Now the second step is the function declarations. Now, a function is also a value like a variable. The difference is that the function declaration is instantly fully initialized. Now, when a lexical environment is created, a function declaration immediately becomes a ready to use function, unlike the let keyword that is unstable till the declaration. That's why we can use a function declared as function declaration even before the declaration itself. For example, if you look at the initial state of the global lexical environment, here when we add a function, you can see that at the very start, when the execution start, phrase was initialized, but we have say as the function where the outer points to null. Now, naturally, this behavior only applies to function declarations, not function expressions where we assign a function to a variable, such as, let's say, equal to function name. So right here you can see that even before the declaration happens, we have the declarations itself. Moving on to the third step, that is the inner and outer lexical environment. Now when a function runs at the beginning of the call, a new lexical environment is created automatically to store local variables and parameter of the call. For instance, if you have a look at this diagram, so for say John, it looks like this. The execution is at the line labeled with an arrow. So we have let phrase equal to hello, function say name, alert phrase name, and at the bottom you can see that we have say John. Now during the function call, we have two lexical environments. The first one is the inner one, that is for the function call, and the outer one is actually that is global. The inner lexical environment actually corresponds to the current execution of the say function. It has a single property, that is name, the function argument. We called say John, so the value of name is John. The outer lexical environment is the global lexical environment, and it has the phrase variable and the function itself. Now the inner lexical environment has a reference to the outer one as well. So if you have a look at this diagram, you can see that. So when the code wants to access a variable, the inner lexical environment is going to be searched first, then the outer one, then the more outer one, and so on until the global one. Now, if a variable is not found anywhere, that's an error in strict mode. So without use strict, and assignment to a non-existing variables create a new global variable for compatibility with old code. Now, in this example, the search proceeds as follow. For the name variable, the alert inside say find it immediately in the inner lexical environment. When it want to access the phrase, then there is no phrase locally. So it follows the reference to the outer lexical environment and find it there and print it out hello John for you, as you can see here. Now the step number 4 is to return a function. So let's return to the make counter example which we have. So right here we have the make counter example. Now at the beginning of each make counter call, a new lexical environment object is created to store variables for this make counter run. So we have two nested lexical environments in the example above. So you can see that we have a function make counter, then we have a lexical environment of the make counter call, and then we have the global lexical environment. Now what's different is that during the execution of the make counter function, a tiny nested function is created of only one line, that is return count plus plus. We don't run it yet, only we created it. Now all functions remember the lexical environment in which they were actually made. Technically, there is no magic here. All functions have the hidden property named environment that keeps the reference to the lexical environment where the function was created. So counter.environment has the reference to count 0 lexical environment. That's how the function remember where it was created, no matter where it was called. So the environment reference is set once and forever at function created creation time. So later, what we have is this diagram. When the counter is called, a new lexical environment is created for the call, and its outer lexical environment reference is taken from the counter.environment. So now when the code inside the counter look for the count variable, it first searches its own lexical environment, which is empty as there are no local variables there. Then the lexical environment of the outer make counter call where it finds and exchange it. Now a variable is updated in the lexical environment where it lives. So here is the state after the final execution. You can see that finally we have the count as a 1. So if we call counter multiple times, the count variable will be increased to 2, 3, and so on at the same place, which is the modifying place right over here. So closure, there is a general programming term closure that developers generally should know. Closure is a function that remembers its outer variables and it can access them. In some languages, that is not possible, or a function should be written in a special way to make it happen. But as explained above, in JavaScript, all functions are naturally closures. That is the environment, they remember where they were created using a hidden environment property, which you have seen, and then their code can access outer variables. So when on an interview, a front end developer, if he gets a question that what is a closure, a valid answer would be a definition of the closure and an explanation that all functions in JavaScript are actually closures, and maybe a few more words about technical details. That is the environment property and how lexical environment work, and that is actually going to impress your interviewer and get you a job. So I hope that you have understood what we have covered here. We are going to discuss more about variable scope and closure, where we are going to talk about garbage collection. But I think we are going to do that in the next tutorial. For this tutorial, that's it. Thank you so much, guys, for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to continue on with variable scope and closure. So as I told you that we are going to talk about garbage collection, so usually a lexical environment is removed from memory with all the variables after the function call finishes. Now the reason behind that is that there are no references to it. As any JavaScript object, it is only kept in memory where it is actually reachable. However, if there is a nested function, let's just say, that is still reachable after the end of the function, then it has actually the environment property that references the lexical environment. In that case, the lexical environment is still reachable even after the completion of the function, so it stays alive. For example, if you have a function f, and in that function what you have is let's say a value that is going to be, let's just say, lue, and it is going to be 123. Now what you want to do is that you want to add a return function, and inside the return function what you want to do is that you want to alert the value. So right here, if you just write in let g equal to f, and if you run this code, let's just see the output. You can see that it says nothing for now because we have actually alerted the value here. So it is going to be g dot environment that stores a reference to the lexical environment of the corresponding f call. So please note that if f is called many times and resulting functions are saved, then all corresponding lexical environment objects will also be retained in the memory. So what if we want to make three calls? So for that, if you just remove this from here and right here, we just write in math dot random. Now right here, we are going to have return function, alert value, and right down here, we are actually going to store it in an array. Now the values of array, the first one is going to be whatever returns from this function. The second one is going to be from whatever returned from this function. And the third is also going to be what is returned from this function. So in the code here, all three of them are these. A lexical environment object dies when it becomes unreachable, just like any other object. In other words, it exists only where there is at least one nesting function referencing it. So basically in here, three functions in array, every one of them links to lexical environment from the corresponding f run. So in here, what we are now going to do is that after the nested function is removed, we are going to see if its closing lexical environment is cleaned from the memory or not. So let's just say that we move back and we get it to 123. And right here, we have only a single function call, and right down here we just write in that arr equal to null. So right here, while this array function exists, the value stays in memory. And now when you write in arr equal to null, so which means that the memory is actually cleaned up. So this is about how garbage collection is done in the lexical environment. The second part of this tutorial is about real-life optimizations. So as we have seen in theory, while a function is alive, all its outer variables are also retained. But in practice, JavaScript engines try to optimize that. They analyze variable usage, and if it's obvious from the code that an outer variable is not used, it is actually removed. An important side effect in V8, that is Chrome, Edge, and Opera, is that such variables will become unavailable in debugging. So this is basically, if you try running the example like this, where we have the previous, where we have the mat.random, and let's just say that after that we have here a function that is named as g, and right here if we have a debugger. So in console type alert value, no such variable exists. So right here, if you write and return a G, and write down here, if you replace this arr with G, and you now call in G, and save this and run this code, you can see that it did not work. And as I told you, if you try running this example below in Chrome with the developer tools open, when it pauses in the console, type alert value. But since we are not using it in with the developer tools on, so that's why it is going to be something like this. So there is no such variable. In theory, it should be accessible, but the engine optimizes it out. Now, this feature of V8 is good to know if you are debugging with Chrome, Edge, or Opera. Sooner or later, you will meet it, but you have to remember that you have to actually keep the developer tools open. So this is not a bug in the debugger, but rather a special feature of V8. Perhaps it will change sometimes. You can always check for it by running the examples we have covered here. And we are also going to give you some in the tasks so you can actually run them and see how V8 works. So I hope that you have understood what we have covered about variable scope and closure in the previous two tutorials and in this tutorials. So that is it. Thank you so much guys for watching, and I will see you guys later. Guys, what's up? I welcome you to another tutorial on this course, and in this part of the course we are going to talk about the old way of initializing, that is the VAR. Now, the information in this tutorial is useful for understanding old script. That's not how we write new code. So if you are not interested in the past, you can just skip this tutorial. But if you want to increase your knowledge, then you're more than welcome to watch this. Now, in the very start about variables, we mentioned that there are three types of variable declaration, that are the let const, that are the modern ways of having variables, and then the old one is the VAR form. Now, the VAR declaration is similar to the let. Most of the time, we can replace the let by var or vice versa and expect things to work. But the thing is that internally, VAR is a very different beast that originates from very old time. It's generally not used in modern script, but still lurks in the old ones. If you don't plan on meeting such scripts, you may even skip this tutorial or postpone it. On the other hand, it's important to understand differences when migrating old script from VAR to let to avoid odd errors. So that is the motivation for you guys to actually continue on with this tutorial. The first thing is that VAR has no block scope. Now, variables declared with the var are either function scoped or global scoped. They are visible through blocks. For instance, if you have something like if true, what you want to do is that you want to write in VAR test equal to true. So write down here if you want to alert the test, you can see that since it has been initialized inside this block, and you remember from the previous tutorials that if you have a variable inside a certain block, it is only accessible inside that block. But right here, you can see that we are trying to access this test variable outside the block where it has been initialized. So let's just see that what is the output here. You can see that we were able to access that. And if you just change it to let, save this now, refresh this, you can see that you see nothing, which means that let test equal to true, but now test is not accessible outside. Whereas if you used VAR here, then test was actually accessible outside the block. That indicates that VAR has no block scope. Now, as VAR ignores the code blocks, we got a global variable test. Now, as you have seen that when we use let instead, it did not work. Now, the same things for loops. VAR cannot be block or loop local. So the same logic goes there. Now, if a code block is inside a function, then VAR becomes a function level variable, and actually it can be used somewhere inside that function. So for functions, let's just say that you have a function that says hi. Now inside this function, you are going to have if true, you are going to have a variable that is going to be initialized using var, that is going to be named as phrase equals to hello. And now right down here, you are going to alert the VAR. Now you can clearly see that it has been initialized inside this block here. So, which means that it should not be accessible right here. It is not going to be var, but it is going to be phrase. So, but if you run this code, but you cannot run it like that, you have to first call this function actually. So now let's just run it and see what happens. You can see that it says hello, which means that it was allowed to access it outside the block where it was actually initialized. But what if you want to access the phrase right here? So if you want to have phrase right here and you just remove this from here for now, refresh that and you can see that you see nothing. Now the reason behind that was that it is actually a reference error because phrase is not defined. As we can see that var pierces through if, for, or other code blocks. Now that's because a long time ago in JavaScript block had no lexical environment and var is remnant of that. Now to another thing about var. Now var actually tolerates redeclarations. For instance, if you just remove this from here and let's just say that you have a variable a that equal to 3 and right down here you again want to have a equal to 4, you can clearly see that you have got a red line, which means that you are not allowed to have redeclarations when you are using let. But right here, if you replace them with var, you can see that it does not give you an error, but the question is that which value is now alert A going to print for you? The answer is the latest one, which means 4 is going to be the output in this case, as you can clearly see. One more thing about var is that var variables can be declared below their use. Var declarations are processed when the function starts or the script start for globals. In other words, var variables are defined from the beginning of the function no matter where the definition is, assuming that the function definition is not in the nested function. So for the very same code previously we had in this function, let's just say that we only have phrase equal to hello, and then you want to write an alert phrase, and after that you want to have the declaration part. So you already have called the function. We will just remove this from here, save this, refresh, and you can see that you can see hello. But now if you remove this from here, and you have to actually not save this, but you have to save this, and now refresh your browser, you can see that you also see hello here, which means that var variables are defined from the beginning of the function no matter where the definition is. Now it is technically the same as this, that you move this var right here, it is going to work in the same manner. Or even as this remember code blocks are ignored, it is going to even work in that pattern. So people also call such behavior hoisting or raising because all var are hoisted to the top of the function. So that's why right here, if you have var phrase here, it is actually going to make it move at the top automatically. So then comes the IIFE. In the past, as there was only var and it has no block level visibility, programmers invented a way to emulate it. What they did was called immediate invoked function expression, that is abbreviated as IIFE. That's not something we should use nowadays, but you can find them in old scripts. So an IIFE looks something like this. You have to have a function, and inside that you can have var message equal to hello, and then you can just write an alert, not hello but alert the message, and then these two brackets here. Now here a function expression is created and immediately called. So the code executes right away and its own has its own private variables. The function expression is wrapped with parentheses because when JavaScript engine encounters the function in the main code, it understands it as the part of the function declaration, but a function declaration must have a name. So this kind of code will give you an error message if you just remove these brackets from here. Then this over here, as you can clearly see, it is going to give you an error. So you have to apply these brackets here to enclose this function along with its body inside the parentheses. So I hope you have understood what we have covered here. There are two main differences of var compared to the let or const. Var variables have no code block or the block scope. Their visibility is scoped to current function or global if declared outside function. Second is that var declarations are processed at function start. There is one more minor difference related to the global object that we will cover later. These differences make var worse than let most of the time. Block level variable is such a great thing. That's why let was introduced in the standard long ago and is now a major way along with const to declare a variable, and that's why we don't use var anymore. So I hope that you have understood what we have covered about the old var here. That was just for knowledge purposes. We don't use it anymore. So that is it with this tutorial. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this part of the course we are going to talk about decorators and forwarding and call or apply. Now JavaScript gives exceptional flexibility when dealing with functions. They can be passed around, used as objects, and now we are going to see how to forward calls between them and actually decorate them using decorators. The first thing which we are going to learn in this tutorial is about transparent caching. So the first thing we need to do here is that we need to have a function that is going to be named as slow. X is going to be the parameter of this function here. So let's just say that we have this function slow x, which is CPU heavy, but its results are stable. In other words, for the same x, it returns always the same result. Now, if the function is called often, we may want to cache it or remember it and remember the results to avoid spending extra time on recalculations. But instead of adding that functionality into the slow function, we will create a wrapper function that adds caching. As we are going to see that there are many benefits of doing what we are going to do here. So let's just see the code so that we can understand how we are going to decorate it. So there can be a heavy CPU intensive job where we can just write an alert. And right here, we are going to write an call with a dollar sign and X. So we will just consider that this is some very heavy CPU function going on inside this slow function. Now what we are going to do, as I told you, that instead of adding the functionality into the slow function, we are going to create a wrapper function that is going to do the caching for us. So what we are going to name this function, since we are talking about caching, so we are going to name it as caching, and since we want to decorate it, so this function is going to be named as caching decorator, and it is going to receive a function in its parameter. So inside this function, the first thing which we are going to do is that we are going to have our cache, and we are going to create a new map here. Now after that, what we are going to do is that we are going to actually return the function x here. And inside the function, what we are going to do is that we are going to check if there is such key in cache. So if there is such a key in cache, we are going to read the result from it. So we are going to check for the value of x here. So we are going to check if the cache dot has x, which is what we are looking for. So if it has what we are looking for, we are going to return the cache dot, we are going to return x using the cache dot get method. Now, after the if statement, what we are going to do is that what we also want to return as a whole from this function x is the result, where actually we are going to call the function and pass x to that function. Now, this func which we are talking about here is this function that is slow right here, which is going to be called inside from this caching and decorator here. So after that, at the very end, we are going to write in cache dot set and x as result. So it is going to store x in the result, and finally it is going to return the result. So outside these two functions, now what we are going to do is that we are going to have a variable slow, and it is going to actually call the caching decorator function, and we are going to pass in the function slow to that. So basically what it received in the parameters here is actually this function slow, which we have passed as a parameter to this caching decorator function. So it is going to first create a map. Then what it is going to do is that it is going to return function x. It is going to check for the value of x. If it has, it is going to call the function x, and it is going to set the x as the resultant value. So right down here, if you want to alert slow 1, then slow 1 is actually cached and the result is going to be returned. So if you save this, refresh this, and you can see that it says called with 1, and then it is going to say 1, which means that this over here is going to be printed, that is going to say called with a 1, which is exactly what we have. Now after this, what we are going to do is that we are going to call in alert again slow 1. So now if you refresh this, low one result is going to be returned from cached. For the first call, actually, this one is going to first get cache, and after that, the result is going to be returned. So we will just remove this from here for now, save this, and you can see that first it is going to actually cache called with 1, and then it is going to return the result. But for the second call, if you just save this now, refresh this, it is going to say called with 1 1 and then again 1, and this time you can see that it did not printed me this. So if I just remove this alert statement from here, so since now for the first call, this value is going to get cached, which means that this if condition is now going to be true, which means that it is directly going to return the cache results because it has the value of x as 1 now. So if you refresh this page, you can see that it says called with 1, and after that it is going to say again 1. So that is exactly what is going on here. So, for example, you now want to have alert and you want to have slow, and this time you want to change the value to 3, let's just say. So you can see that 3 is not a part of cache here. So we will also add an alert statement over here. And now save this, and now if you refresh this page, now for the first call it is going to have called with 1, and then it is going to return 1 for you, and after that for the second call that says alert again with 1, it is going to say again 1, then for the second one it is going to say called with 3, and then it is also going to return 3 because 3 is not a part of cache for the first call. But what it is going to do is that it is actually going to cache that. Now, 3 is also a part of your cache. So if you want to have alert and just copy this from here, paste it here and have 3 over here, save this and refresh this, you can see that it says called with 1, then 1, and again 1, and not going to return because it is a part of cache. then it is going to say called with 3, return 3, and after that when you again call it with 3, since 3 is a part of cache, so it is only going to get the result from the cache and not return it. So as you can clearly see that how it is actually working in this, the caching decorator function is actually a decorator that is a special function that takes another function and it actually alter the behavior of that function which is passed as a parameter to this caching decorator function. Now the idea is that when we call the caching decorator for any function and it will return the caching wrapper, that is great because we can have many functions that could use such a feature and all we need to do is to apply the caching decorator to them. Now by separating caching from the main function code, we also keep the main code simpler. The result of caching decorator with function in its parameter is a wrapper function X that wraps the call of funcX into caching logic. Now, from an outside code, the wrapped slow function still does the same. It just got a caching aspect added to its behavior. Now, to summarize, there are several benefits of using a separate caching decorator instead of altering the code of the slow function itself. First is that the caching decorator is reusable, which means that we can apply it to another function. The second benefit is that caching logic is a separate, it did not increase the complexity of the slow function itself if there was any. The third benefit is that we can combine multiple decorators if needed. Other decorators are going to follow. So I hope that you have got a basic idea of a caching decorator, or you can say simply decorators. In the next tutorial, we are going to talk more about this. So for this tutorial, that is it. Thank you so much guys for watching and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course. And as you know that we are talking about decorators and forwarding with call or apply. So in this tutorial, we are going to talk about call and we are going to see how you are going to use the func.call for the context. Now the caching decorator, which we have mentioned in the previous tutorial, is not suited to work with object method. For instance, what we are going to do is that right here, we are going to have a variable that is going to be named as worker. Now what we are going to do is that we are going to have the make worker dot slow caching. So we are going to have some method here, not like this, but this is going to be a call here. So right inside here, we are going to simply write in return 1. And now what we are going to do here is that we are going to add a comma and we are going to have our previous function that was the slow x function. But and you know that this was something that was a scary CPU heavy task here. And right here we are going to have x and after that we are going to have static this dot some method and we are going to have the closing brackets which we deleted. So right here you can see that we are going to make this worker dot slow caching and we are going to have the same decorator function. Now right down at the very end, if we write in alert worker dot slow and pass in 1, what it is going to do is that it is going to make the original method work. So if you save this, refresh this, you can see that it says called with 1 and it is going to return 1 in the very same way. And actually it is actually calling this slow function right here. Now what if right down here I try to write in something like worker dot slow and make it equal to the caching decorator and passed in worker dot slow here, which means that now we are make it caching. So just save this and write down here if you now want to have alert worker dot slow and pass in 2, then actually that is going to be an error because it cannot read the property of the function sum method, and it is going to be undefined. Now the error occur in this line number 26 that tried to access this dot sum method, and it actually failed. Now can you see why? The reason is that the wrapper calls the original function as funcx, and when called like that, the function gets this equal to undefined, which we have right here. So this dot sum method is actually going to give you an error message. So we would observe a similar symptom if we try to run in let func equal to worker dot slow and then call in func and pass in 2 to that. So the wrapper passes the call to the original method but without the context of this, hence the error occurs. Now the question is that how you are going to fix it. Now there is a special built-in function method that is known as func.call, and it has two parameters. The first one is the context and the second one is the arguments. Now it can have as many arguments as you like, and that function is going to allow you to call a function explicitly setting the this. Now the syntax is actually func.call context, and after that you can have as many arguments as you like. It runs the func providing the first argument as this and the next as the arguments. To put it simply, what we are going to do is we will just remove this from here, and we are going to have not remove this, but what we are going to do is that we are going to have func and we are going to pass in 1 2 3 to it, and after that we are going to have func dot call and we are going to pass an object, and after that we are going to pass in the parameters. Now these two calls do almost the same. They both call func with arguments 1 2 3. The only difference is that func.call also set this keyword to the object, that is obj, that is the first parameter here. Now as an example, what we are going to do is that we will just remove all this from here, and we are going to have a function say hi. To keep it simple, what we are going to do is that it is only going to alert this dot name. Now outside this function we are going to have user equal to name as John, and we are going to have admin equal to name as admin. Now what we are going to do is that we are going to use the call to pass different object as the this keyword. So right down here we are going to say hi dot the call method, and we are going to pass in user. Now if you run this, it is going to print out John for you, and if you have say hi dot call and you pass in admin, it is actually going to give you admin. So if you refresh this, you can see that it says John, and after that it says admin as an output. Here we use the call to say with the given context and phrase. So if you have something as a parameter here, let's just say phrase here, and then you have alert this dot name plus the phrase. So what we are going to do is that for the user right here, where we are calling the that we are going to actually add hello here. So we will just remove this admin for now. Save this and refresh this, and you can see that it says John hello. So in our case, we can use the call in the wrapper to pass the context to the original function. So we will just remove this from here, and what we are going to do is that we are going to get our previous caching function back. So you know that we had error with this, that was line number 3, where we were trying to have worker dot slow to, and the reason behind that was it cannot read the property of the some method function because of the this keyword. So right here we are going to fix that using the concept of the call function, which we have learned just now. So to do that, what we are going to do is that right down here, we will just remove this from here, and worker.slow is going to equal to caching decorators. Now it is going to, here it is going to have the caching part. After that, what we are going to do is that we are going to have this. Now this over here is actually going to work, but what you are going to add here is that you are not going to have a simple func, but you are going to have func dot call, and you are going to have this comma x. And what it is going to do is that basically that this keyword is passed correctly now, and now it is going to make it work. So the first statement here is actually going to work, and if you copy this and paste it again here, then this statement is also going to work, but it doesn't call the original because it is going to call the cached value now. So now everything is fine. To make it clear, let's mm, see more deeply how the this keyword is passed along. Now, after the declaration, worker.slow is now the wrapper function. So when the worker.slow is executed, the wrapper gets 2 as an argument, and this equal to worker, it's the object before dot. Now inside the wrapper, assuming the result is not yet cached, the func.call this comma x passes the current this equal to worker and the current argument equal to 2 to the original method, which is right here. So you can fix your problem of reference undefined using this comma x here and the call function. So I hope that you have understood what we have covered here. In the next tutorial, we are going to talk about the apply function. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course. And in this tutorial, before we move on to the apply function, we are going to talk about how to deal with multi-arguments. So let's make the caching decorator even more universal. Till now, it was working only with single argument function. Now, how to cache the multi-argument worker.slow method. Now to do that, what we are going to do is that we are going to have certain changes. Now inside here where we are having this slow function, right here what we are going to do is that we are going to have a min and we are going to have a max. And what we want to return actually is going to be right here. We are going to, not like this, but we are going to return min plus max. And the work.slow over here is going to remain the very same, where worker.slow is going to equal to the caching decorator with worker.slow in the parameters. Now previously for a single argument x, we could just have cache.set, and in the set method we could have the x and the result. To save the result, and cache.get x is actually going to right here, the cache.x get x is actually going to retrieve the result which we had set using the cache.set. Now we need to remember the result for a combination of arguments that are min and max. The native map takes single value only as the key. Now there are many possible solutions for that. We will discuss 3. The first solution is to implement a new or use a third-party map-like data structure that is more versatile and allows multiple keys. The second is to use nested maps. Now cache.set min will be a map that stores the pair max comma result, so we can get result as cache.getMin dot get max. The third is to join two values into one. In our particular case, we can just use a string min comma max as the map key. For flexibility, we can allow to provide a hashing function for the decorator that knows how to make one value from many. Now, for many practical application, the third variant is good enough, so we are going to stick to it. Also, we need to pass not just x, but all arguments in function.call. So let's recall that in a function, we can get a pseudo array of its arguments as arguments keyword. So func.call with this comma x right here in line number 17 could be replaced with func.call with this keyword right here. But this time it should be something like dot arguments. Now you have already covered that in the previous tutorials, which is going to make a very powerful caching decorator for you. So moving on towards our original code here, what we will do is that we don't need this anymore now. Now inside this slow function, what we are going to do is that we are going to have some changes here where we are going to write in called with min, comma, a dollar sign again, and we are going to write in max over here, which means that it was called with min and it was also called with max, and it is going to finally return min plus max. Now, as I told you that the caching decorator is now going to not only receive this func, but it is also going to receive a hashing function. Now, the purpose of this hashing function, what this hashing function is going to do simply is that it is going to know how to make one value from many. So right here we are going to receive a hashing function as well. Now right here we are going to make certain changes inside this part of the code as well. Now inside the return function x, before we go on and have the if condition, we are going to have let key equal to hash, and we are going to actually hash the arguments which we have. Now, in this case, the min and the max values. So, in this line, it basically calls the hash to create a single key from arguments. Here, we will use a simple joining function that turns the arguments, let's just say 3 and 5, into the key 3, 5 in a single value. So more complex cases may require other hashing functions, but this over here is going to help us deal with 2 to 3 arguments. So right here, we are going to check if cache.has, and we are going to check for key now, and we are going to also get the key here, because whatever we passed as an argument to this hashing function, it is going to convert that into single value. For instance, if you have 3 comma 5, it is going to convert that into something like 3 5, which means a single value. So that is why we are using this hashing function here. So after that, in the result here, we are going to have func.call, and as I told you, it is going to be this comma dot and arguments. Now what is going on here is that this uses the func.call to pass both the context and all the arguments the wrapper got, not just the first one, to the original function. Now, what we also need to do is that the cache.set is going to basically change, and instead of this, it is going to have key that is going to have whatever arguments we passed in as a single value. And finally, we are going to return the result. Now, after here, we are going to have our function that was known as hash. It is going to have some arguments, and right here it is going to return the args number 0 plus a comma plus args1, which means that we are dealing with only two values now. If you want to add more, just add a plus sign, args2, args3, and so on till the end. So now right down here, we also need to make some changing. Now the first statement, as you know, is due to perform the caching operation, but now it is not only going to perform the caching operation, but we also want it to perform the hashing operation as well. So that's why we are going to also add hash here. Now worker.slow is going to actually receive two arguments. So let's just say we pass in 3 and 5. So it is going to simply work. Now right here, if you want to have an again statement, so we are going to have again a plus sign and worker.slow, and this time it is going to be 3 and 5. So if you save this page, refresh it, you can see that it says call with 3, 5. It is going to return 8, which was the sum because what we returned was min plus max. And after that, it is going to say again 8. So that's how it is works. So it works with any number of arguments, though the hash function would also need to be adjusted to allow any number of arguments. As I told you, what you need to simply do is that just add a plus sign here and just add args2 and so on, whatever number of arguments you like to, because this dot 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 arguments, as we have learned previously, is going to receive as many arguments as you like. So I hope that you are cleared with that. So let's just move on to the func.apply function, which was the part of this tutorial. So instead of func.call, which we have been using up till now, we could use the func.apply, which is going to have the first parameter as this and the second parameter as arguments. Now the syntax of the built-in method func.apply is something like this: func.apply, and in the parameter, the first thing is the context, and the second one is the args. Now it runs the function setting this equal to context and using an array-like object of args as the list of arguments. Now the only syntax difference between the call and apply is that call expects a list of arguments while apply takes an array-like object with them. So basically, the two calls, which are func.call, where we have context, but this time it is going to be dot 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 args. So you can say that these two calls are almost equivalent. They perform the same call of func with given context and arguments. There's only a subtle difference regarding the arguments. Now the spread syntax, that is the triple dot, allows to pass iterable arguments as the list to the call function, whereas the apply accept only array-like arguments. Now as and for objects that are both iterables and array-like, such as a real array, we can use any of these methods, but apply will probably be faster because most JavaScript engines internally optimize it better. So passing all arguments along with the context of another function is called call forwarding. That's the simplest form of it, where you can have not function, but you can have a wrapper equal to a function, where you can have func return func dot apply, where you can have this and you can have the arguments you like. So this is the simplest form of it. When an external code calls such wrapper, it is indistinguishable from the call of the original function func. So I hope that you have understood the basics of the apply function as well as the difference between the call and apply function. So we will just remove this from here. In the next tutorial, we are going to talk more about the apply function. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk more on what we are covering, that is decorators and forwarding. And in this tutorial we are going to see how you are going to borrow a method. So for that, what we will do is that we will just copy this and we are going to paste it right over here. And what we are going to do is that we are going to make one minor improvement in the hashing function, which is right here, that we have return args0 plus this plus args1. As of now, it works only with two arguments. Now, it would be better if it could glue any number of arguments. Now, the natural solution, which you might be thinking, is to use the array.join method, but unfortunately, that is not going to work because we are calling hash arguments. An arguments object is both iterable and array-like, but not a real array. So calling join on it would fail if you have arguments dot join inside the hash function. But what we are going to do is there is an easy way to use the array dot join, that is using the call function. So what we are going to do is that inside the hash function, what you can simply do is that you can just write an alert. You can have arguments dot join, not arguments, but you can have the array completely. You can have dot join dot call, and then in the parameters you can pass in the arguments, and that is going to work just fine. So if you call in the hash function on that, have 1 2 here, and run this code only, it is going to return 1 and 2 as a single value to you. So this trick is basically known as method borrowing. We take a join method from a regular array like this, where we have this call here, and we uses the this array.join.call to run it in the context of argument. Now the question is that why does it work? Now that's because the internal algorithm of the naive method array.join is very simple. Taken from the specification almost as is, let's say that we have something like array.join, and in the parameter we have this glue. We do not want a built-in, but we want arr.join. So let glue be the first argument, or if no arguments, then a comma. Let result be an empty string. Append this 0 to result, append glue and this 1, append glue and this 2. Do so until this dot length items are glue, and finally return the result. So technically it takes this and join this 0, this 1, and so on together. It's intentionally written in a way that allows any array like this, not a coincidence. Many method follow the practice. That's why it also work with this equal to arguments. So the last thing which we are going to study is about the decorators and function properties. Now it is generally safe to replace a function or a method with a decorated one, except for one little thing. If the original function had properties on it like func.called_count or whatever, then the decorated one will not provide them because that is a wrapper. So one needs to be very careful if you use them. For example, in the example here, if the slow function had any properties on it, then the caching decorator with slow in its parameter is a wrapper without them. Now, some decorators may provide their own property. For example, a decorator may count how many times a function was invoked and how much time it took, and expose this information via wrapper properties. Now, there exists a way to create decorators that keep access to function properties, but this requires using a special proxy object to wrap a function. But we are going to discuss it later in the tutorial, where we are going to talk about proxy and reflect. So for this tutorial, that is it. To summarize what we have covered so far, we have talked about what is a decorator, that is a wrapper around a function that alter its behavior. The main job is still carried out by the function. Then we have seen that decorator can be seen as features or aspects that can be added to a function. We can add one or add many, and all this without changing its code. implement the caching decorator, we studied the method func.call and func.apply as well. Then we see the generic call forwarding is usually done with the apply function. We also saw some examples of method borrowing when we take a method from an object and call it in the context of another object. It is quite common to take array methods and apply them to arguments. The alternative is to use rest parameter object, that is a real array. There are many decorators there are in the wild. Check how well you got them by solving the tasks which are going to be provided at the end of this section. So I hope that you have got what we have covered in this tutorial. It was a very important topic. Decorators is something which you are going to use when you are dealing with a high level code where you have some very high CPU heavy tasks going on. So that's why if you need stable results, you are going to need decorators. So that is it with this tutorial. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course where we are going to start on with events. And the first thing we are going to talk about is the introduction to browser events. Now, an event is basically a signal that something has actually happened. All DOM nodes generate such signals, but events are not limited to the DOM. So here is a list of the most useful DOM event just to take a look at, where at the top you can see that you have got the mouse events. In the mouse event, the first one is the click. Now it is when the mouse clicks on an element in touchscreen devices generates it actually on a tab. Then the second one is the context menu, that is when the mouse right clicks on an element. When we have the mouse over or mouse out, that is when the mouse cursor comes over or leaves an element. Then we have the mouse down or mouse up, that is when the mouse button is pressed or released over an element. And finally, we have the mouse move, that is when the mouse is actually moved. In the second type, we have got the keyboard events. And in the keyboard events, we have the key down and key up. That is when a keyboard key is pressed and released. After that, we have the form element events where we have the submit and focus. Submit is when the user submits a form, and focus is when the visitor focuses on an element, for example, an input tag. Then we have the document events in which we have the DOM content loaded. That is when the HTML is loaded and processed. Now DOM is actually fully built. Then we have the CSS events in which we have transition end, that is when a CSS animation finishes. Now there are a lot of other events as well. We are going to go into more detail of particular events in upcoming tutorials. So what is basically an event handler? Now to react on events, we can actually assign a handler that is going to be a function that runs in case of an event. Now, handlers are that's basically a way to run the JavaScript code in case of user actions. Now, there are several ways to actually assign a handler. So let's see them starting from the simple one, that is going to be using an HTML attribute. Now, a handler can be set in HTML with an attribute that is going to be named as on, and after that, it is going to have an event, and the event is going to be what we have discussed. So it can be on click, on context menu, on mouse over or out, and so on. So to assign a click handler for an input right here, what you are going to do is that you are going to, let's just say, have an input here. The value here, the type is going to be button. And right in here, what you're going to do is that you are going to assign a value to this button that is going to be click me, and on, that is basically the format. And after that, you have to actually write in the event which we have just discussed. So let's just say we want to have the very simplest event that is going to be on click. And on click, what I want to do is that I want to do the simplest of all, that is alert. And inside that, we are going to simply write in clicked, which means that it is going to alert clicked whenever this button is clicked. So on mouse click, the code inside the on click is going to run. Now you can see that inside the on click we use single quotes because the attribute itself is in double quotes. So if you forget that the code is inside the attribute and use double quote inside this, then it is not going to work. So whatever you have inside these brackets of alert, are going to be in single quotes because the attribute, as you can see here, the on click is in double quotes. So double quotes inside this is not going to work actually. So if you now save this and you go towards your browser, refresh this, you can see that you have got click me button. So if you click on it, you can say that it is going to say clicked. So that is the simplest event of how to have an event executed using an HTML attribute. Now the second type is using a DOM property. Now we can assign a handler using a DOM property that is going to be the same as on event. So what you are going to do for that is that we are going to just remove this and we are going to have an input here. The type is going to be button. We are going to assign an ID to it that is going to be element. And right here, we are going to specify a value to this as well that is going to say click me. Now, right down here, we are going to have our script tags, and inside that, we are going to have element dot, and it is going to be on a click. It is going to actually call upon a function, and inside that function, we are going to have a simple alert statement that is going to say clicked. So if you refresh your browser now, you can see that you have got the button, click it, and it is going to say clicked. So that's how basically you can access a DOM property as well. So as there is only one on-click property here, as you can see, we can actually not assign more than one event handler. For example, you can see that with this input type, we have this script tag attached here. So right in here, if you try to assign one more event, like on click here again and want to have alert the inside event. So you can see that you have the way where you have coded that before, where you have the event inside this input tag, but you can also see that you have also got this event. So let's just see that which one works actually. So if you refresh this, click on this button, you can see that it says clicked, which means that JavaScript actually overwritten the existing handler. Now there is also a way to actually remove a handler, and that is using assign element dot on click, and you can make it equal to null, and that is going to actually do your job. So moving ahead, now we can also access the element using this keyword. Now the value of this inside a handler is actually the element, the one which has the handler on it. So right here, what if you have a button? So we will just remove this from here. We will just scroll down towards the left a bit. And right here, we are going to have a button. And the button inside that is going to say click me. So right inside here, we are going to have the on click, and we are going to simply write in alert. And inside that, we are going to write in this dot, and we don't need but the quotes actually. So we are going to have only this dot inner HTML. So let's just see what happens, but we will just remove this code from here. We don't need that. So we will refresh this, click this, and you can see that it is going to show you click me, which are actually the contents of this button. So the contents include click me here. That exactly what this dot inner HTML is going to get us. So now the next thing we are going to talk about is how to actually use the add event listener. Now the fundamental problem of the forementioned ways to assign a handler is that we cannot assign multiple handlers to one event. So let's say one part of our code wants to highlight a button on click and another one wants to show a message on the same click. So what we would like to do is that we would like to assign two event handlers for that, but a new DOM property will actually override the existing one which you have seen as well. So developers of web standard understood that long ago and suggested an alternate way of managing handlers using the special method that are known as the add event listener and the remove event listener, which are not bound by such constraint. Now the syntax to add a event listener is something like this, where we have element dot, and then we have the add event listener. And inside that, we have three parameters. The first one is the event, the second one is the handler, and then we have some options which are actually an optional parameter as well. Now, event is actually the event name that can be click or anything else. Then we have the handler function and additional options that can be of three types. The first one is once, that is if true, then the listener is automatically removed after it triggered. Then we have the capture one, that is the phase where to handle the events. Then finally we have passive, that is if true, then the handler will not call the prevent default. We will explain that later. So to remove the handler, we are going to use the remove event listener, which has almost the same pattern. We have the three parameters, event handler and options. But what you have to do is that just in place of this remove add, you have to add remove right over here. And that is actually going to do your job. So let's just see how it works with the help of a very simple example. We will just save this, and right inside here, what we are going to do is that we are going to have a very simple input tag. The type is going to be button. Then we are going to assign an ID to it, that is going to be element, and we are going to assign it with a value that is going to say click me. Now inside the script tags, what we are going to do is that we are going to assign our handler, and this time we are going to have two handlers. The first one is going to be handler number one, and inside the handler number one, we are going to simply alert, not alerts, it is going to be alert, and we are going to just say that handler handler number one called. And after that, we are going to have another handler that is going to be handler number two. And inside that, what we are going to do is that we are going to alert, and we are going to alert that handler dash two called. Now what we are going to do is that right here, what we are going to have is inside the script tag is element, which has basically the ID which we want. So we are going to have element dot on click equal to alert click. And after that, we are going to have element dot add event listener. And inside the event listener, we are going to have parameters. The first one is going to be the thing which you want, that is going to be the event, that is going to be a click event. And after that, we are going to have handler number one here. And then we can have element dot handler number two, not like that, but we are going to have the add event listener, and inside that we are going to have click event, and this time we are going to have handler number two. Now when this statement executes, what that is going to do is that it is going to actually give us this output, whereas when the handler number two execute, it is going to give us this output. So if you save this page, and let's just see what happens when you refresh the browser, you can see when you click, it is going to say first clicked, then it is going to call upon handler number one, and then it is going to call upon handler number two, which is exactly opposite of what we were doing before. In before, when we actually add attached two events to a single tag in here, you notice that it actually overwritten the previous one and it called upon only the last one. So in here, you can see that it not only called this, which is the direct event assigning using the normal onClick, and right here we assigned multiples to the add event listener. So you can see that three events are actually attached to a single click on this single button right here. The first one is the simple event, That is the on click which you have which you have discussed before, and the second one and the third one are using the add event listener. So as you have seen here that we can set handler both using a DOM property and using the add event listener, but generally we use only one of these ways. It was just to show you that how you can actually have both of these together as well. So that is it with this tutorial. You have learned a lot about the browser events. In the next tutorial, we are going to talk more about that. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course where we are talking about events. And in this tutorial, we are again going to talk about introduction to browser events. And in here, we are going to start on with event object. Now, to properly handle an event, we would want to know more about what's happened, not just a click or a key down, but what were the pointer coordinates actually, which key was pressed, and so on. Now, what when an event happens, the browser creates actually an event object that is going to have the details into it, and it is going to pass it as an argument to the handler. So let's just say that you have this input type button id element, and in here we have value as click me. Now inside the script tag you are going to have element dot on click is going to call upon a function. And now inside that function, what we are going to do is that we are going to show the event type, we are going to show the element, and we are going to show the coordinates of the click. Now to do that, we are going to have an alert statement where we are going to have event dot type. We are going to concat this with at, concat it further with the event dot current target. So after that, what we are going to do is that we are going to alert the coordinates. We are going to see the coordinates where the click happened. So we are going to concat this with the event dot client x, and we are going to further concat this with a colon and concat this with event dot client y. So what that is going to do is that it is going to give us the type of the event, the current target, the client X event, and the Y coordinates where the event actually occurred. So now the event object has these properties. You can see that we have the event type. That is the event type. Here it is going to be click. And the second one we actually wanted was the event dot current target, as you have seen. Now, element that it is basically element that handled the event. Now, that's exactly the same as the this keyword, unless the handler is an arrow function or it's the this keyword is bound to something else. Then we can get the element from event dot current target. And finally, we have event dot client x and event dot client y that are the window relative coordinates of the cursor for pointer events. Now there are more properties as well. Many of them depends on the event type. Like keyboard events have one set of properties, pointer events have another one. We are going to study them later in details. So the next thing we are going to talk about in this tutorial is the handle event function. Now we can assign not just a function but an object as an event handler using the add event listener. When an event occur, its handle event method is going to get called. So right in here, before we go on with the handle event, let me just show you the output to this as well. So let me just refresh this, click on this button, and you can see that it says click, that is the event dot type. Then add the object HTML input element, which is the event dot target. Then click OK, and it is going to give you the X coordinate that is 36 and the Y coordinate that is 18 in this case. So let's just get on to the object handler, that is the handle event. So in here, what we are going to do is that we are, instead of the input tag, we are going to have a button, the ID for which is going to be element, and this button is going to say click me. Now right inside here, what we are going to do is that we are going to have something like this, where we are going to have let object is going to equal to the handle event function that is going to receive an event. And inside that, what we are going to do is that we are going to get the type. So we will just copy this from here, and right here we are going to actually paste it. That is going to get us the event type at the event.current target. Now what we are going to do after that is that right here we will just remove this from here, and in here we are going to have element dot, and we are going to have the add event listener. We are going to have the event as the click event, and we are going to call upon the object that is going to be the handler in this case. So as you can see that when the add event listener receive an the object as the handler, it is going to call upon the object dot handle event in case of an event. So if you run this code, refresh this, click on this, and you can see that it is going to give you the output as click at HTML button element. So in here, basically, since the handler is the object, so it is going to call upon object dot handle event and actually execute this code for you. Now we could also use objects of a custom class as well, where right here what you can do is that in here, in place of the object, what you can do is that you can have a custom class that is going to be, let's just say, named as menu. And in this class we are going to have our handle event that is going to receive this event, and inside that we are going to have a switch statement that is going to receive the input dot type, and it is going to check for the input dot type, and in the we are going to add the cases as event types, which can be either, let's just say, mouse down, and in the mouse down we are going to simply have that element dot inner html is going to equal to mouse button pressed. And what you can do is simply that you can just copy this case from here, and what you can do is that you can just go back here, paste this, but we have to actually move it back. So the next event can be, let's just say, the mouse up. So we will just remove this from here, move up, and right here we are also going to add the break statement. And in the mouse up we are going to just write in mouse button released. All right, so we can add a break statement here as well. And now right down here, what you can have is that you can actually create an instance of the menu using the new keyword and write in the name of the class here. That is going to be named as menu. And right after that, what you can do is that you can have element dot add event listener, and the listener which you're going to attach is going to be the mouse down on the menu object. Now as soon as it gets the object, so it is going to call upon object.handle event, which is going to be this function in that case, and it is going to enter the switch statement. So what we can do is that we can just copy this from here, and we can have the other event that is the mouse up event here as well. So let's just run this code and see what's the output here. So refresh this, click on it. You can see that it is going to say mouse button released. So let's just refresh it again, and I will just keep on clicking. You can see that it says mouse button pressed, and at this time I am actually holding the mouse button. So if I release it, you can see that now it is going to say mouse button released. So here the same object actually handle both events. Please note that we need to explicitly set up the events to listen using the add event listener. The menu object only gets the mouse down and mouse up here, not any other type of events. So now event handlers are clearly separated. That may be easier to support as well. So I hope that you have understood what we have covered in this tutorial and the previous one. That was all the introduction to browser events. So that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course where we are talking about events. And in this tutorial, we are going to study a very important topic, that is bubbling and capturing. So let's just start with an example. So let's just see that inside here you have actually a div element, and the div element on click is basically going to alert the handler. So what we are going to do is that inside this div, what I'm going to do is that I am going to have an em tag. Now inside that em tag, I'm going to write in if you click on, and after that I'm going to have the code tag, and inside the code tag I'm going to write in em. Then what I'm going to do is that I'm going to write in the handler on, and I'm going to use the code tag again on the div runs. So then we are going to close that. So now if you refresh this, you're going to see that it says if you click on, you can see that you have got this em. You can see that when you click on it, it is going to run the handler for you. And after that, it has also got this on div. Now, isn't it a bit strange? Now, why does the handler on the div run if the actual click was on the em? Now that's where the concept of bubbling comes up. Now the bubbling principle is simple. When an event happens on an element, it first run the handler on it, then on its parents, and then all the way up on other ancestors. So for example, if you have, let's just say, something like you have in here, you have three elements, and we will just see the hierarchy now. So let's just say that you have a form. We don't need any action on it, but what we need to do is that we need to have an on click event on the form that is going to alert. It is going to simply alert form. Now inside the form, what we are going to do is that we are going to add a div. Now we are going to also have the on click event here, so we will just copy this from here. We are going to paste it, and this time it is going to say div. And right inside the div, what we are going to do is that we are going to have a paragraph element. And the paragraph element also is going to have a on click, and this time it is going to call a p. So that is going to be it. Right here, we are going to just add the, so it is going to be form. Then this one is going to be div, and then this one finally is going to be p. So not here, but it is going to be inside this. So you can see that we have got a form. Inside that form, we have got a div, and then inside that div, we have actually got a p event. So we have got actually three nested elements where form is greater than div, which is greater than p, with a handler on each of them. So let me just run this and let's just see what happens. So if you refresh this, you can see that you are going to have a form, you are going to have a div, and you are going to have a p. Now a click on the inner paragraph first runs on the on click, then on that paragraph, then on the outer div, and then on the outer form, and so on upwards till the document object. So if you click on the paragraph, you can see that first it is going to run the child, then the parent of that is div, and then the uppermost parent, that is the form, and it is going to, so as you can see that the hierarchy goes from the child, that is the most deeply nested element, and then up to the top. So if you click on P, so you can see that it just displayed P, then div, then form. Now this process is called bubbling because events bubble from the inner element up through the parent like a bubble in the water. Now, all events actually bubble almost. Now, the key word in this phrase is almost. For instance, a focus event does not bubble. There are other examples too, we are going to see them, but still it is an exception rather than a rule. Most events do bubble. Then the second part of this tutorial is capturing. Now there is another phase of event processing that is known as capturing. It is rarely used in real code, but sometimes it can be useful. Now the standard DOM events describe three phases of event propagation. The first one is the capturing phase, the second one is the target phase, and the third one is the bubbling phase. Now in the capturing phase, the event goes down to the element. In the target phase, the event reached the target element, and in the bubbling phase, the event bubble up from the element. So, so here is the pictorial representation of that taken from the specification of the capturing one, target two, and bubbling three phrases for a click event on a TD inside a table. So as you can see here at the left side, we have the capturing where it moves from window towards the document. You can see the red line, then HTML, then body, then table, and then the T body. And after that, it moves to TR and then towards the target phase. That is actually the target. Now in the bubbling phase, you can see that it happens in the opposite way. It starts on down the river. It is going to move from TD to the TR, then towards the T body, then the table body, HTML document, and finally towards the window. Now that is for a click on TD, the event first goes through the ancestor chain down to the element that is known as the capturing phase. Then it reaches the target and triggers there, that is the target phase. And then it goes up, that is the bubbling phase, calling the handler on its way. So until now, we only talked about bubbling because the capturing phase is actually rarely used. In fact, the capturing phase was invisible for us because handler added using the onEvent property or using HTML attribute or using two arguments using the add event listener that were the event and handler don't know anything about capturing. They only run on the second and the third phase. Now to catch an event on the capturing phase, we need to set the handler capture option to true. Now there are two possible values of the capture option. If it is false, that is default, then the handler is set on the bubbling phase. And if it is true, then the handler is set on the capturing phase. Note that while formally there are three phases, the second phase, the target phase, is that the event reached the element is not handled separately. Handlers on both capturing and bubbling phase actually trigger at that phase. So I hope that you have understood this image and understood the difference between capturing and bubbling. So let's just see capturing and bubbling both in action. So you can see that you have got this ancestor chain where you have form as the parent, then you have div as its child, and then the div also has a child that is the most nested element, that is the paragraph in this case. So what we are going to do now is that inside the script tags, we are going to have for, and we are going to write in for let element of document dot query select all. What we are going to do is that we are going to specify static here, which means that it is going to select everything for us. And right inside that, we are going to have two event listeners. In the first event listener, that is going to be of the click event, we are going to assign an event. And using that event, we are going to alert that capturing is in effect, where we are going to write in capturing with a P after this A. So right here, we are going to write in $, and we are going to write in the tags. And inside that, we are going to write an element dot, and we are going to write in the tag name. So we are going to make it true. And after that, what we are going to do is that right here, we are going to have element dot add event listener, and the event listener is again going to be click, and we are going to have an event that is going to alert, and right here we are going to write in bubbling colon, we are going to have our dollar sign, the tags here, and inside that we are going to write in element dot tag name. So that is going to be it. So just save this page and refresh your browser here. You can see that if you click anywhere, it is going to say first P, then you can see that it says capturing, where P is true, then bubbling P, then the div, then the capturing div true, then the bubbling div, then the form, then the capturing form true, and finally the bubbling form. So the code actually sets the click handler on every element in the document to see which ones are working. So if you click on P, you can see that for the capturing phase, that is the first layer's listener, the output looks something like HTML, then the body, then the form, then the div, and then the paragraph. And for the bubbling phase, that is the second listener, the output goes from paragraph to div, then to form, then to body, and then to HTML. Now, please note the P shows up twice because we have set two listeners, the capturing and the bubbling. The target triggers at the end of the first and at the beginning of the second phase. Now, there is a property that is known as the event.event phase that tells us the number of the phases on which the event was caught. But it is rarely used because we usually know it in the handler. Now to remove the handler, remove event listener needs the same phase. So if we have the add event listener, then we should mention the same phase in the remove event listener to correctly remove the handler. Now we have the event.stop propagation during the capturing that also prevents the bubbling. Now the event.stop propagation method and its sibling that is known as event.stop immediate propagation can also be called on the capturing phase. Then not only the further capturing is going to get stopped, but the bubbling as well is going to get stopped. In other words, normally the event goes first down, that is capturing, and then up, which is bubbling. But if event.stop propagation is called during the capturing phase, then the event traveling is going to stop and no bubbling will occur. So I hope that you have understood these two very important concepts that are bubbling and capturing. Bubbling is more important because capturing is something that is rarely used nowadays. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk about event delegation. Now in the previous tutorial we talked about capturing and bubbling, and we know that it allows us to implement one of the most powerful event handling patterns that is known as event delegation. Now the idea is that we have a lot of element handled in a similar way, then instead of assigning a handler to each of them, that is, we put a single handler on their common ancestor. So in the handler, we get event.target to see where the event actually happened and handle it. So you can see right here that we have this code where we have the Bagua diagram reflecting the ancient Chinese philosophy. Now the HTML is right in front of you. You can see that we have table that has actually 9 cells, but there could be 99 or there could be 9,999, doesn't matter. What our task here is to highlight a cell TD on click. Now instead of assign an on click handler to each TD, which can be many, we will set up the catch all handler on the table event. What it is going to do is that it will use the event.target to get the clicked element and highlight it. So if you see the code down here for that, you can see that you have let target equal to event dot target. That is where was the click. Then in here you are going to write in if target dot tag name is not equal to td, that is not on td, then we are not interested actually. And if it was, then we are going to simply highlight the target. Now inside the function highlight, what we are going to do is that if selected td, we are going to remove the existing highlight if any and write down here select the td.classlist.add is going to highlight the new td. Now, such a code does not care how many cells there are in the table. We can add or remove a td dynamically at any time, and the highlighting will actually still work. Still, there is a drawback. The click may occur not on the td but inside it. In our case, if we take a look at the html here, then we can see that we have nested tags inside td as well. Like you can see that this one we have inside the td, we have a nested tag that is known as strong northwest. Now naturally, if a click happens on that strong, then it becomes the value of event.target, and it is going to move from event.target, which is strong, towards the td, and then towards the tr, and then towards the table, like the capturing concept. Now in the handler, the table.onClick, we should take such event.target and find out whether the click was inside the TD or not. Now to do that, what we can do is that we can actually modify the table on the onClick code, which can be actually replaced by this code. So in here, you can see that you have the improved code where you have the event.target.closes is td, which is one change, and then we have this where we are going to have the return statement, then table.contains td, return 3. So if you have an explanation here, then in here what's going on is that the method element.closes selector returns the nearest ancestor that matches the selector. In our case, we are going to look for td on the way up from the source element. Then in here we are actually going to have a return statement. So if event.target is not visible inside any td, then the call returns immediately as there is nothing to do. And then in here, what that is going to do is that in case of nested tables, event.target may be a td but lying outside of the current table. So we check if that is actually our table or not. And then finally, what we are going to do is that if it is so, then we are going to highlight it. As a result, we have a fast, efficient highlighting code that does not care about the total number of TD in the table. So that's what delegation, event delegation in JavaScript is. That is really cool. It's one of the most helpful patterns for a DOM event. It's often used to add the same handling for many similar events, but not only for that. The algorithm is to put a single handler on the container. In the handler, check the source element that is going to be event.target, and if the event happened inside an element that interests us, then we are going to handle the event. Now, there are some pros and cons to it as well. So, if you talk about the benefits of event delegation, then the first benefit is that it simplifies initializations and saves memory. No need to add many handlers. The second advantage is that it has less code. When adding or removing elements, there is no need to add or remove handlers. And finally, the third benefit is the DOM modifications. We can actually add or remove elements with inner HTML and the like. Now, the delegation has its limitations, of course. The first is that the event must be bubbling. Some events do not bubble. Also, low-level handlers should not use the event.stop propagation. Second limitation is that the delegation may add CPU load because the container level handler reacts on events in any place of the container, no matter whether they interest us or not. But usually the load is negligible, so we don't take that into account. So this is all we have to talk about event delegation in JavaScript and how it is actually related to what we have covered in the previous tutorials as well. So I hope that you have understood what event delegation is. So that's it. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and from this tutorial on we are going to be talking about binary data and files. So for the first part, we are going to talk about array buffer and binary arrays. Now, in web development, we meet binary data mostly while dealing with files that are to create a file, to upload a file, or to download a file. Now, another typical use case is the image processing. Now, that's all possible in JavaScript, and binary operations are high performant. Although there is a bit confusion because there are many classes. Now, to name a few, we have the array buffer, then we have the uint8 array, we have the data view, we have the blob, and we have the file. We have others as well. Now, binary data in JavaScript is implemented in a non-standard way compared to other languages. But when we sort things out, everything becomes fairly simple. Now, the basic binary object is basically known as the array buffer. That is a reference to a fixed length contiguous memory area. So to create a array buffer, what you have to do is that you have to create an object, let buffer, and you have to make it equal to new, and right here you have to write an array, and there it is, array buffer. And right here you have to specify the length actually. So what this line here is going to do is that it is going to create a buffer that has length 16. So right here, if you want to confirm that, you can just write in buffer dot, and you can write in byte length. So if you save this and right here refresh your browser, you can see that it says 16, which means that you have actually created a array buffer, the byte length of which is actually 16. So this 16 actually represents the bytes, not the bits. So this here is the byte length, not the bit length. That is something that is very important for you to understand. So basically what this is going to do is that it is going to allocate a contiguous memory area of 16 bytes, and it is going to pre-fill it with zeros. Now, as you can see here that right at this moment, we have not specified any data inside this array buffer right here. So what the JavaScript is going to do is that it is going to actually have, for example, this is, let's just say, the array buffer, which is stored in buffer. So this buffer at this instance is going to be a set of zeros. So right here, it is going to be pre-filled with zeros. The entire 16 byte area is going to be filled with zeros. Now, you need to understand one thing, that array buffer is not an array of something. So let's eliminate this possible source of confusion. Now, array buffer has nothing in common with the array. It has a fixed length, we cannot increase or decrease it. It takes exactly that much space in the memory, and to access individual bytes, another view object is needed that is not the buffer. So array buffer is a memory area. Now the question is that what is actually stored in it? It has no clue, just a few raw sequences of bytes. Now to manipulate an array buffer, we need to use a view object. Now what is a view object? A view object is something that does not store anything on its own. It is actually the eyeglasses that give an interpretation of the bytes that are stored in the array buffer. For instance, we have, let's just say, a uint8 array. Now it actually looks something like this. It is uint, and you can see here that you have the uint16 array, you have the uint32 array, you have the uint8 array. So for this uint8 array, it treats each byte in array buffer as a separate number with possible values from 0 to 255. So if you have this here, then this over here actually stores the value from 0 to 255. That is actually a byte, which is actually 8 bits. So it can hold only that much. Such value is called a 8-bit unsigned integer. Now for the second one, we have the uint 16 array. Now the uint 16 array actually treats every 4 bytes as an integer with possible values from 0 to 65535. That's called a 16-bit unsigned integer. So it stores value from 0 to 65535. Then we have the uint32 array. So uint32 array, it is here, right? So this actually stores, and this also treats every byte, every 4 bytes as an integer. Now you can see that the difference, the first one over here, that is the uint8 array, it treats each byte in the array buffer. Whereas for the second one, the uint16 array, it actually treats every 2 bytes as an integer. And for the uint32 array, it actually treats every 4 bytes as an integer. Now, this actually has the possible values from 0 to a very big number, that is 42949672, and I guess it was 95 at the end. So this is the values that it store, and it is actually called a 32-bit unsigned integer. And then we also have the float 64 array. Now, the float 64 array actually treats every 8 bytes as a floating point number with possible values from 5.0 into 10 power minus 3 to 4, that are negative values, and it goes up till 1.8 into 10 to the power of 308. So you can see that it is something that is very massive. It stores a lot of numbers. So actually the binary data is an array buffer of 16 bytes and can be interpreted as 16 tiny numbers or 8 bigger numbers, 2 bytes each, or even 4 bigger with 4 bytes each, or 2 floating point values with high precision, which means 8 bytes each. So if you have a look at this image, you can see that you have this new array buffer 16 where uint 8 array are values from 0 till 15, which means that every byte has been stored as a single byte. You can see that every one has only one space, 0, 1, 2, 3, and until 15. Whereas the uint 16 array, as I told you, that it treats every 2 bytes as an integer, so you can clearly see that we have got only 8 spaces, which mean 8 into 2, which makes it equal to 16, which means that every byte every it has treated every 2 bytes as an integer, whereas for uint32 array, as I told you, that it treats every 4 bytes as an integer, so that's why it has only 4 locations, which makes it equal to 4 into 4 16. And finally, for the last one, it treats every 8 bytes, so that's why we have got only 2, which makes 2 into 8 16. So I hope that you have understood how they actually store bytes in their locations. So as you can see, that array buffer is actually the core object, that is the root of everything, that is the raw binary data. But if we are going to write into it or iterate over it, basically for almost any operation, we must use a view. Now I have told you what a view is, so let's just create it right over here. So what we are going to do is that we will just remove this stuff from here, and we will have this buffer, new array buffer equal to 16. And right here, what we are going to do is that we are going to now create a view. So a view is actually created using either of the uint patterns, which we just studied. So we will just stick on with uint32, and right inside the parenthesis of uint32 array, you have to specify the buffer. Now what that is going to do is that it is going to treat buffer as a sequence of 32-bit integers. So right here, if you try to alert the view dot length, then actually it is going to give you 4, that is something that stores that many integers. So this means that it actually stores 4 integers, whereas right here, if you want to alert the view dot byte length, then actually it is going to give you 16, that is the size in bytes. So I hope that you have understood how these works. So let's just remove this from here. So after creating the view, what we are going to do is that we are going to have, for the view 0, we are going to store an integer in that is going to be, let's just say, 1 2 3 4 5 6. So right now, if you want to have the uint32 array dot bytes per element, then it is going to give you 4 bytes per integer. So right here, we are going to simply have a for loop where we are going to write in let number of view. So we are having a for of loop in which we are going to actually print out your array. So it is not going to be new, but it is going to be num. So now if you run this code, you're going to see a very interesting thing. So let's just refresh that. And as you can see that it says 1, 2, 3, 4, 5, 6. And after that, it says 0, 0, and 0. So what that mean actually is that the output which was generated was something like this. At the first place, it had the 1, 2, 3, 4, 5, 6. And after that, it has a 0, then a 0, and then a 0. So basically, it was able to store 4 integers, and you have already seen that when you tried to alert the view dot length. So you remember that it would generate you 4 as the answer, which is the number of integers it could store. And right here, you can see that at the 0th location, you have actually stored a number that is 1, 2, 3, 4, 5, 6. Now, as I told you in the very beginning, that as soon as this buffer gets created, it is going to get pre-filled with zeros. And as soon as you overwrite the value when you want to store something now, it is going to get stored at that particular location which you have specified using the view here. So 1, 2, 3, 4, 5, 6 is going to get stored here, and the remaining one are going to be the zeros that got pre-filled when this array buffer was created. So I hope that you have understood what we have covered so far. In the next tutorial, we are going to talk more about array buffers. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to continue on with array buffer and binary arrays. And in this tutorial basically we are going to talk about the typed array. Now, the common term for all the views that are the uint8 array, uint32 array, and else, which we have talked about, are known as the typed array. Now, they share the same set of methods and properties, so please note that there is no constructor that is known as typed array. It's just a common umbrella term to represent one of the views over the array buffer that can be int8 array, uint8 array, and so on. The full list is going to soon follow. So when you see something like new typed array, it means any of the new int8 array, new uint8 array, or something like that. Now, typed arrays actually behave like regular arrays. They have indexes and they are actually iterable. Now, a typed array constructor, be it be the int array or the float64 array, doesn't matter. It behaves differently depending on the argument type. Now, there are actually 5 variants of arguments using which you can use the new typed array, which are listed right in front of you. Now, in the first one, which you can see in front of you, that if a array buffer argument is supplied, then the view is created over it. We used that syntax already. Optionally, we can provide the byte offset to start from, that is 0 by default, and the length that is till the end of the buffer by default. Then the view will cover only a part of the buffer. So this is the one which we have actually covered as well, where we supplied the buffer in the previous tutorial. So as I told you that these are the two optional parameters since they are in the square brackets, so that indicates that they are actually optional. So if you don't specify them, then the byte offset is going to be 0 by default, and the length, if you don't specify it, it is going to be from 0 till the very end. Now, in the second one, you have specified the object. Now, if in an array or any array like object is given, it creates a typed array of the same length and copies the content. Now, we can use it to pre-fill the array with the data. So, for example, let's just say right down here, we have an array that is equal to new, and you have the uint 8 array, and inside that you have, let's just say, 0, 1, 2, 3. So these are, let's just say, the 4 elements you have inside that. So after that, if you write in here alert, and you write in array dot length, not the last index of, but the length, then it is actually going to give you 4 as an output, which means that the created binary array is of the same length which we have specified right here. Then right here, if you want to have alert the array and you want to access the first element, so it is going to be actually filled with 4 bytes, that is unsigned 8-bit integers with given values. So let's just see the output for these two. So refresh that, and 4 is going to be your first output and 1 is going to be your second output, which is actually this, that is the array 1th element, which means that it is actually something that was filled with 4 bytes. Now, another typed array is supplied, which actually does the same. It creates a typed array of the same length, and copied values. Values are converted to the new type in the process if they are needed to. So for this one, let's just say that we have an array that is equal to a new array that is a uint, and let's just say a 16 array where we specified 4, which means that it is going to create typed array for 4 integers. So we will just remove this code from here because it is actually a duplication error. So we are talking about the third pattern. Now right here, if you just write an alert and you want to have, not alert, but we will do the alert later. But for example, let's just say that you have an array 8 that is actually equal to the new uint 8 array, and right here you actually write in the first array that you specified using the uint 16 array. Well, let's just name it to 16 so that it looks much like what it is doing. And right here you can specify this to be array 16. So right here, if you now write in alert array 8 and you want to access the 0th element, and right here you, not let, but it is going to be alert, and this one is going to be alert as well, that is going to have alert array 8, and you want to access the first location. Now this one over here is going to actually give you 1, whereas this one is going to give you 232 if in the parameters for this uint 16 array, instead of this you have to specify 1 and 1000. So let's just run this code and see the output, and then I'm going to show you what's going on. So you can see that it says 1 and it says 232. So basically it tried to copy 1000 but can't fit into the 8 bits. We are going to follow the explanation for this later. So just you need to understand the pattern for how this one works actually. So let's just remove this for now as well. And let's just move on to the next one, that is the new typed array length. Now for a numeric argument length, it is going to create the typed array to contain that many elements. And now its byte length will be the length multiplied by the number of bytes in a single item. That is going to be accessed using the typed array dot bytes per element. So let's just say that you have an array that is equal to the new uint 16 array with 4 in its parameter, that is actually the length. So it is going to create the typed array for 4 integers. And now if you want to have the uint 16 array dot bytes per element, then actually it is going to give you 2 bytes per integer. And right here you can have alert array dot byte length, which is going to give you 8, that is the size in bytes. So let's just see the output for these two. The first one, as I told you, is going to give you 2, that is 2 bytes per integers. And after that you are going to get 8, that is actually the size in byte, which is obtained using the byte length. So this was the fourth way in which the arguments can be manipulated of the typed array. And in the final one, where we have no argument, it is going to create a zero length typed array. So we can create a typed array directly without mentioning the array buffer, but a view cannot exist without an underlying array buffer. So gets created automatically in all the cases except the first one when provided. So to access the underlying array buffer, there are certain properties in the typed array. The first one is the buffer that references the array buffer, and the second one is the byte length, that is the length of the array buffer. So we can always move from one view to another view. So right here, let's just say that you have an array 8 where you have new uint 8 array where you have actually data that says 0, 1, 2, 3, and right here it is not uint 9, but it is uint 8. And right here, let's just say that you have array 16 that is equal to new uint 16 array. And right here, you want to have array 8 dot buffer. So that is actually another view on the same data. So the list of type arrays are the uint 8 array, uint 16 array, and the uint 32 array for integer numbers of 8, 16, and 32 bytes respectively. We have the uint8 clamped array that is for 8 integers and that clamps them on assignment, which we are going to see. Then we have the int8 array, int16 array, and int32 array for signed integer numbers, which can be negative as well. And we have the float32 array, and we have the float62 array for signed floating point numbers of 32 and 64 bits. Now, no int8 or similar single value types, so please note that despite of the names like int8 array, there is no single value type like int or int8 in JavaScript. Now that's logical, as the int8 array is not an array of these individual values, but rather a view that is supplied on the array buffer. So I hope that you have understood what is a typed array, and that is going to be it for now. In the next tutorial, we are going to talk more about the array buffers and binary data. So thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are again going to be talking about the array buffer and binary arrays. In this tutorial specifically, we are going to talk about the out of bound behavior. Now, the question is that what if we attempt to write an out of point value into a typed array? Now, that is going to be no error, but the extra bits are going to be cut off. Now, for instance, if you try to put a 256 into a uint8 array, so in binary form, 256 is actually 1 and followed by 80, which makes it 9 bits. But uint8 array only provide 8 bits per value, which actually makes the available range from 0 to 255, which we have talked about in the previous tutorials. Now, for bigger numbers, only the rightmost, that are the less significant 8 bits, are going to be stored and the rest are going to be cut off. So for the 8-bit integers, so let's just say that we have 8-bit integers, and let's just say that we are talking about 1, and after that we are going to have 1, 2, 3, 4, 5, 6, 7, 8 zeros. So this is actually the code which we have for 256. Now for a 8-bit integer, what that is going to do is that it is only going to keep these values. So what we are going to get is that we are going to get only zeros. Now for 257, what we have is that we have actually got a 1 here at the one end, and it is going to actually make it equal to 257. So that is again 9 bits. So the rightmost 8 bits are going to get stored, and we will have 1 in the array. So you can see that something very interesting over here is going on. We are trying to store 257, but since it is going to only take these 8 bits, which means that this is going to get discarded. So you can see that this is actually now the binary code for 1, which means that we are trying to store 257, but what it is going to store is actually 1, which is exactly what we don't want. So in other words, actually what it is going to save is the modulo, that is 2 power 8. So let's just see this with the help of an example. So we will just remove this from here, and let's just say that you have a uint 8 array object, which is actually equal to a new uint 8 array, and we are going to have 16 inside that. So right here we are going to have the number as 256. So as I told you in the beginning, that what it is going to store is actually the rightmost 8 bits, which is actually the binary code for 0. So right here, if you have alert the number dot to string and you want to get the binary code for that, so let's just save it and see the binary code here. So you can see that it is actually 1, and after that it is followed by 8 zeros. So just remove this, we don't need it anymore. It was just to show you the binary representation of 256. So right here, if you write in uint 8 array and write in the 0th location and make it equal to 256, whereas for the second one you write in at the first location you want to actually store in 257. So right here, if you now alert the uint8 array and you want to print out the 0th location, so this is actually going to give you 0, whereas if you write in alert and uint8 array and you want to check for the first location, actually it is going to give you 1, which is actually exactly what I told you, that this actually has the code 10000 8 zeros, which means that it is only going to have these one. So what that is going to imply is that it is only going to have 0000, which means 8 zeros, which is actually the binary code for 0. Whereas for this one, actually it is going to have 1 followed by 7 zeros and a 1, which makes it equal to, since it is going to only take the rightmost 8 bits, discard the 1 at the end, so it is going to be something like this, which is actually the binary code for 1. So this is exactly what's going on to happen here. So let me just show you the output for this. So refresh this, you can see that it gets 0, and after that it is going to print out 1. So I hope that you have understood that. Then we have the uint8 clamped array that is special in this effect as well. Its behavior is different. It actually saves 255 for any number that is greater than 255 and 0 for any negative number. Now that behavior is useful for image processing. So right here, if you don't have the uint8 array, and let's just say that you have the uint clamped array, so what it is going to have is that it is going to not have this output, but if you save this and refresh this, you're going to see that for the first one it is going to have 255, and for the second one it also is going to have 255, which is exactly what this uint8 clamped array does, that for any number that is greater than 255 for the uint8 format, it is going to actually print out 255, and for, since both of these are 255, so that's why it is going to have 255, and for negative values it is actually going to have 0 as the output. So let's just see this for the second output. This is 255 for the first one and 0 is for the second one. So after that we have the typed array methods. Now they have actually regular array methods with notable exceptions. So we can iterate, we can have the map method, the slice method, the find method, and the reduce method. There are a few things we can do though. We have got no splice, which means we cannot delete a value because typed arrays are views on a buffer. So these are fixed, contiguous areas of memory. All we can do is to assign a 0. And then we also have the no concat method. Now there are two additional methods. The first one is the array.set, which has two parameters. So let me just write you the syntax of those. The first one is the array.set. The first parameter is the from array, and the second parameter is the optional parameter, that is the offset. Now in this it actually copies all elements from the from array to the array, starting at the position offset, which if you don't specify it is going to be 0 by default. Now the second method is array dot subarray, and actually it has two parameters, that are the begin and the end. So what this function is going to do is that it is going to create a new view of the same type from begin to end, that is exclusive. Now it is actually similar to the slice method that is also supported, but what it's different about this is it does not copy anything, it just create a new view to operate on the given piece of data. So these method allow us to copy typed arrays, mix them, create new arrays from existing ones, and so on. So the last thing which we are going to study is the data view. Now data view is a special super flexible untyped view over the array buffer. It allows you to access the data on any offset in any format. Now, for typed arrays, the constructor dictates what the format is. The whole array is supposed to be uniform. The ith number is the array I. Now, with data view, we access the data with methods like dot get uint 8 or dot get uint 16. So we choose the format at method call time instead of the construction time. So if you talk about the syntax, then it looks something like this. It is going to be new data view, and inside the parameters, the first one is that you have to specify the buffer, and then you have two optional parameter which are the very same for the byte offset, and the second one is the byte length. So the first one as is the buffer, that is the underlying array buffer. Unlike typed array, data view does not create a buffer on its own. We have to have it already. So the second one is the byte offset, that is the starting byte position of the view. It is optional, default value is 0. And finally, we have the byte length of the view, and it is also optional. By default, it is going to be till the end of the buffer. So for instance, let's just see this with the help of an example, and let's just say that you have a buffer that is equal to a new uint8 array that has values 255, 255, 255, and 255 dot buffer. So as I told you that what it is going to have is that it does not create a buffer on its own. We need to have one ready. So after that, we are going to have let data view, and data view is going to equal to new data view, and inside that we are going to specify the buffer. After that, if you write in alert and you have data view dot the get method, which as I discussed you with, it is going to be get uint 16 not, but we are talking about get uint 8. And in the parameters, if you specify 0, then it is actually going to get you 255. So it is going to get you the 8-bit number at offset number 0, which is 255 in our case. Then if you want to now get the 16-bit number at the offset 0, now since it consists of 2 bytes together, it is going to be represented as 65535. That is the biggest 16-bit unsigned int. So right here, if you copy this and you just paste it again, and instead of uint 8, you just write in uint 16. So this over here is going to be a combination of two values now, which means 16. So it is going to give you 65535. That is the biggest number in the 16-bit unsigned int. And this one is going to give you the biggest number in the 8-bit, that is going to be 255. And after that, if you have in place of 8 you have 32, then it is going to get you the 32-bit number at offset number 0, which is the biggest 32-bit unsigned number. That is 4294967295. And after that, if you have data view dot set uint 32, and in the parameters you specify 0 by 0, that is actually the set method. So it is going to set 4 byte numbers to 0, thus it is going to set all bytes to 0. So if you run this code, you're going to see 255, then for the 16-bit greatest number, and then for the 32-bit greatest number. So a data view is great when we store mixed format data in the same buffer. For example, when we store a sequence of pair that can be 16-bit and 32-bit, 16-bit integers and 32-bit float values. So data view allows to access them easily. So that is all with the array buffer and the binary arrays. So I hope that you have understood what we have covered in the previous two and this tutorial. That was all about array buffers in JavaScript. So thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk about the text decoder and the text encoder. Now, the question is that what if the binary data is actually a string? So, for instance, we received a file with textual data. Now, the built-in text decoder object allows one to read the value into an actual JavaScript string given the buffer and the encoding. So, first, we need to actually create it. So, right in front of you in the very first line here, we have actually got the syntax for doing that. So it is going to be let decoder equal to new text decoder, and you have two parameters, label and options, both optional. So the first one, label, is the encoding that can be UTF-8 by default, but you can also have the big 5 U, the Windows 1251, and many others are also supported. Then the options is again the optional object that can be either fatal or it can be the ignore BOM. Now for the fatal boolean, if true, then throw an exception for invalid characters, otherwise replace them with the character /UFFFD. Then the ignore bomb is boolean. If true, then ignore the BOM, that is an optional byte order Unicode mark that is rarely needed. And then to decode things, you have to use this. Let str equal to decoder dot decode, and input and options. In the input you have to specify the buffer source which you want to decode, and in the options parameter you have to specify the stream that is true for decoding streams when decoder is called repeatedly with incoming chunks of data. In that case, a multi-byte character may occasionally split between chunks. This options actually tells the text decoder to memorize unfinished characters and decode them when the next chunk comes. So for instance, let's just say that you have a uint 8 array that is equal to new uint 8 array that actually stores some data. Let's just say 72, 101, 108, 108, and 111. So let's just say that this is the data. So we are going to write an alert new text decoder, and we are going to call in the decode ot it, and we are going to specify the uint8 array. So when you run this code, what that is going to do is that it is going to actually print hello, which is actually the codes here. So 72 is H, this 101 is E, 108 is L, 108 is again L, and then 111 is actually this O. So after that, if you have let uint8 array equal to new uint8 array, and this time let's just say that the sequence which you specify is 228 189 160 and 229 165 and 189. And this time if you write an alert new text decoder dot decode, and with this you specify the uint8 array, then it is going to be something else. So we can actually decode a part of the buffer by creating actually a subarray view for it. So you have to actually make it equal to 1 so that it is something different. 1 with this as well. So let me just first show you the output of this, and then we are going to move ahead. So it is going to say hello, and after that it is actually a Chinese representation of a word which is printed using this sequence which you have provided right over here. So as I told you, we can actually decode a part of the buffer by creating a subarray view for it. Now to do that, you have to actually create a uint8 array, and this time let's just add a 2 with it and have uint8 array. And this time, let's just say that the elements are 0, 72, 101, 108, 108, 111, and finally 0. So this is actually something that again is the hello. But what we have here is the string is actually in the middle this time. You can see that it is actually surrounded by zeros here. So we have actually to create a new view over it without copying anything. Now to do that, you have to write in let binary string is going to equal to the uint8 array2 dot subarray, and you have to pass in 1 and -1. So now if you want to have an alert statement where you have the new text decoder dot decode, and you want to decode the binary string, it is actually going to give you hello as the output. So let's just run this and see what happens. So we are going to refresh this. This hello is for the first, then the Chinese word. And after that, you are going to see that you are again going to get a hello. So for the last one, which we did here, we have actually decoded a part of the buffer by creating a subarray view of it. So I hope that you have understood that. So moving on to the next part of the tutorial, that is the text encoder. Now, what we have done in the text encoder is going to do the reverse thing. It is going to convert a string into bytes. Now the syntax is quite simple. It is let encoder equal to new text encoder. The only encoding it support is the UTF-8. Now it has two methods. The first one is the encode, and you have to specify a string in the parameters. That is going to return the uint8 array from a string. And the second function is the encode into, which has two parameters, the str and the destination. That is going to encode the string into the destination, that must be the uint8 array. So to see an example of this, let's just create a variable named as encoder equal to a new text encoder. And right here we can have let uint8 array. This time let's just make it equal to 3 here and write in encoder dot encode and just specify the strings inside here, and that is going to be it. Just alert it, and it is actually going to give you the output as the numbers which you specified here, that are 72, 101, 108, and 111. So as I told you, that this over here is actually converting this binary into a string, but this one here is going to convert this string actually into into actually bytes. So if you save this, and let me just comment this one out here so that the output for this doesn't generate. Just remove this, and now it has actually been commented out, so we will only get the output for this. So if you run this, it is going to say 72, 101, 108, 108, and 111, which is actually the encoding of the hello string. So I hope that you have understood what a text decoder and what a text encoder is and how they works actually. So that is it with this tutorial as well. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to be talking about blob. Now a blob object is simply a group of bytes that holds the data stored in a file. It may seem like that a blob is a reference to the actual file, but actually it is not. A blob has its size and the MIME just like that of a simple file. Now what is actually a MIME? Now a MIME is actually a multi-purpose internet mail extension protocol. Now, it is a standard that was proposed by the Bell Communications in 1991 in order to expand the limited capabilities of email. MIME is a kind of add on or a supplementary protocol that allows the non ASCII data to be sent through the SMTP. It allows the user to exchange different kind of data files on the internet. That can be audio files, video file, images, application programs as well. So you can go on and actually Google what a multi-purpose internet mail extension MIME is, and you are going to get a lot of stuff regarding that. So for now, you need to just stick on to Blob. So as I told you that a blob has its size and MIME just like that of a simple file. So the blob data is stored in the memory or the file system of a user depending upon the browser features and the size of the blob. Now, a simple blob can be used anywhere we wish, just like files. Now, the content of the blob can easily be read as the array buffer, which makes blob very convenient to store the binary data. So, if you talk about the syntax for how to create a blob, then it looks something like this. It is var abc equal to new blob, and inside that you have to specify the parameters, where the first one is going to be the blob content and the second one is going to be the type, and it is actually the blob property containing the MIME property. So apart from inserting data directly into a blob, we can also read data from blob using the file reader class. So let's just implement this syntax with the help of an example. And right here, let's just say that we have variable abc that is equal to a new blob. Now inside the parameters, what you have to do is that the first thing which you have to specify is going to be the blob content. So it can be anything. Let's just say we want to have tutorials on JavaScript. So this is going to be the blob content. And after that, what you have to do is that you have to specify the type here. So for this one, we have a very simple type that is actually a text that is plain. So we have plain text here as the second parameter, that is the blob property that contains the MIME property now. So after that, as I told you that apart from inserting data into a blob, we can also read data from this block using the file reader class. Now to access the file reader class, we have to actually create a variable, and we are going to make it equal to new file reader. So this is going to be it. After that, what we are going to do is that we are going to have def dot add event listener, and what we are going to have inside that is load end. So we are going to call upon a function that is going to receive an event that is going to be the load end event. And after this event has been performed, what we want simply is that we want to have document dot get element by ID, and we want to get a paragraph, and we want to change the inner HTML for that. That is going to equal to e dot src element dot result. So all we need now to do is that we need to have def dot read as text, and we have to specify the blob here. So all now you need to do is that in the HTML file, you have to just create a simple paragraph element, and you have to specify the ID for that paragraph to be this para. So right inside here, we are going to have paragraph, and we are going to specify an ID as para, and that is going to be it. So if you now run this code, you're going to see that it is going to say tutorials on JavaScript. So I hope that you have understood that. Now the second part is the blob URLs. Now just like we have the file URLs that refers to some real files in the local file system, we also have the blob URLs that refers to the blob. Now blob URLs are quite similar to any regular URLs and hence can be used almost anywhere that we can use the general URLs. Now a blob can be easily used as a URL for the A tag, for the image or other tags to display its content. Now, the blob URL pointing towards a blob can be obtained using the create object URL object. So let's just see this with the help of an example, that how we are going to have the blob URL and point it towards a blob that can be obtained using the create object URL object. So in the index.html, you can specify the title to be JavaScript blob. And what you are going to do inside the body is that you are going to have a tag. So we will just remove this from here and we are going to have an a tag. The href is going to be hashtag, and before that we are going to have download, and download is going to equal to actually an image. So right here what we are going to do is that if you go into the browser and see this, that we have this google.com. So if you right click it and write in save image as, you can see that you have got a specific name for it. So if you just copy this, and you can see that the type is the png image, so we will not just save it here. What we are going to do is that we will just go back here, and right here we are going to specify that, and we are going to specify the id as link. So we will just save this, and before that you have to add download here. Save this, and in the script.js what you have to do is that we will just remove this from here. We have our blob, that's this tutorials on JS, and right here we are going to write in link dot href, that is going to equal to url dot create object url of this blob. So if you save this page and refresh this, you are going to see that you have this download button. If you click on this download button, you can see that you have got this as text file. So if you open it, you can see that inside that you have got tutorial on JS, which is exactly what we have here in here. So basically you are going to get a downloaded you are going to have a downloaded dynamically generated blob here with tutorial on JS as its content. Now you can have the blob to array buffer as well. The blob constructor can be used to create blobs from anything, including any type of buffer source. Now for low level processing, we can use the lowest level array buffer from the blob using the file reader. So to do that, what you have to do is that you can have let def equal to new file reader, and after that you can have def dot read as array buffer, and you can specify the blob here as the parameter, and you're going to write in def dot onload equal to a function that is going to receive an event, that is the onload event. It is going to have let res equal to def dot result. So what that is going to help you with is that it is going to use the lowest level array buffer from the blob using the file reader. So I hope that you have understood what a blob is and what is the purpose of blob in JavaScript. So before we quit on, let's just discuss the pros and the cons of using blobs. So let's just first discuss about the pros of using blob. There are three. The first one is that blobs are a good option for adding large binary data files to a database and can be easily referenced. Second is that it is easy to set access rights using the rights management while using blob. And finally, the database backups of blob contains all the data. So these are the three pros for using blobs. Then there are some cons for using blobs as well. The first one is that not all databases permit the use of blobs. Secondly, blobs are inefficient due to the amount of disk space required and the access time. And finally, creating backups is highly time consuming due to the file size of blobs. So I hope that you have understood about blobs, what they are, and how they are used in JavaScript. So that is it with this tutorial as well. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are going to talk about file and file reader. So firstly, we will talk about file. Now, a file object inherits from blob and is extended with the file system related capabilities. Now, there are two ways to obtain it. First, there is a constructor that is similar to Bob. And in the first, you can see that you have got new file, then file parts, file name, and options are the parameters. In the file parts, it is actually an array of blob or buffer source or string values. The file name is actually the file name string, and in the options, you can have optional objects like last modified, that is this timestamp of last modification. Secondly, more often we get a file from input type equal to file or a drag and drop or other browser interfaces. In that case, the file gets this information from the operating system. Now, as the file inherits from the blob, file object have the same properties, plus it has two more that are the name, that is the file name, and then the last modified, that is the timestamp for last modification. So that's how basically we get a file object from input type equal to file. So let's just see how we are going to use the input one. So let's just say that in here in the body tags of HTML, you are going to have an input field. The type is going to be file, and we are going to have a on change event that is going to equal to show file this. So let's just move to the script.js, and in the script.js we are actually going to have that function that is named as show file. Input is going to be inside that. So inside this function we are going to have let file equal to input dot files, and we are actually referring to the zeroth file. So if you now write in alert and you have file name, and inside the brackets you have file dot name, then it is actually going to give you a file, for example my.png. And if you want to alert the last modified, then that is going to be something like this, where you will have file dot last modified. So it is going to give you a date that is going to tell you that when was the file last modified. So please note that the input may select multiple files. So input.files is an array like object with them. So here we have only one file. So we just take input.files 0. So if you want to run this code, you can refresh and it is going to ask you to choose a file. So if you click on choose file and click on that image which you just loaded in the previous tutorial, you can see that it is going to say file name Google logo color .txt. If you click on OK, it is going to give you the last modified, that is a number that actually is the last modified time. So you can see that right here you have also got the name of that file. So this is how file works here. So the next part of this tutorial is about the file reader, which you can see right down here. So we will just remove this from here for now and move down here. Now in the file reader, you can see that it is actually an object with the sole purpose of reading data from blob objects. Now it delivers the data using events, as reading from disk may take time. Now the constructor is right in front of you that says let reader equal to new file reader, no arguments here. Now there are certain methods which are associated with that. The first one, as you can see, is the read as array buffer that has the parameter as blob. Now it is going to read the data in the binary format from the array buffer. The second function is read as text, which has two parameters, the blob and the encoding. It is going to read the data as a text string with the given encoding, that is UTF-8 by default. The third function is read as data URL. which has the parameter as blob. It is going to be not UTL but URL. Now it is going to read the binary data and encode it as the base64 data URL. And finally, we have the abort that is going to cancel the operation. Now the choice of a read method depends on which format we actually prefer and how we are going to use the data. So the read as array buffer function for binary files is to do low level binary operation. For high level operation like slicing, file inherits from blobs, so we can call them directly without reading. And for the read as text for a text file, when we would like to get a string, and for the read as data URL is when we would like to use this data in the src for image or another tag. Now there is an alternative way to reading a file for that, as which we discussed in the previous tutorials using the url dot create object url. Now as the reading proceeds, we actually got some events as well, which you can see in front of you. The first one is the load start. That is when the loading start, when the progress, which occurs during reading, then load no errors, reading complete, abort for abort calls, and error when an error has occurred, and for the load end, which we also covered in the previous tutorial, that is when the reading finished with either success or failure. And for the result part, when the reading is finished, we can access the result as either reader.result if the result if successful, that, and in the reader.error, that is the error which if uh, reading was not successful and it failed. So the most widely used events are for sure the load and the error. So let's just see this with the help of an example for how to read a file. So right here, what we are going to do is that first we are going to have here, we have the input type equal to file. On change is going to be not show file, but it is going to be read a file. So just save this, go back to the script.js, and in the script.js, what we are going to do is that we are going to have a function that is going to be read file. It is going to take an input, and inside this function we are going to have file equal to input dot files number 0, which is going to be the file we select. Then we are going to have let reader equal to new file reader. After that, we are going to have reader dot read as text the file which we have selected, and we are going to have read file, not, we are going to have reader dot on load. It is going to call upon a function which is going to actually alert reader dot result. And for this is basically for the success, whereas for the error we are also going to have reader dot on error. It is going to call upon a function, and inside that function we are going to alert reader dot error. That is actually an event. So that is it. So let's just run this code and see if the reading was successful or not. So refresh and it is going to ask you to choose a file. So let's just say that this time we choose a file which has some text as well. So right here, we are going to choose this file, that is some JavaScript code. So if we open this, you can see that it is going to alert the it is going to actually read out the data and list it right in front of you, whatever this txt file contains. So this is what it contains, that is some JavaScript code, and you can see that you have got my js.txt here. So this is actually how you can actually read a file in JavaScript using the file reader. So I hope that you have understood what we have covered. We actually talked that file object inherits from blob. In addition to blob, methods and properties File object also have name and last modified properties plus the internal ability to read from file system. We usually get file object from user input like input tag or the drag and drop events, that is the on drag end. Then we talk that file reader objects can read from a file or a blob in three formats, that is the string, the array buffer, or the data URL, that is the base64 encoded. In many cases, though, we don't need to read the file content, just as we did with blobs. We can create a short URL with the url.createObject URL and assign it to a tag or the image tag. Now, this way, the file can be downloaded or shown up as an image as a part of canvas. And if we are going to send a file over a network, that is also easy. Network API like XML HTTP request or fetch natively accept file objects. So this was all we talked about file and file reader. So I hope that you have understood that. So that is it. Thank you so much guys for watching, and I will see you guys later. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorials we are going to start on with frames and windows. And the first thing we are going to cover is pop-ups and window methods. Now, a pop-up window is one of the very oldest method to show additional documents to user. Basically, what you have to do is that you have to run a very simple command that is known as window.open, and inside that you have to write in the name of the website. Let's just say google.com. So if you go here and you refresh this, you are going to see that it says the pop-up was blocked. But if you actually allow this pop-up and just write in done, refresh this, you can see that on a new page it is going to open that specific website, that is google.com. So as you have seen that it has opened a new window with the given URL which you have specified in the window.open parameters here. So most modern browsers are configured to open URL in new tabs instead of separate windows, which you have just witnessed as well. Now pop-ups exist from really ancient times. The initial idea was to show another content without closing the main window. As of now, there are other ways to do that as well. That includes that we can actually load content dynamically with the fetch function and show it in a dynamically generated div tag. So pop-ups is not something which we use every day. Also, pop-ups are tricky on mobile devices that don't show multiple windows simultaneously. Still, there are tasks where pop-ups are still used, for example, for the OAuth authorization. That includes the login with Google or Facebook or any other site, because a pop-up is a separate window which has its own independent JavaScript environment. So opening a pop-up from a third party, that is a non-trusted site, is actually safe. So it's very easy to open a pop-up, and a pop-up can actually navigate or change URL and send messages to the opener window. Then there is a concept of pop-up blocking, which you also have witnessed that in the very start when I tried to run this very code, actually my browser blocked that. But when I allowed that pop-up to be opened, it then after that opened this google.com website. Now in the past, there were evil sites abusing pop-ups a lot. Now, a bad page could open tons of pop up windows with ads. So, now most browsers try to block pop ups and protect the user, which you have also witnessed in the very beginning. Now, actually, most browser block pop-ups if they are called outside of the user trigger event handler, like for example on click. So if you have, let's just say button dot on click, and you make it equal to an arrow function, and inside that you just write in window dot open and you write in the name of the website. So this way basically the user are somewhat protected from unwanted pop-ups, but the functionality is not disabled totally. So what you have here is that you have to now actually click a button before this website, that is google.com, is actually open. In the first case, it directly open as soon as you refresh this index.html inside your browser. But now it actually requires a button for you, which you have to click in case of that pop-up to actually appear. Now let me just show you a site which is actually an online movie watch site. Now you can see that there are a lot of things happening here. You can see that if I click on the scroll down key, you can see that it has actually opened a pop-up. Now, why this pop-up has been opened when I click on this scroll bar? Now, there is a reason behind that which we are going to cover in the very soon. So I hope that for now you have understood what is a pop-up and how actually pop-ups are blocked and how you can actually control them using certain buttons or something else. So now let's just move on here and let's just talk about the syntax of this window.open in a bit detail. So basically this window.open comes with certain parameters. For now you have only studied that we entered a URL. Now it can have more parameters like names and certain other params. Now URL is what you have witnessed, that is a URL to load into the new window. Then the second parameter which you can specify in the window.open is the name. Now the name is actually what you have to specify for the new window. Now each window has a window.name. And here we are going to specify which window to use for the pop-up. If there is already a window with such name, then the given URL opens in it, otherwise a new window is going to be opened. And in the third parameter, that is actually the configuration string for the new window. Now it contains settings delimited by a comma. So there must be no spaces in the third parameter. For instance, if you want to have, let's just say, specify the width and height, then you can just write in width equal to 200, a comma, and height equal to 100. You have to specify no spaces between the params so that it recognize it as a single parameter. Now there are certain settings which you have to specify for the third parameter. The first one is the position. Now in the position you have two things. The first one is the left or top, that is the numeric positioning. Now in the left or top coordinates of the window, it includes the top or the left corner or on the screen. Now there is a limitation, that is a new window cannot be positioned off screen. The second positioning element is regarding the width or height, which is also a numeric value. That is to specify the width and height of a new window. Now, there is a limit on minimal width and height, so it's impossible to create an invisible window. Then after the position settings, we have the settings for the window features for this third parameter as well, which includes certain things. The first one is the menu bar, that is a yes or no value that shows or hides the browser menu on the new window. The second Windows feature is the toolbar, which is again a yes or no thing that shows or hides the browser navigation bar on the new window. The third thing is the location, that is again a yes or no thing that shows or hides the URL field in the new window. FF and IE don't allow to hide it by default. The fourth thing in the Windows feature is the status. That is again a yes or no thing that shows or hides the status bar. Again, most browser forces to show. And we have resizable, that also it has a yes or no values, which allows to disable the resize for the new window, which is actually not recommended. And finally, the last Windows feature is the scroll bars, which is a yes or no values that allows to disable the scroll bars for the new window, which is again not recommended. So I hope that you have understood the complete syntax for window.open and also understood the parameters which are a part of this windows.open and also the settings which we have just discussed for the third parameter, that is the params. So let's just cover this with the help of an example where what we are going to do is that at the very top here, we are going to have let params and make it equal to use the forward text, and we are going to write in, let's just say, scroll bars, which as I told you has a yes or no value. So let's just say we want to make it no, then we have the resizable, which let's just say we also want to make it no, then we have the status, which we also want to make as no, then we have the location, which we also want to make as no. Then after that, we have the it is going to be equal to no, not comma no. After that, a comma, and then we are going to have the toolbar as no, and finally, we are going to have the menu bar as no. So these are the things which we have specified for the third parameter. Now, let's just add some more here. But we are not going to specify it here. We are going to specify it inside. We don't need this comma here. And right here, we are, let's just say, going to specify the width as 0. We are going to specify the height as 0. We are going to specify the left as -1,000,000. And we are going to specify finally the top as -1,000,000. So as you have seen here that most the window features are disabled and the window is actually going to be positioned off screen. So right here, if you have window.open and you write in here, let's just say that we want to specify the name to be test, and in the third parameter we are going to specify the params, and we will just remove this from here. So if you save this page and refresh your browser here, you're going to see that you have got a page which is actually positioned off a screen. So if, as you can see, what really happened is that most browser fix or things which include like width or height. Now width and height cannot be 0 for instance, and the off screen which is left or top. Now here we have specified the left and top to be -1,100, -1,000, which is actually not possible because it is actually going to position your window off screen, which is actually not possible. So what your browser is going to do is that it is going to actually fix those issues for you. So for instance, Chrome opens such a window with full width or height so that it occupies the full screen, which you have seen right over here as well. You can see that it occupies the entire screen from top to the bottom. So I hope that you have understood that. So now let's add normal positioning options and reasonable width, height, and the left and top coordinates here. So right here, we are going to specify, let's just say that we specify the width to be 600. We specify a reasonable height, which let's just say is 300. And let's just say that we want to specify the left as 100, and we are going to specify the top as 100 here as well. So if you now save this page and you refresh your browser, you can see that now you have got a page which has the position which you have actually specified. It is from left it is 100, from top it is 100 pixels, and it has a width of 600 and it has a height of 300. So most browser actually show the example here as required. Now there are rules for omitted settings as well. The first rule is that if there is no third argument in the open call or it is empty, then the default window parameters are used. The second rule is that if there is a string of params but some yes or no features are omitted, then the omitted features assumed to have no value. So if you specify params, make sure you explicitly set all the required features to yes. The third rule is that if there is no left or top in the params, then the browser tries to open a new window near the last opened window. And the last rule is that if there is no width or height, then the new window will be the same size as the last open window. So I hope that you have understood the syntax of windows.open completely. So for this tutorial, I guess that is it. In the next tutorial, we are going to talk more about pop-ups. So thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course where we are talking about pop-ups and window methods. In this tutorial, we are going to see how to access a pop-up from a window. Now the open call actually returns a reference to the new window as you have seen. Now it can be used to manipulate its property, change location, and even more. So what we are going to do is that we are going to generate a pop-up content from a JavaScript. So in this example, what we are going to do is that we are going to have let new window that is going to be opened is going to be equal to window dot open, and in the parameters we are going to specify about colon blank. The second parameter is going to be hello, which is actually the name, and the third parameter are the params where we are going to specify the width as 200, and we are going to specify the height as 200 as well. So right here, what we are going to do is that we are going to write a new window dot document dot write, and what we are going to write inside that window is basically going to be hello world. So if you save this page and refresh your browser here, you can see that you have got a new window that says hello world. So basically we have actually created an about blank window with the name hello, and we have specified a width and height for that, and inside that we have actually written hello world. Now, what we are discussing here is how to access a pop-up from a window. So what we are going to do here is that we will modify the contents after loading the window. Now, to do that, what we are going to do is that we will just remove this from here. And right here, we are going to change its name to example. The width and height are going to remain the same. And after that, we are going to write a new window dot focus. So we are going to call in the focus method on the new window. And after that, if you write an alert and you write in the new window dot location, not local storage, but the location dot the href. So we will just remove this from here. And if you save this now and refresh your browser, you can see that you have got this page. Now this is actually where actually the loading hasn't started yet. So you can see that it says about blank, which means that the loading has yet not started. Now to load, what you are going to do is that we will just remove this from here. We don't need this alert statement. And right here, we are going to write a new window dot onload, that whenever this new window is loaded, we want to call in a function, and inside this function, what we are going to do is that we are going to make let html is going to equal to div, and these are going to be the closing tags for the div. Now inside this div, what we are going to do is that we are going to specify the style, which is going to be the font size, which is going to be 30 pixels. And inside this div, we are going to simply write in welcome. So after this, what we are going to do is that we are going to write a new window dot document dot body dot insert adjacent html, and it is going to be after begin. We want to insert whatever we have in the html part. So if you run your code, you're going to see that you have the same output. But what you can do here is that if you have the alert statement back, and now you refresh your browser and click outside it, you can see that it still says about blank, which means that the loading hasn't started yet. So immediately after window.open, the new window isn't loaded yet. Now that is demonstrated by the alert statement right in front of you. So you have to actually wait for the onload to modify it. Now we could use the DOM content loaded handler for new win.document as well. So this was how we can access a pop-up from a window. Now we are going to see how to access a window from a pop-up. Now a pop-up may access the opener window as well as using the window.opener reference. It is null for all windows except pop-ups. So if you have an example that looks something like this, where you have this as about colon blank, and right here you have hello, and you have this width and height at 300, and after that you can have new win dot document dot write, to have a dot here, dot write, and inside that you can have a script where you can have something like this script, the closing tags for the script, and right in here you can have window dot opener dot document dot body dot inner html. And what you're going to do is that you are going to make this equal to test. So actually the connection between the windows is now bidirectional. The main window and the pop-up have a reference to each other now. So let's just close this window and refresh this. So you can see that you have got a blank window, but if you just move down here, you can see that you have this test right over here printed as well, which means that now we have a connection between the main window and the pop-up which has this blank window which has appeared here. So you can clearly see that you have got both of these here. You can see that you have got this pop-up as well as you have got this main window that says test. So that's how you can access the window from your pop-up. So I hope that you have understood these two concepts, accessing pop-up from window and accessing window from pop-up. So in the next tutorial, we are going to discuss more about pop-ups. So for this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course, and in this tutorial we are again going to be talking about pop-ups and window methods. And in this tutorial we are going to see how to close a pop-up. Now to close a window you have the method that is window.close. To check if a window is closed you can have the win.closed. You can check it for either true or false. So technically the close method is available for any window, but window.close method is ignored by most browser if window is not created with window.open. So it will work only as a pop-up. Now the close property is true if the window is closed. That is useful to check if the pop-up is still open or not. Now a user can close it anytime and our code should take the possibility into account. So right in front of you, you have your new window, and what I want to do is that on load, what I want to do is that I want to make this new win dot close. So I want to call in the close function, and after that I'm going to simply alert new win dot close, which is the thing that is going to return either true or false. So since we have called the close function, so this over here is actually going to return true. So after that, what we are going to study is some functions. So the first functions which we are going to talk about are the functions for moving or resizing a window. Now in that we have got four functions. The first one is window.moveBy with two parameters x and y. Now it is going to move the window relative to current position x pixels to the right and y pixels down, whereas negative values are also allowed for this function. The second function is the window.moveTo with two parameters x and y, which move the window to the coordinates xy on the screen. Then we have got the resize by and resize to function. In the resize by, we have to resize the window by the given width or height relative to the current size. whereas negative values are also allowed. And in the resize too, we resize the window to the given size in the parameter respective to the width and height. Now there is also a window dot on resize event as well. Now, to prevent abuse, the browser usually block these methods. They only work reliably on pop-ups that we open that have no additional tabs. Now, JavaScript has no way to minify or maximize a window. These OS level functions are hidden from front-end developers. Move or resize method do not work for maximized or minimized windows. Then we have got functions for scrolling a window, in which we have got four functions. The first one is the win.scroll by with two parameters x and y. It scroll the window x pixels right and y down relative to the current scroll. Negative values are also allowed in that. The second one is the win.scroll to that scroll the window to the given coordinates. Then we have the element.scroll into view where a top equal to true. Now in this function, it scroll the window to make the element show up at the top or at the bottom for element dot scroll into view false. That is now there is also a window dot on scroll event as well. Now the last method is the focus or blur on a window, where we have the window dot on blur equal to window dot focus. Now theoretically there are window dot focus and window dot blur methods to focus or on focus on a window. And there are also focus or blur even that allow to catch the moment when the visitor focuses on a window and switches elsewhere. Now, although in practice they are severely needed because in the past evil pages abused them. So when a user attempts to switch out of the window, it brings the window back into the focus. The intention is to lock the user within the window. So whenever the on blur is performed, it is actually going to call in the window.focus. So the lock is actually at the window and the user always stays at the window. So browser had to introduce many limitations to forbid the code like that and protect the user from ads and evil pages. Now it depends on browser to browser. For instance, a mobile browser usually ignores the window.focus completely. Also, focusing does not work when a pop up opens in a separate tab rather than a new window. Still, there are some use cases when such calls do work and can be useful. For instance, when we open a pop up, it might be a good idea to run the new window.focus on it. Just in case for some OS or browser combinations, it ensures that the user is in the new window now. Secondly, if we want to track when a visitor actually uses our web page, we can track the window.onFocus or onBlur. Now, this is going to allow us to suspend or resume in-page activities, animations, etc. But please note that the blur event means that the visitor switched out from the window, but they still may observe it. The window is in the background, but still may be visible. So this is all we have to talk about pop-ups and window methods in JavaScript. So what we have studied in the previous two and in this tutorial is that pop-up windows are used rarely as they are alternatives for loading and displaying information in page or in the iframe. If we are going to open a pop-up, a good practice is to inform the user about it. An opening window icon near a link or button would allow the visitor to survive the focus shift and keep both windows in mind. A pop-up can be changed by the open call. It returns the reference to the newly opened window. Now, browser block opens call from the code outside of user action. Usually, a notification appears so that a user may allow them. Now, browser open a new tab by default, but if sizes are provided, then it is going to be a pop-up window. Pop-ups may access the opener window using the window.opener property, and the main window and the pop-up can freely read and modify each other if they are having the same origin. Otherwise, they can change the location of each other and exchange messages. Now to close the pop-up, we have the close method call, which we have covered. Also, the user may close them just like in any other window by clicking the cross button. The window.close is true after that. Then we studied about the methods focus and blur that allow to focus or unfocus a window, but they don't work all the time. Events like focus and blur allow to track switching in and out of the window, but please note that a window still may be visible even in the background state after the blur has performed. So that was all we have to study about pop-up and window methods. So I hope that you have understood all about that. In the next tutorial, we are going to talk about what is a cross-window communication. So stay tuned for that tutorial. Thank you so much for now. Bye bye. Hey guys, what's up? I welcome you to another tutorial on frames and windows. And in this tutorial, we are going to talk about cross-window communication. Now, the same origin or the same site policy limit access of windows and frames to each other. The idea is that if a user has two pages open, one from johnsmith.com and another one is gmail.com, then they would not want a script for johnsmith.com to read all our mails from gmail.com. So the purpose of the same origin policy is to protect user from information theft. Now, two URLs are said to have the same origin if they have the same protocol, they have the same domain, and they have the same port. So let's just say that you have a website which is something like this. It is http colon and it is site.com. And after that, we have a site that is http colon and it is site.com slash. And after that, we have a site that is http colon site.com slash my slash page dot html. Now, actually, these URLs all share the same origin that is site.com has. But what we have is that if we add a www with it and make it http www.site.com, and this one, let's just make it equal to site.org, and let's just say that we add a https here and made this equal to site.com but with https, and after that let's just say that I copy this from here and let's just say that I have site.com here, and right here I specified port number 8080. So now these URLs actually do not share the same origin because for the first one we have another domain where www matter. For the second one we have another domain that is the org. For the third one we have another protocol that is the https protocol, and for the last one, we have another port number that is 8080. So the same origin policy states two things. The first one is that if we have a reference to another window, for example, a pop-up created by window.open or a window inside iframe, and that window comes from the same origin, then we have full access to that window. The second policy state otherwise. If it comes from another origin, then we cannot access the contents of that window, variables, documents, or anything. The only exception is the location. We can change it, thus redirecting the user, but we cannot read the location, so we can't see where the user is now, which means no information leak. So I hope that you have understood the concept of what is same origin and why for the same origin you have to have the same protocol, domain, and port. Now let's just see the iframe in action. Now an iframe tag hosts a separate embedded window with its own separate document and window objects. So we can access them using properties like iframe.content_window, iframe.content_document. Now the iframe.content window is to get the window inside the iframe, whereas the iframe.content document is to get the document inside the iframe. Shorthand for the iframe.content window.document. So when we access something inside the embedded window, the browser checks if the iframe has the same origin. If that's not so, then the access is going to be denied. Writing to the location is an exception, it's still permitted. For instance, if you try reading and writing to the iframe from another origin, then it is something that is actually not allowed. So let's just see this with the help of a very simple example. So let's just say that in the HTML part right here, you have an iframe, and the source for that iframe is, let's just say, https colon and it is example.com. So you have this very simple website here, and we are going to specify an ID, and the ID is going to be iframe in this case. So we will just save this and move back to our script folder. And inside this script folder, we are going to write in iframe.onload is going to call a function. And inside that function, the first thing which we are going to do is that we have to get the reference to the inner window. Now, if you want to get the reference to the inner window, then that is something that is actually allowed. So if you have here, let iframe window equal to iframe dot content window, then this is actually something that is allowed. Now, as I told you that we can access the property using iframe.content window and the iframe.content document. Now, iframe.content window, as I told you, is to get the window inside the iframe. So that is something that is actually allowed. So if you run the iframe window, it is actually going to return true. But if you have, let's just say, let's just write it in the try and catch blocks. So in the try block, if you write in let document equal to iframe dot content, and you want to access the documents, then that is something not allowed. So you have the you can get the reference to the inner window, but not to the document inside it. So you are getting the reference to the inner window using the content window, which is allowed, but you cannot actually get a reference to the documents inside that iframe, that is example.com in this case. So that is something that is not allowed, and it is going to get caught in this exception here where we have catch E, and inside that it is actually going to alert E. So if you run this, what it is going to do is that it is going to generate a security error that is going to tell you that you are trying to access a document that is from another origin. Also, we cannot read the URL of the page in the iframe. So if you have, let's just copy this try and catch block from here, and let's just paste it again. So right here, if you want to access the URL of the page using the content window dot location dot href, then that is actually something that is also not allowed because it is again a security error. Now we can write into the location and thus loading something else into the iframe, that is something that is allowed. So you can actually not get the href, but what you can have is, if you just copy this from here and paste it over here. So if you remove this href from here, so as I told you that we can write into the location and thus loading something else into the frame. So content window dot location is something that is allowed. So this is going to be actually okay. And you are going to actually make it equal to a backslash, which means that you can write into the location. And if you write in iframe dot onload equal to null, then what it is going to do is that it is going to clear the handler, not to run it after the location is going to change. So this code is going to show error for any operation except getting the reference to the inner window where we have iframe dot content window that is allowed. And secondly, to write to a location using this. So we don't have to specify this here. So this is basically writing to a reference. So this is also writing to a location, which is also allowed. But these two things which we have here, trying to access the URL or trying to access the document of a reference, then that is something that is allowed. Now, contrary to that, if the iframe has the same origin, then we can actually do anything with it. So right here in the, we will just save this, and if you go here and in place of example.com, if you just write in backslash, which means that we are talking about the same origin now, which means the same website, then you can actually do whatever you want to do here. So this statement over here is also going to execute, and this statement is also going to get executed then. So the iframe.onload versus iframe.content-window.onload has certain things. The iframe.onload event is essentially the same as the iframe.content-window.onload. It triggers when the embedded window fully loads with all resources, but we cannot access iframe.content-window.onload for an iframe from another location, so using iframe.onload. So I hope that you have understood what we have covered so far. So we are going to talk more about it, but we are going to do that in the next tutorial. For this tutorial, that is it. Thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course where we are talking about cross-window communication. In this tutorial, we are going to talk about windows on subdomains. Now, by definition, two URLs with different domains have different origins as well. But if windows share the same second level domain, for instance, john.site.com, peter.site.com, and site.com, so that their common second level domain is site.com, we can make the browser ignore that difference so that they can be treated as coming from the same origin for the purpose of cross-window communication. Now, to make it work, each such window should run the code that looks something like this, where we have document.domain, and that is going to equal to sites.com. So all the windows should actually run this, and that is going to be it. They can interact without limitation. Again, that's only possible for pages with the same second level domain. The document.domain property is in the process of being removed from the specification. The cross-window messaging, as explained, is the suggested replacement. That said, as of now, all browsers support it, and the support will be kept for the future, not to break the old code that relies on document.domain, but for the rest, it is going to be replaced with the cross-window messaging. So the next thing which we are going to cover is the wrong document pitfall for the iframe. Now, when an iframe comes from the same origin and we may access its document, there is a pitfall. It is not related to cross-origin thing, but important to know. Upon its creation, an iframe immediately has a document, but that document is different from the one that loads into it. So if we do something immediately with the document, that will probably be lost. So let's just say that right here in the index.html, we have an iframe which has the source this, and we are going to specify an ID for this form as iframe. And right inside the script file, what we are going to do is that we are going to have let old document is going to equal to iframe dot content document. So right here, iframe dot onload is going to call upon a function, and inside that function we are going to have, it is going to be on load. So inside this function we are going to create let new document equal to iframe dot content document. So after that, if we try to write in old doc equal to new doc, then it is going to actually generate false because the loaded document is not the same as the initial. So if you have alert and write that you can write an old doc equal to the new doc, then it is actually going to return false, as I told you that the new document and the old document are not the same. Now we shouldn't work with the document of a not yet loaded iframe because that's the wrong document. If we set any event handlers to it, then those event handlers are going to get ignored. Now the question is how to detect the moment when the document is there. The right document is definitely at place when the iframe.onload triggers, but it only triggers when the whole iframe with all resources is loaded. So we can try to catch the moment earlier using checks in the interval. So right here, and after this, what you can have is that you can actually have a timer where you can have let timer equal to set interval, and inside that you are going to have an arrow function. Now inside that function, what you are going to do that you are going to do what you have done here. So you will just remove this from here, you are going to paste it here, we will just remove it from here. So now if you have iframe dot document equal to iframe dot content window, and right here you're not going to directly output that, you're going to write an if, and inside the condition you are going to specify this. So we will just remove it from here and we are going to paste it here. So if old document and new document are same, you are going to simply return out of this interval function, and after that you are going to alert that the new document is here. And what you are going to do is that you are going to have the clear interval of the timer. So it is going to cancel this time interval and we are not going to need it anymore. So right here, you're going to specify the time that is going to be 100 millisecond. So what that is going to do is that for every 100 millisecond, it is going to check if the document is the new one or not. Now for this, if you save this and refresh your window, you can see that it says the new document is here. So it is going to check it after every 100 millisecond. Now if you run that previous code we had, where we have alerted old document equal to new doc, that is going to return false because we had not specified intervals and the new documents, loaded document, is not yet equal to the same initial document. But right here, since we are waiting for the new document to get loaded, and after that, after it has loaded, the new doc is then going to equal to the old doc. So now we are going to talk about the window.frames collection. Now, an alternative way to get a window object for iframe is to get it from the named collection from windows.frame. Now you can get it by number using window.frames and using array-like concept by specifying 0 or 1 or something like that, which is going to treat the window object for the first frame in the document. And by name, you can write in window.frames dot, and after that, you can specify the iframe name. So that is the window object for the frame with the name equal to iframe name. For instance, if you have an iframe here, and right here you are going to specify some style, just add a space here, and right here in the style tag, you are going to specify the height as 80 pixels, and you are going to specify the name here, which is going to be 1, and we are going to specify the ID as iframe. And in the script, we are going to have alert. So if you write in iframe dot content window and you make it equal to the frame 0, then this statement over here is going to return true. And after that, if you write an alert iframe dot content window and make it equal to frames dot when, then this statement over here is also going to return true. So an iframe may have other iframes inside. Now the corresponding window objects form a hierarchy. So there are three navigation links that include the window.frames, that is the collection of children windows, window.parents, that is reference to the parent window, and window.top, that is the reference to the topmost parent window. So for instance, if you write in, let's just say window.frames 0 dot parent and triple equal to the window, then that is actually going to return true. So we can use the top property to check if the current document is opened inside an iframe or not. So for that, it has a simple thing where you can write in window equal to top. If window equal to top, what you are going to do is that you are going to alert simply that the script is in the topmost window. Just ignore my spelling mistakes, and right here in the else condition, in the else you can simply alert that the script runs in a frame. So that's how you can use the top property to check if the current document is open inside a frame or not. So that is it with this tutorial. In the next tutorial, we are going to talk more about cross-window communication. So thank you so much guys for watching, and I will see you guys in the next tutorial. Hey guys, what's up? I welcome you to another tutorial on this course where we are talking about cross-window communication. In this tutorial, we are going to talk about the sandbox iframe attribute. Now, the sandbox attribute allows for the exclusion of certain action inside an iframe in order to prevent it executing untrusted code. Now, it actually sandboxes the iframe by treating it as coming from another origin and applying other limitation. Now, there is a default set of restrictions that are applied for the iframe sandbox SRC, but it can be relaxed if we provide a space separated list of restrictions that should not be applied as a value of the attribute. Now, in other words, an empty sandbox attribute puts the strictest limitation possible, but we can put a space delimited list of those that we want to left. So basically, these are some of the limitations which we have. The first one is the allow same origin. Now, by default, the sandbox forces the different origin policy for the iframe. In other words, it makes the browser to treat the iframe as coming from another origin, even if its source points to the same site. With all implied restrictions for a strip, this option removes that feature. Now, the second one is the allow top navigation. Now, it allows the iframe to actually change the parent location. The third one is the allow forms that allow to submit forms from the iframe. The next one is the allow scripts that allow to that allow to run scripts from the iframe, and the last one is the allow pop-ups that allows to window.open pop-ups from the iframe. So the next thing which we are going to talk about is the cross-window messaging. Now the post message interface allows windows to talk to each other no matter which origin they are from. So it's a way around the same origin policy. It allows a window from johnsmith.com to talk to gmail.com and exchange information, and but only if they both agree and call corresponding JavaScript functions. So that is actually to make it safe for users. So the interface has actually two parts. The first one is the post message. That now the window that wants to send a message calls a post message method of the receiving window. In other words, if we want to send the message to a window, we should call the window.post message function, which has two parameters that are the data and the target origin. Now the first parameter, that is data, let me just write in here the syntax. It is actually like when dot post and capital message, and after that it has the first parameter as data, and the second parameter is the target value, not the target value but the target origin. Now, the first parameter is the data to send. Now, it can be an object. The data is actually cloned using the structured serialization algorithm. So, integrated environment supports only strings, so we should join json.string stringify complex objects to support the browser. Now, the second parameter is the target origin. It specifies the origin for the target window set so that only a window from the given origin will get the message. Now, the target origin is a safety measure. Remember, if the target window comes from another origin, so actually, in that case, we are not allowed to read its location in the sender window. So we can't be sure which site is opened in the intended window right now. That is, the user could navigate away and the sender window has no idea about it. So specifying the target origin ensures that the window only receives the data if it's still at the right site. So it is important when the data is actually sensitive and you don't want someone else to actually read your data. For instance, if we just cover this with the help of an example, so let's just say that right down here you have an iframe which is having the source here as http colon, and it is something like example.com. So the ID, we don't need an ID here. We will just specify the name, and the name is going to be example in this case. Now in the script file, what we are going to do is that we are actually going to use the post message function. Now that is actually the site which is actually sending the data. So right here, we are going to write in let window equal to window dot frames dot example. So we are talking about frames dot example, and right here we are going to write in window dot post message. So the message which we want to post is this simple message text, that is the data to send, and the second parameter is going to be the site where you actually want to send in this data. So in our case, that is going to be example.com. Now, if we don't want that check, we can actually set the target origin to a steric. So right here, if you don't want this, you can actually have a steric here. Now that is the post message, that is actually performed at the area, that is the window that wants to send a message. Now if you have sent a message, you want someone to receive that as well. So to receive a message, we have the second part of this tutorial about the cross window messaging, that is the on message function. To receive a function, basically the target window should have a handler on the message event. So it is going to trigger when the post message is called and the target origin check is successful. So the event object has actually some special properties. The first one is the data that is from the post message which has been actually sent over. The second one is the origin of the sender. For instance, in our case, it is example.com. And then the third thing is the source, that is the reference to the sender window. So we can immediately have source.postMessage back if we want. Now to assign that handler, we should use the add event listener. Now a short syntax window.onMessage does not work. So as an example, if right down here you have, let's just say, another HTML file that is index.iframe.html, that is actually the receiving iframe. So in that you can have window.add event listener, and in that you have to write in the message, and you have to write in a function that is going to actually receive an event, and inside that what you are going to do is that you are going to write an if event dot the origin is not equal to, we have the http example.com. So if it is not equal to the example.com, then what we want is that we want to actually ignore it. So since it is from another domain, so we will just write in return, which means that we are actually ignoring it. And after that, we can simply alert. We can alert that received. Now that is basically the case where this if condition is not true, because if this if condition is true, it is actually going to simply return, it is not going to execute this statement. But if this statement is wrong, which means that if the origin is http.example.com, so we want to have an event listener that is going to say received, and we are going to write an event dot data. So that is going to be it, which means that can message back using event.source.post message is even accessible now. So right here, you can also send a message back to from where your message has come, that is http example.com. So I hope that you have understood what we have covered here. To summarize what we have covered in the previous two and this tutorial is that to call methods and access the contents of another window, we should have a reference to it. For pop-ups, we have these references that includes window.open and window.opener. Now for iframes, we can access the parent or children window using the windows.frames, window.parent, window.top, and iframe.content window, which is the window inside an iframe tag. Now, if windows share the same origin, then the windows can do whatever they want to with each other. Otherwise, the only possible actions are to change the location of another window, that is the write-only access, and post a message to it. Now, there are certain exceptions that windows that share the same second level domain, like a.site.com and b.site.com, then setting document.domain equal to site.com in both of them puts them into the same origin state. And secondly, the second exception is that if an iframe has a sandbox attribute, it is forcefully put into the different origin state unless the allow same origin is specified in the attribute value. That can be used to run untrusted code in the iframes from the same site. And finally, we talked about the post message interface that allow two windows with any origins to talk. The sender call the target window.post message. If the target origin is not static, then the browser checks if window target win has the origin that is the target origin, that is the second parameter for the post message. If it is so, then the target window triggers the message event with special properties that are the origin, the source, and the data. And we should use the add event listener to set the handler for this event inside the target window. So I hope that you have understood all about cross-window communication. So that was it with this tutorial as well. Thank you so much guys for watching, and I will see you guys later.